Okay, welcome to this video where we're going to be having a look at all of the topics that haven't yet appeared from paper 1. Of course, it is important to note that just because topics appeared on paper 1, it doesn't mean that they can't then reappear on paper 2, although it is quite unlikely in some circumstances. For example, a frequency polygon, if that appeared on paper 1, it's quite unlikely that you would see another frequency polygon on papers 2 and 3. Obviously some topics are more than likely to appear, things like laws of indices, which did appear on paper 1 for some of the exam boards, that could still appear in some form or another on papers 2 and 3. So it is important to obviously take note of that, but we will be looking over pretty much all of the topics that didn't appear on paper 1. Now before we get started, I'm just going to show you what is now included inside the TGMT Upgrade Hub. So when you are logged in now, you'll see that there is a new tab at the top that says Paper 2. Now if we click into Paper 2, you'll see that there are a couple of extra tabs here with some bespoke quizzes and the checklist that I had on the screen. So you can get access to the checklist to keep track of everything that you're doing, and you can also access the bespoke quiz for your exam board. So if I click into the Edexcel quiz, on here you will be able to practice questions from every topic that hasn't yet appeared. So you can see here on page 1 of the quiz we've got things like highest common factor, lowest common multiple and products of prime factors. And you've also got some things like standard form conversions and calculations. Now obviously that's just page 1, you can carry on and work through each individual unit. Once you've completed each of the units within the quiz, you will be emailed a full report that tells you exactly what you need to work on and everything that you already know. So you can really simplify your revision and get rid of any wasted time leading up to this crucial next paper. So there we go, that's worth checking out. All the links are in the description, but we've got a lot to get through, so let's get started. So write 180 as a product of prime factors and give your answer in index form. So we can do our nice little prime factor tree. And again, thinking of any two numbers that times to make 180. So I'm going to go for 18 and 10. 10 becomes 2 and 5, locking off those numbers when we see that they're prime. 18 is 2 and 9, and 9 is 3 and 3. And again, locking those all off when they're prime. Remembering you can write down some of the prime numbers if it helps. Now writing these in size order, we get 2 times 2 times 3 times 3 times 5, and then we can simplify these. So 2 times 2 becomes 2 squared, 3 times 3 becomes times 3 squared, and then times 5 at the end, and that's in index form there using indices. Okay, so there are 15 pencils in a pack and 40 pens in a box. How many packs of pencils and boxes of pens would we need to buy to have the same amount of each? So we're looking at lowest common multiple, so 15 and 40. I'm going to do a list of their times tables, so 15, 30, 45, 60, 75, 90, 105, 120. And there it is. I know that 40, 80, 120, that's going to be our lowest common multiple there. So the question said how many packs of each, so that is 1 on the top. We've got 1, 2, 3, 4, 5, 6, 7, 8. That was the pencils, so that's 8 packs of pencils. 8 packs of pencils. And below there we have 1, 2, 3 boxes of pens. Okay, so just remember to read the question there, what's it actually asking for in the final step, even though we were looking at lowest common multiple for that one. Let's have a look at the next one. So find the highest common factor of 72 and 90. So we've got different methods of doing this. We can write down 72, we can write down 90 and start finding all their factors. We can of course use the prime factor method, but let's have a look. Let's start with 90. 1 and 90, 2 and 45, 3 and 30. Let's see what else goes in. 4 doesn't go in, 5 does. 5 goes in 18 times. 6 goes in, let's have a think, 15 times. 7 doesn't, 8 doesn't, 9 does. 9 and 10, now the numbers are right next to each other, so there's no more to look at. So starting with the biggest, let's have a look which one goes in. 90 doesn't, 45 doesn't, 30 doesn't go into 72, does 18. 18 actually goes in 4 times. So 4 times 18 We don't have to do all the factors of 72 there because we've spotted that it's 18. Of course, we could use the prime factor method to find the highest common factor, which I'd recommend for numbers like this, so 72 and 90. Do their prime factors, so 8 and 9, 3 and 3, 2 and 4, 2 and 2. 90 is 9 and 10. And then we have 3, 3, 2 and 5. And we can have a look at what's in both. So they both have a 2. They both have a 3, so times 3. They both have another 3. And that's all that they share. 2 times 3 is 6, times 3 again is 18. So we can get our highest common factor using our prime factor method as well. Okay, so on the number line, show this inequality. So when we're drawing these sorts of things on a number line, we look at what numbers we've got. We're going to put our little circles above those, so -2 and 4. And we're going to join them up. And then we just need to have a look at these symbols. So the 1 here, which is less than or equal to, or pointing towards that less than or equal to, it has more ink on it, so we just remember to colour that one in. Make sure the circle has more ink in there as well. Nice little way of remembering it. There we go. So that is between -2 and 4. Remembering that is equal to -2. So the numbers that this could be is we could have -2, -1, 0, 1, 2, and 3, but not including the 4 there because it says less than 4. So you can have an inequality like this as well, where it just says x is greater than or equal to 1. So again, putting our circle above the 1, the greater than or equal to has the extra ink on it, so we'll colour that one in. It's equal to that as well, and greater than 1, so we'll just point an arrow to the right saying it's got to be greater than 1. And that's that for that type of inequality. Right, so a washing machine costs £640 plus 20% VAT. James pays a £68 deposit and the rest in 10 equal monthly instalments. Work out the cost of each monthly payment. So it's a percentage of an amount question, so we need to work out 20% of 640. 10% is the most important percentage we ever have to work out, so we can work out everything from there. So we'll work out 10%. 10% is £64. 20% will be double that. So double that is £128, so that's the extra amount he's got to pay for VAT. So if we add these together, 640, add 128, we get £768. Now it says he's going to pay a £68 deposit, so let's take that £68 off because that's what he pays right at the start, and that leaves us with £700. Now it says in the question he's going to pay that in 10 equal monthly instalments. So if we finish this off, if we divide this by 10, so 700 divided by 10 tells us that he's going to pay £70 per month. There you go. So the main part here was the working out the percentage. So always work out 10%, and remember from there you can figure out any percentage. We could have halved 10%, we could have got 5% as 32, or we could have actually divided it by 10, we could have got 1%. Dividing 64 by 10, 1% would have been £6.40, and we could have built that up to any percentage that we wanted from there, so £6.40. Let's have a look at something else. So £800 is invested for 2 years, offering a 1.5% simple interest rate per annum per year. How much is in the account after 2 years? Now, simple interest means it doesn't keep accumulating. So if we first work out what 1.5% is, again, if you haven't got a calculator, we can do this non-calculator. So 10% of 800 would be 80. 1% would therefore be 8, and 0.5%, which we're going to need there, is 4. So joining those two together, the 1 and the 1.5 gives us 12. So we get £12 there for our 1.5%. Now we can do this using a calculator as well, which I'll discuss in a sec, but if we're going to get £12 per year, simple interest just means that's what we're going to get per year. So if it's 2 years, we'll times that by 2, and we will get £24. So that's the amount of interest we'll earn. It does say how much is in the account though, so if we add that back into the account, we'd have £824 as our final answer. Now if you've got a calculator here, you can always use your multiplier method. So we could do 800 and we could times it by 1.015, and that gives us the answer 812, telling us that in that first year there we've earned £12 interest. So adding in another 12, so add another 12 would give us 824, the same answer. Okay, or you could times it by 0.015, and that would have just straight up given you the 12, and you can add that on for however many years for simple interest. When it comes to this sort of question, Emily invests £150,000 in a savings account offering a compound interest rate of 2.4% per annum per year for 4 years. Work out the amount of interest that she earns. So I'm just going to underline that, the amount of interest, so a slightly different part of the question here. So compound interest does keep accumulating, so she earns more in the second year, more in the third year and the fourth year, but we can take a very similar approach. We do 150,000 times it by 1.024 for 2.4%, and rather than finding out what that is and repeating myself, I'm going to do it to the power of 4, and that'll just keep timesing it by 1.024, adding on that 2.4% every year. And if we type that into a calculator, 150,000 times 1.024 to the power of 4, we get the answer £164,926.74 to the nearest penny. Now, just being careful on this question because it does say how much interest does this person earn, does Emily earn, so we're going to want to subtract that original 150,000, so take away the 150,000 for this particular one, and that gives us 14,926 pounds and 74p again to the nearest penny. So there's a bit of compound interest, just remembering this multiplier here and how that works with compound interest, not forgetting the 0 there, and putting, because if we were to put 1.24, that would increase it by 24%, so we don't want that one there. So Mary buys a car for £4,000. Each year it depreciates by 20%. Work out the value of the car in 3 years. So that word depreciate means it falls in value. Now again, with depreciation, it's similar to compound interest. It falls in value, but it falls in value based on its new price. So if we do this without a calculator, we can do it both ways. Year 1, the £4,000 is what it's worth. 20% of that we can work out. 10% is 400, 20% is 800. And if we take away that 800 there, so 4,000, take away 800, we end up with 3,200. So we don't keep losing £800 a year. Now in the second year, it's worth 3,200. 10% of that is 320. 20% of that is double that, 640. And we could subtract 640. So 3,200, take away 640. Will leave us with our answer for the final year. Take away 640 there, gives us 2,560. And we can finish this off, or I should have said year 2, we can finish this off on year 3. So our value is 2,560. 10% of that is 256. So 20% will be 512, and then we can subtract 512, so 2,560, take away 512, leaves us with a final value there of 2,048. £2,048, and that'd be our final answer. Again, we could do this with a calculator. If something loses 20% in value, then it's only actually worth 80% of its cost the previous year. So if it's worth 80%, the decimal that I can use for 80% is 0.8. If it's losing value, we won't want a 1 point number there, we've got 0.8. So we could just times it by 0.8 3 times, or times it by 0.8 to the power of 3. So I could just type into my calculator 4,000 times 0.8 to the power of 3, and I'll get that answer there, 2,048 as my final answer. And let's test that out. 4,000 times 0.8 to the power of 3, and we get 2,048. So that's depreciation. So in a bag of counters, 2/5 are blue, and it says 18 are blue. Work out the total number of counters in the bag. So it's not asking us to work out 2/5 of a number, it's saying that 2/5 are 18. Remember, it could have said work out 2/5 of, let's say, 20, and you divide by the bottom to get 1/5, you'd say that 1/5 is 4, and then times by the top to get 2/5, and we'd get 2/5 would be 8. That's a different question, so it's nothing to do with that, but it says 2/5 are blue and 18 are blue, so 2/5 equals 18. So if I want to work out 1/5 in this scenario, I need to divide by the top this time, because that gives me 1/5, half of that, so 1/5 would be 9. And then to work out 5/5, the original amount, we could times that by 5. So times it by 5, and we would get 5/5 equaling 45 counters. There you go, so that's our scenario there. So slightly different, the other way around obviously to working out a fraction of an amount, it says that that fraction is 18. So dividing it by 2 to get 1/5 and then timesing it by 5 to get the original amount. Okay, so writing some numbers in standard form, we're going to make this a number between 1 and 10 times 10 to the power of however many jumps we have to do in whatever particular direction. So this number here, 5,600, I'm going to hop the decimal in between the 5 and the 6. So 1, 2, 3. So that becomes 5.6 times 10 to the power of, it's a big number there, it's not a 0-point number, so 10 to the power of 3. Final answer. The next one is a small number, so we're going to have a negative power because we hop the decimal the other way this time. So 1, 2, 3 would make it 3.4, and again this time it would be times 10 to the negative 3 because it's a 0-point number, that indicates that it's a small number. When it comes to the other way round, writing them as ordinary numbers, I like to rewrite this little bit at the start to start with. So 2 and 3, and I like to just imagine where that decimal is between the 2 and the 3. So times 10 to the power of 5 makes it a big number, so we need to hop it 5 places. 1, 2, 3, 4, 5 to the right, and then filling in all those zeros underneath. And if it is messy, just remember to rewrite that, but there's my answer, 230,000. The next one, 8.04 times 10 to the negative 3. So this is going to be a 0-point number, and again I'm just going to write these digits out at the start, these bits here, and imagine where the decimal is at the top, 8.04. So negative 3 means it's going to be a small number, so we're going to jump it left 3, 1, 1, 2, 3. So it's going to go there, fill in all the zeros and tidy it up at the start. So 0.00804, final answer. Okay, so write this as a power of 3. So when we've got the same base numbers, which we do, these are all 3s, we can add the powers when multiplying and subtract the powers when dividing. So if we tidy up the top to start with, which I always do first, we add the powers there because they're getting multiplied. So 3 to the power of 7, and on the bottom we've got 3 to the power of 3. Now these are being divided, so we can subtract the powers. So 7 take away 3 is 4, so we get 3 to the power of 4. And again, it doesn't say to work out the value of that, it says to leave it as a power of 3. If it said work out the value of it, I'd actually have to work that out, and that means 3 times 3 times 3 times 3. Wouldn't be very nice without a calculator, that one, but we could work it out. But it says to write as a power of 3. Okay, so negative and fractional powers. Remembering the negative symbol there just means to do the reciprocal, to flip it over. So in this first one, if that's 5 over 1 at the moment, it'll become 1 over 5. Now if it was just a negative 1 in the power, we'd leave it as it is because it would be a power of 1, but that 2 is just a normal power, which means we're going to have to square both of these. It's a normal squared power. So 1 squared on the top is 1, and 5 squared on the bottom is 25, and that's our final answer there. Onto a fractional power, remembering that number on the bottom of the fraction represents a root. So in the case of a 2, that is a square root. So we're going to do the square root of 64, and the square root of 64 is 8. Now the 1 on the top is a normal power, so a normal power of 1 doesn't do anything. But if it was a 3, for example, we'd have to cube it, but it is just a 1. There's no negative in that one, so we don't have to flip it over or anything. It's just the square root, which gives us the answer 8. Okay, on to some combinations. It says in a bike store there are 8 different bikes and 10 different choices of paint colour. How many different combinations are there? Well, we have 8 choices of bikes to pick from, so that's 8 different combinations, and all we do is we multiply it by however many choices we have on the second option. So the second option is the paint colour, and there are 10, so we times it by 10 as our second option. So 8 times 10 gives us 80 options as our final answer. So you just take how many choices you have on each pick and multiply them together, and that's combinations. Okay, so this one's slightly different. A 3-digit padlock uses the numbers from 0 to 9. How many of the possible 3-digit number combinations use 3 different digits, meaning we can't have any repeats here? So let's imagine on the first one, on the first digit of this padlock, so imagine we've got 3 numbers. And on that first digit, let's say we pick the number 2. Now in that first pick there, we had the numbers from 0 to 9, including 0, so that would be 10 options that I had. But now that I've picked the number 2, I can't pick the number 2 again because there's no repeats. So I don't have 10 options now, I only have 9 options. Let's imagine we pick the number 3. So on this option now, on this third pick, I can't pick 2, I can't pick 3 out of these 10 numbers, so I only have 8 to choose from. So they are my 3-digit padlocks. Let's just imagine we pick the number 4, 2, 3, 4, and we'd have to multiply these all together. So 10 times 9 gives us 90. Well, we've got to times by 8, and 8 times 90, well 8 times 9 is 72. That's not a 7. 8 times 9 is 72. So 720. and that's how many different combinations we'd have for this particular padlock. So 10 times 9 times 8, perfect, 720. Okay, some error intervals. 6.4 has been rounded to 1 decimal place, and write the error interval. So the error interval, we always tend to put either 6.4 or a letter in the middle, depending on what the question is, and we have our arrows always pointing to the left. So we're going to find the upper and lower bound. Now 6.4, if it's been rounded to 1 decimal place, it couldn't have been 6.45. As soon as that 5 goes after that 4, it would have rounded up to 6.5. So we put that on the right hand side as our biggest possible number, that it couldn't have been 6.45. So it can't be equal to that number, so we leave that symbol as it is. It's got to be less than 6.45. Now what we did there is we added on this extra 0.05, and all we're going to do for the smaller one is take that away. So it would be 6.35. Okay, but it can actually be equal to 6.35, so I'm going to add my little equal to symbol on my inequality just there. So it can always be equal to that lower bound, because that would in fact round up to 6.4 if we rounded it to 1 decimal place. On to the next one. This one's slightly different in the wording. So this one says it's been truncated to 1 decimal place, and truncated basically just means it's been chopped off at that after this first decimal, regardless of how it rounded. So if we have a look at writing this as an error interval, again we write these in the same way. The impossible number that it couldn't have been 6.5. So my top one here is 6.5. It had to be 6.4 something if it was just chopped off. Let's imagine just a random how this works. So it could have been 6.4932, but it was just chopped here, and we just wrote what was at the start. Okay, but it couldn't have possibly been 6.5, because otherwise we'd have written 6.5. And the smallest it could have been is just 6.4 with no digits after it. It couldn't have been 6.3 though, because again, if we truncate that, it would have just been 6.3. So 2 different scenarios there. One where you've got to add on that extra 5 at the end and take the same size 5 off the start, and truncating there where we've just got to think about the fact that it was just chopped off and no rounding at all. And the final little one we're going to have a look at here is using your calculator. So it's important to know where lots of digits are. Pick quite a complicated one here, but you just need to have a play around with your calculator to make sure you can find your square root, your cube root, your squared, your cubed, your fraction button, your sin, your cos, your tan, and figuring these out. So I picked quite a complicated one here. So to get your cube root button, depending on what calculator you have, but the majority of them you still have to press the same things. We press shift, and then we go for, let's get a different colour here, we go for the square root button, and that allows us to get a cube root. So on your calculator, a cube root will pop up, and then we're going to use the fraction button. So the fraction button is just next to it in this diagram here, the fraction button, and an empty fraction is going to pop up. So on the top, we're going to just type in on the top of that fraction there, 4.3 multiplied by, press your tan button, and then press 39, and normally this will go in a bracket, so remember to close the bracket off there. But you don't put this little degrees symbol in, you just put 39, the calculator knows that you're talking about degrees. So let's get that up on my calculator. We've got 4.3 multiplied by tan, the brackets opens for me, 39, close the brackets, press your down button on the calculator to go into the bottom of the fraction, and type this sum in here, 23.4 take away 6.06. So 23.4 take away 6.06, and make sure at this point you write all the numbers down. That equals 0.585593423. Now some calculators may go beyond this depending on what the answer is on the calculator, but it tends to be that you never really have to go beyond 9 digits, because not all calculators will go that far, so you are limited to the amount that some people will be able to write depending on what calculator they use. Now the question will probably usually say then to round your answer to 1 or 2 decimal places. So if we just have a quick think, if we were to round this to 1 dp, to 1 decimal place, and we could chop that after the 5 there. So 1 decimal place would round up to 0.6, and we would round that to 0.6. If we had this to 2 decimal places or beyond, let's have a think. After 2 decimal places, let's pick a different colour. It would chop it after the 8, and it would be 0.59, because it's a 5 after that one. Okay, so you could have different ways of rounding this, but just make sure you write down all the digits on your calculator display. before actually rounding. Okay, so when you see this sort of question, you see these words here about bounds, there's always something we need to write down straight away. So we've been given two numbers here, so S is correct to 2 decimal places and T is correct to 1 decimal place. So the first thing I'm going to write down is the error intervals for them before I move any further. So writing our error interval, arrows pointing to the left, and an equal to symbol on our lower bound there. So I always start with the upper bound and I just stick a 5 on the end, so 8.24 with a 5 on the end, and then we just need to take that 5 off for the lower bound, so it'll be 8.2, not 4 but 3 with a 5 on the end, and then do the same for the other one as well. So let's write down the upper and lower bound for 3.5. So 3.5, stick a 5 on the end, and then for the lower one, 3 point, drop it down to a 4, and again just stick a 5 on the end. Now this question here asks us to find the upper bound. So when it comes to a fraction, and you could have anything here, but when it comes to a fraction, if we want to get the biggest possible answer, we want to do either, we've got to decide here, either we're going to do the upper bound divided by the lower bound, or we're going to do the lower bound divided by the upper bound. And we've just got to think which one there is going to give us our biggest possible answer. And that is the upper bound divided by the lower bound. So we want the biggest number on top divided by the smallest number, and that'll give us our biggest possible answer. So we want the upper bound of S sitting on top, so the 8.245, and the lower bound of T, 3.45 sitting on the bottom. So this is a calculator question. So we just need to type that in on the calculator, 8.245 divided by 3.45. and see what we get as our answer there. So if we type that in, 8.245 divided by 3.45, and we get the answer. It's quite a lot of decimals here, 2.3898550. Always just write down all the numbers and then round it however you've been asked in the question. This one says 3 decimal places, so let's chop it after the 9, and that would go to 2.3, and this is a bit of a dodgy one because the 8 rounds the 9 up, so it would go to 2.390, keeping the 0 in there. It does say 3 decimal places, so 2.390 would be my answer there. Okay, obviously it might say lower bound as well, in which case you'd use the other side of the formula, would you use this one instead. You might even be asked to do both of them and then round it depending on what they both look like. So if we imagine that the lower bound comes out as, and if we just make something up here, let's imagine the lower bound comes out as 2.295 or something like that. Now it might say considering bounds, give your answer to an appropriate degree of accuracy. And if you look at both these numbers, if we just imagine this is the lower bound, it's probably not, but if we imagine it was, these two numbers would not round the same to 2 decimal places, not to 3 decimal places, not even to 1 decimal place, because the one on the left there would round to 2.4 and the one on the right would round to 2.3. So if I did have to consider bounds to give an answer for this, I'd just have to say 2. And I would say the answer is 2, and that would be to 1 significant figure. So I could be asked that as well, and I just look at the upper and the lower bound and I round according to how they both actually round. And in this case, my little example here, they only round the same to 1 significant figure. Okay, so recurring decimals as fractions. So a little rule, we are going to use a bit of algebra for this, but if there's 2 recurring decimals, we're going to times it by 100, and if there's 1 recurring decimal, we times it by 10, and so on. There's lots of different ways of doing this. This is just the way that I do them. So I write what the decimal is. So we've got x equals 0.54. And remember, if there's a dot above the 5 and the 4, that means that decimal there is 0.5454, and continues like that. It's the 54 that's recurring. And it's always good just to write that down, just to remind yourself what that decimal actually represents. So if we've got 2 recurring decimals, we can times that by 100. You'll see why if you've not seen this before. Hopefully it's just a reminder. You get 54.54. Now we can take them away from each other, and that'll eliminate these recurring decimals here. If we take them away from each other, we have 99x's equals 54. And make sure that you actually do use your algebra to show this. Now we can divide both sides by 99, so x equals 54 over 99. And there it is as a fraction. You do just need to check just to see if your fraction simplifies, so do check to see if this one simplifies. This one actually does. The top and the bottom both divide by 9, and you'd normally be asked to show that it equals this next one, but if it doesn't, you can look to simplify if it says to give it in its simplest form. And if you divide them both by 9, you get 6 over 11. So the question might have said show that it equals 6 over 11, and that's how you would show it. You'd show how it simplifies. Now onto the one below. It's only got 1 recurring decimal, but it's a bit of a nasty one. So if we think about what this decimal actually looks like, 0.23 with the dot above the 3, that's 0.23 2 and then a recurring set of 3s. It's not a full repeating pattern of 2, 3, 2, 3, 2, 3. So if we have a look at this one, and again there are different ways of doing this type of question here, but this is I just follow the same process for all of them. So x equals 0.23 with a dot above the 3, and there's one recurring decimal, so let's times it by 10. So we get 10x equals 2.33, and then the 3 keeps going. I'll just balance it out so there's the same amount of decimal places in both. Now if we take these away from each other, something kind of interesting happens here. We get 9x equals, and 2.33 take away 0.23 is 2.1. Now if we take the same approach as before and turn that into a fraction, so dividing both sides by 9, we get x equals 2.1 over 9. And obviously you can't have decimals in fractions, so we need to remove this decimal from the top, so we can times the top and bottom by 10, and that would give us 21 over 90. There you go, and there's your fraction. And again, you just need to check to make sure that's to see if that simplifies or not. And it actually does. The top and bottom both divide by 3. So you can divide the top and bottom by 3, and you would get 7 over 30. Again, so it might have said show that this fraction equals 7 over 30. But always just check at the end to see if it simplifies. Obviously, if it just said to write it as a fraction, 21 over 90 would be fine. But if it said to give it its simplest form, we would have to look to simplify there. Okay, so some compound interest. James invests £2,500 for 3 years in a savings account. He gets 3% per annum compound interest in the first year, and then X% for 2 years. He has this much at the end of the 3 years. Work out the value of X. Well, just like normal compound interest here, we can actually do the first year. So we can work out, I'm just going to label this up. So after the first year, let's see how much money he has. So 2,500 for 3%, we would times that by 1.03. Obviously we don't need to add any powers into there because it is just the first year that he's getting this. So if we do this on the calculator times 1.03, and we get an answer of £2,575. Now we've got a bit of a reverse compound interest scenario, and we're going to have to create a little formula for this, because in the second and third year he gets X%. Now his starting number, and let's just write down second and third, his starting number now is 2,575. Now if we knew the percentage, we'd multiply it by that percentage, which we'll call x in this scenario because we don't know what it is, and we'd do that to the power of 2 as it's 2 years. And what it's saying in the question is that gives us the answer £2,705.36. Now obviously at this point here we could just guess some numbers. We could just guess an x value, and if it's too high go lower, if it's too low go higher, and that's a fine way of doing it as well. But you can save yourself a bit of time here just guessing lots of numbers by actually just rearranging this. So we can divide both sides by 2,575, and it will give us the value of x squared. So x squared is going to equal, and again let's just do this on the calculator, 2,705.36 divided by that gives us this answer here, 1.050625243. That's obviously the value of x squared, so we need to square root both sides. So if we square root that answer, we get the answer 1.025000118. So that gives us our little percentage here. So it's hidden within this decimal. Now our actual percentage here is not 1.025, because that 1 point is what we increase by for the percentage. So it's just this 0.25 that we're interested in, and 0.25, if you think back to what we did at the start here with 0.3 being 3%, well 0.25 would be 2.5%. There we go, so that's 2.5%. So just be careful that you do read that off there and don't put 1.025 in this type of question. But again, you could have guessed, if you'd have guessed 1.02, it's normally going to be lower than that first one. That's normally what banks do. They give you a better one in the first year and then not so good following that. Okay, so there's just two ways that you can approach that. You can guess some numbers, or you could obviously just rearrange it and find it there. Just being very careful that you actually read the percentage from that 1 point number. Okay, so we've got some standard forms, we've got some multiplication and some division. I'm going to start with this multiplication. Now I'm primarily thinking this is like a non-calculator style question, because obviously if this was on a calculator you could just type it in nice and easy and write it in standard form. So actually we're going to have to do a bit of a trick here. So 3.2, I can times that by 4 to figure out what my starting numbers would be. So 3.2 times 4, again, you've just got to work that out, whatever method you're used to using. I'm going to do 32 times 4 and hop the decimal back in. So 4 times 2 is 8, and 3 times 4 is 12, and then hop the decimal back in, so it's 12.8. So the answer I get there is 12.8, it's going to be times by 10, and when we're multiplying we can add together the powers here, so 3 plus 4 gives us 7. Obviously though it says to write your answer in standard form, and that number here, 12.8, is not between 1 and 10, so if I hop the decimal in, making the number 1 place value smaller, I'd get 1.28, and if I make the number smaller, I have to make the power 1 bigger, so it'd be 10 to the power of 8. Okay, so don't be put off by these sorts of questions. Do your multiplication, follow your power rules, and then balance it out. Just remember, if you make the number smaller, you make the power bigger. We'll take this exactly the same approach for this one, except it's a divide. So I need to do 3.6 divided by 4. And again, it's up to you. You can hop the decimal out and hop it back in, but I'm just going to do 3.6 divided by 4 using a bit of bus stop. So 4 doesn't go into 3, so carry the 3, and then 4 goes into 36 9 times. There we go, so it's 0.9. So when we divide that, we get 0.9 times 10 to the power of, and when we're dividing we can subtract the powers. So the first power there is 2, the second power is negative 3, so just write that down to the side. What have we got? We've got 2 take away negative 3, which is 2 add 3, which gives us a power of 5. There we go, so the power is 5. And then again we just need to balance that out, because obviously this is not between 1 and 10, so I'm going to hop the decimal this way, making it 9. So this time I've made the number bigger, so I need to make the power smaller, so it goes down to a 4. And there's our final answer, 9 times 10 to the 4. And the last question on this section, so we've got in 2008, Alice bought a house in 2008 Alice bought a house, in 2014 she sold it for 20% profit, and in 2019 it was sold at a 5% loss, and it gives us the value that she sold it for. Work out the cost of the house in 2008, so right back at the start. So we had 2008 she bought a house, and she sold it for a 20% profit. Then in 2014, it was sold for a 5% loss. And then in 2019, the value of it was 182,400. Right, so at this point in 2019, this cost here to whoever she sold the house to in 2014, this was sold at a 5% loss. So to her, that was only 95% of the value that she bought it for. So if we've got a calculator here, in order to turn that back into 100%, quite nice and simply, we can divide it by 95 to get 1%. So if that there is 95%, we can divide that by 95. So divide by 95, which would give us 1%. So 1% would equal, and we'll just do this on the calculator, 182,400 divided by 95 gives us 1,920. And then to get back to 100%, we just times that by 100. So we can just add 2 zeros on for that. So 1920 with an extra 2 zeros. There we go, so 192,000. So that's the price that it was sold for. That she paid for it before. So before that, it was 192,000. That's not a zero, 192,000. And then we've got to think about the original sale in the first place. So that means that 192,000 there was at a 20% profit. So if that was a profit to Alice in the first place, then to her, this amount of money was 120%. Okay, it was 20% more than she originally paid for it. So we can follow exactly the same approach now. If that's 120%, we would divide that by 120 to give us 1%. So 1% here would equal, and we'll just work that out. Divide that by 120, and 1% is 1,600. And again, you can times that by 100 to get 100%. And our original cost up here would be 1,600 with 2 zeros on the end, so £160,000. There we go, so 160,000. There we go. So that's it using a calculator. That's moving through 2 reverse percentages there, one with a decrease, one with an increase. You just got to remember, if something's been decreased, then we get this 95%, whatever was left over. And then there was also the scenario where at one point it was increased, making it 120%, that extra 20% there. So this can be done calculator and it can be done non-calculator. The 95% one wouldn't be very nice, but thinking about how you could have done this 120%, which is quite common when VAT is added on, because they often have these VAT questions where they say VAT was added on at 20%. There is a way of doing that without a calculator, and what you could do when that happens is you can divide by 12 and then times by 10. So you could do that without a calculator. You could do a bit of bus stop there and divide 192,000 by 12 and then just add on a 0 when you times by 10. Okay, so moving on to algebra, and we're looking at index laws to start with. So we know with index laws, we've looked at this when we have powers that are getting multiplied together when they have the same base number. These powers can be added together, so 2 and 3 would make 5. We also had the process when they're being divided. So x to the power of 7 divided by x squared, we take away the powers and we get x to the power of 5. And we also have powers in brackets, so if we have x squared to the power of 5, we multiply the powers, so we get x to the power of 10 in that particular example. Now having a look at this one, we've got 30x squared y to the power of 3 on the top and 6xy squared on the bottom. So we're doing a divide. Now we've got these numbers on the top and the bottom, 30 on the top, 6 on the bottom. So numbers always just divide numbers, so 30 divided by 6 gives us 5. Now individually looking at the letters, we've got an x squared, and on the bottom we've got an x. Now it's not written in there, but that is a little power of 1 there that's not written. So if we subtract the powers, 2 take away 1 gives us x to the power of 1. I'm not going to write that in, I'm just going to leave it as x because that means x to the power of 1. Moving on to the y's, we have y to the power of 3, y squared on the bottom, and 3 take away 2 gives us just y on the bottom there. So our final answer would be 5xy. Okay. Looking at this one then, we've got powers in brackets, so we're going to be multiplying powers here. But we've got this number 2 in the start as well, so numbers always get treated like numbers, and that whole thing is being cubed. So we need to work out what 2 cubed is. 2 cubed is 2 times 2 times 2, which is 8. So we're going to have 8 at the start of this one. Multiplying the powers for the x then, x to the power of 2, that's going to get times by 3, so that's going to become x to the power of 6. And y there is a power of 1 which is not written, so 1 times 3 gives us y to the power of 3. And there's our final answer there. On to expanding brackets. This first bracket we are multiplying everything inside the bracket by b. So b times 3b, well not forgetting there's a 1 in front of that, 1 times 3 is 3, and b times b is b squared. On to the next one, 1b times 7, well 1 times 7 is 7, and there's just that 1b that we're going to leave in there, and we're just going to copy that symbol, which is a plus, so keeping that as a plus. On to expanding below, we have 3y times 5. 3 times 5 is 15, and we've got the 1y there, so we'll leave that as a y. And then 3y times the 4y, well 3 times 4 is 12, y times y is y squared, and then again copying that symbol as a negative. Expanding and simplifying two brackets, so we'll expand these separately, so let's have a look at the first one. So 3 times 5 is 15, and 3 times 4 is 12. So we have 15x plus 12. On to the next one. Got to be careful with this one because it's saying take away, which means this is a negative 2 at the start of the bracket. So we're going to times both these pieces by negative 2. So negative 2 times 3x is negative 6x. And negative 2 times negative 2 gives us positive or plus 4. Now we just need to tidy all this up, so we have a 15x take away a 6x, and that gives us 9x's in total. And we have a 12 add a 4, and 12 add 4 is 16, that's positive 16, so we get 9x plus 16. Moving over to expanding and simplifying a double bracket. So x times x gives us x squared. X times negative 5 gives us negative 5x. 3 times x is positive 3x. And then positive 3 times negative 5 is negative 15. And then again, we just need to tidy this up because we've got these two x pieces in the middle. So we've got x squared still at the start, but we've got negative 5x add 3x, which in total is negative 2x, negative 5 add 3. And then we've got the negative 15 at the end. Onto the one below. So we've got some numbers in front of the x's here, so I'm going to do the same process. Let's see if we can move some of this out of the way. Just about. Okay, so 2x times 3x, 2 times 3 is 6, x times x is x squared, so we'll get 6x squared. 2x times 4 is 8x, that's negative 4, so it's negative 8x. Negative 3 times 3x is, well 3 times 3 is 9, so negative 9x. And then negative 3 times negative 4 will give us positive 12. 3 times 4 is 12, and it's a negative times a negative. And then again, just tidying this up, we have 6x squared at the start, and we've got negative 8 take away another 9x. So negative 8 take away another 9x is negative 17x. And then we've got that plus 12 at the end, and there's our final answer. And we've simplified it there with the simplifying in the middle. Final answer. Okay, so factorising. We're going to take out a factor and put this into brackets. So we'll have a look at both these pieces. 3x and 15. We just think what number goes into both of those? They both divide by 3. So we're going to divide this by 3. So 3 on the outside of the bracket, that's the factor we're taking out. 3x divided by 3 is just x. Copy the symbol with a plus. And 15 divided by 3 is 5. And you can check your answer there. You can expand that back out just to check that you do get 3x plus 15. Now this next one says factorise fully, and that's because there's more than just one thing that comes out of the bracket in this one. So in that one above there was just a 3 that came out. So here we're going to have two things, and let's have a look at both these pieces. So we've got 35x and 21x squared. So they both have an x in, so there's definitely going to be an x coming out. Just need to think with 35 and 21, what's the biggest number that goes into both of those? That is 7. So the highest common factor of those two numbers is 7. They also both have an x in, so we can take x out as well and then follow the same process. So 35x divided by 7x, or what do we times 7x by to get 35x? Well, we have to times 7x by 5, but we don't want to put an x in there because we don't want to make that go up to an x squared. Copy the symbol. We times 7 by 3 to get 21, but we want that to be an x squared, so I'm going to stick another x in there with it. That would enable us to get an x squared when we expand that, and there's our final answer, factorised fully. Just a note, if you didn't take the 7x out and you just took a 7 out, for example, and this wouldn't be factorised fully, you'd have got 7 brackets 5x minus 3x squared. And you can see in that bracket there, there's still an x in both these pieces. There's a little hint there that you didn't fully factorise it. Okay, so on to factorising a quadratic. This is the opposite of expanding a double bracket, so we know what our answer is going to look like already. It's going to be in a double bracket, both with an x at the start. Now when we're doing this, we've just got to find the pair of numbers that are going to go into our bracket. So looking at the 12, we know it's going to be a pair of numbers that multiply to make 12. So I always write these down. We can have 1 and 12, 2 and 6, or 3 and 4. We just need to have a look at these numbers there because we've got a 7x in the middle, so they have to add up to make 7x. So 1 and 12, there's no way I can make 7. 2 and 6, I could either make 8 by adding them together, or I could make 4 or minus 4 if I do a minus with one of them. So I'm not going to make 7, but I can make it with 3 and 4. I can have plus 3 and plus 4, and that would make 7. So plus 3 and plus 4, and that's not a 4, plus 3 and plus 4, and that would be factorised. Having a look at the one below, we've got some negative symbols going on there, so we've got a slightly different process, but our answer is going to look the same. It's still going to be in a double bracket, it's still going to be x at the start, and we're still going to have two numbers in here with some symbols. So 28, the numbers that times to make 28 are 1 and 28, 2 and 14, or what else could we have? 4 and 7, and let's have a look if these can make 28. So what have we got? We've got minus 3 in the middle. So we want to make minus 3. Well, we're not going to do that with 1 and 28. That's not going to work. 2 and 14, we could make 16, or we could make 12. That's not going to work. But 4 and 7, we could do plus 4, take away 7, that'd make minus 3. So plus 4 and negative 7. And that's our double bracket there finished. So on to solving equations. So when we've got this word solve, it means it wants us to find the value of this x piece just here. So we've just got to reverse the process of what's going on. So at the moment it says 3 times the number, 3 times x, plus 5 is 26. Well, if we get rid of this plus 5 by taking away 5 from both sides, that tells us that 3 times the number, 3x, must equal 21. And that means 3 times the number, so we can reverse this process now by dividing by 3, which I like to write as a little fraction, so divide by 3. And 21 divided by 3 is 7, so we would write x equals 7, and there's our final answer. So have a look at this next one. So 5x minus 2 equals 21. Well, this time to reverse this, we've got 5 times the number, take away 2, so if we add the 2 onto both sides, we get 5x equals 23. And here comes the part where I explain why I like to write it as a fraction as above rather than just writing divide by 3, because in this circumstance 23 doesn't divide perfectly by 5. So if we go divide by 5 again and divide by 5, we have our answer there written for us, 23 over 5. So x equals 23 over 5. Okay, which we could convert back into a mixed number. 5 goes in 4 times with the remainder of 3. So we could write it's 4 with that remainder of 3/5 there. Or I could even write it as a decimal. I could type that into my calculator and turn it into a decimal, but it's fine to leave it as a fraction. 4 3/5 is my answer. So here's one where we've got x on both sides of the equation. So in order to make this look like one of the equations from before, we want to get rid of x from one of the sides. Now it doesn't matter which one we choose. I always choose to go for the smallest x. So we've got a 5x on one side and a 3x on the other side. So 3 being the smaller one. So we can take away 3x from both sides. That's smaller x. So if we take away 3x from both sides, well 5x take away 3x leaves us with 2x. We've still got that negative 3 there, and that now equals positive 9, so I won't bother putting the positive symbol. However, if there was a negative there, I would keep that in, just to emphasise that it is a negative 9, that's really important. So now we've got an equation just like the question before, so again we can add 3 to both sides, and we get 2x equals 12, and then we can divide that by 2. Again, I like writing that as a fraction, and 12 divided by 2 is 6, so we can write that as a whole number, x equals 6. Make an x the subject of a formula, or any letter the subject of a formula. So this one's y equals 3x plus 5. So essentially, to make x a subject, we want it to say x equals. And we're going to rearrange these pieces and move them around, just like we did on that solving the equation. So the first thing I can do is I can get rid of that 5, just like before, and we can subtract 5 from both sides. Now I can't actually subtract 5 from y, so I'm just going to write that as y minus 5. And that now equals 3x. And just like before, we're just going to divide by 3. So if I divide by 3 both sides, thinking about how I did it before, I wrote it as a fraction like this, and that's what it's going to look like on the other side. It's going to be y minus 5 over 3 now equals x. 3x divided by 3 is just x. We've got x on its own. It doesn't matter that it's on the right hand side. We can rewrite it if we want. We can easily just rewrite x equals y minus 5 over 3, and there's our final answer. Got two slightly different ones here that look almost the same because we've got some fractions going on, but let's see how we treat these ones. So on this left, make x the subject. So again, what I could do is I could get rid of this 3 on the bottom to start with if I wanted, or I could get rid of this 5. I'm going to decide to get rid of the 5, so let's take away 5 from both sides. So if we take away 5 from both sides, we get y minus 5 equals x over 3, or x divided by 3. So to reverse a divide by 3, we're going to have to times by 3. So if I multiply both sides by 3, we'll get 3 lots of, and I'll put it in a bracket now, 3 lots of y minus 5 equals x. We could leave it like that, or we could expand this. We could say 3 lots of y is 3y, 3 lots of 5 is 15, copy the symbol, and then put in our x. Again, we could have done that a slightly different way. We could have times by 3 to start with. You'd have just had to remember at the starting point we'd be timesing this by 3, and we'd be timesing this by 3, just like we did in the end there. But that's our final answer. Now looking at this one on the right, it's slightly different because we don't have the option of getting rid of this 5 on the starting process here, because it's locked in by this divide by 3 on the bottom. So the first thing I'm going to have to do is times by 3 to remove this fraction to unlock what's on top there. And if we times by 3, we get 3y equals, and what's on the top is x plus 5. Now we can finish it off quite nice and easily. We can just take away that 5, and again that's going to make x the subject. So we have 3y minus 5 equals x, and again both of these questions we could rewrite it as x equals at the start if we wanted. So a equals 5b plus 2c, b equals 3 and y equals negative 2, find the value of a. So we're just having to substitute these numbers in. So we're going to find out what a is. So a is going to equal 5 lots of b, and when I sub a number in I always put it into a bracket. So we have 5 lots of b, which is 5 lots of 3, and then 2 lots of c, so plus 2 lots of negative 2. We put these in a bracket like that. All we have to do is now multiply these. So 5 times 3 is 15. 2 lots of negative 2 is negative 4. And we're adding these together. So 15 add negative 4 is 11. Remembering that these just become a takeaway. So it's 15 take away 4. So a would equal 11. There you go. Just something to remember there. Whenever you're subbing numbers in, always put them into a bracket there, just so that you can sub them in and then deal with the calculations later. Okay, so on to solving simultaneous equations. Now we've got two equations here. I'm going to call this one 1 and this one equation 2, just so that I can talk about them. So when we're solving simultaneous equations, we want to make the coefficient, the number in front of one of the letters, the same. Now I always focus on this second one here, which in this case is the y. So on the top one we have 1y, and on the bottom one we have 3y. I know one of them is negative, but we'll deal with that later. I'm just purely looking at the number in front of it. So we have a 1y and we have a 3y. Now in order to make those numbers the same, I'm going to have to times the top one by 3, and that would make it a 3y. I don't have to times the bottom one by anything, but I might have to change them both in some of these questions. So let's have a look. If we multiply this top equation by 3, what does it become? So 4x would become 12x, the 1y becomes the 3y, and the number at the end will become 75. And that's my top equation. I'm going to rewrite the other one below it, which was 1x minus 3y equals 16. Now at this point I have the option, I can either add these two together or I can subtract them away from each other, but I want this 3y in the middle to get eliminated. Now if we think about the logics here, if I was to do 3y take away negative 3y, that would become a plus and I'd end up with 6y. So taking them away is not going to work, I'm going to have to add them together. 3y add negative 3y becomes 0. So if we add these two equations together, we get 13x equals 91. Okay, so there is a little way of remembering those. If those symbols there are different, you add them together, and if the signs are the same, you're going to subtract them. Okay, but here we are, we have 13x equals 91. If we divide both sides by 13, we get x equals 7. Now when it comes to simultaneous equations, we have to not just find the value of x, but we also have to find the value of y. So what I'm going to do is I'm going to sub x equals 7 into any of these equations that we've got written down. I'm just going to have a look at the start. I think this one's going to be the easier one for me, just because it's got a plus symbol. So if I sub x equals 7 into equation 1, I won't have that x there anymore, and we can start to work out what it is. So again, using brackets, I'm going to do 4 lots of 7, add that 1y, and that equals 25. Now 4 lots of 7 is 28, so we have 28 plus y equals 25. And again, we just need to now finish this off to solve it to find out what y is. Well, 28 add y is 25, it goes down, so it's got to be negative. And if we solve this like normal, taking away 28 from both sides, we get y equals negative 3. And there's our final answer, y equals negative 3. So x equals 7 and y equals negative 3. I could have subbed this x equals 7 into any of the equations. I could have subbed it into equation 2. I could have even subbed it into this equation that we made up here if I wanted, but I think I just went for the easiest one there. So let's have a think. If I did sub it into equation 2, we'd have had 7 take away 3y equals 16. Doesn't quite seem as nice here, because now when we take away 7 we have negative 3y equals 9 when you take away 7, and then when you divide by negative 3, 9 divided by negative 3 is negative 3. So we could have solved it in that equation as well, but I've opted to go for the easier one there. Okay, so we've got some worded equations here. 3 calculators and 4 books cost £23, and 2 calculators and 3 books cost £16. Work out the price of a single calculator and a single book. So we have to create the equations ourselves here. So let's have a look. We've got 3 calculators and 4 books cost £23. Well, let's just call the calculator C, so 3C, and, so plus 4 books, let's call that B, equals 23, and we've got an equation there that looks similar to the last question. The next statement, we've got 2 calculators, so 2C, add 3 books, so 3B, equals 16. There we go, so we've got again an equation 1 and an equation 2. Now we've got to follow that same process as before. I'm going to make these numbers, these coefficients of B the same, but this time I'm going to have to change them both, because one's a 4, one's a 3. So let's think, we could make those into 12, so I could times the top one by 3, and I could times the bottom one by 4, and that would give me a 12 in the middle. So if we actually work that out, let's have a look. What do we get? Timesing the top one by 3, and let's move this around. Okay, so timesing the top one by 3, we get 9c plus 12b, and 23 times 3 is 69. Onto the one below, timesing them by 4, we have 8c plus 12b, and 16 times 4 is 64. Okay, so looking at these symbols, the signs are the same, they're both a plus, so the way to eliminate this 12b is to subtract these away from each other. So I'm going to do the bigger one on top, take away the smaller one on the bottom. So 9c, take away 8c, leaves us as 1c. And 69 take away 64 is 5. So straight away we get our answer there, c equals 5. So there's our first answer, c equals 5. And then we just need to sub that back into one of these equations. Again, I'm going to pick equation 1, I think. Let's have a look. We could do either one here, but I'm going to pick equation 1. So if c is 5, we have 3 lots of c, or 3 lots of 5. Add 4b, and that equals 23. There we go. Now 3 lots of 5 is 15, so we're going to have to take away 15 from both sides, and we get 4b equals 23, take away 15 is 8, and then dividing that by 4, we get b equals 2. There you go, 8 divided by 4, b equals 2. So our final answer there, we got c equals 5, and b equals 2. Obviously thinking about the context here, that was a calculator is £5 and a book is £2. So Adam, Brian and Chris are all work colleagues. Adam is 8 years older than Chris, Brian is twice as old as Adam. The sum of their ages is 92. How old are they all? Okay, so we can do this using equations as well. Now it says Adam is 8 years older than Chris and Brian is twice as old as Adam. Now it doesn't say anything about how much older Chris is than anyone else. So if let's call Chris X, then what would Adam be? Now it says Adam is 8 years older than Chris, so Adam would be 8 older than that, exactly 8, so that would be whatever Chris's age is, X plus an extra 8. Then it says Brian is twice as old as Adam. Well, this is Adam here, X plus 8, so Brian is twice as old as that. So twice as old as that would be 2 lots of that, so 2 lots of X plus 8. And we could even expand that out now, so 2 lots of X plus 8 is 2X plus 16. So we have their 3 ages now in terms of algebra. We have Chris being X, Adam being X plus 8, and Brian being 2X plus 16. It says the sum of their ages is 92, so sum being to add them together. So if we add them all up and see what we get, we can have X plus the X plus 8 for Adam, plus the 2X plus 16 for Brian. And it says that they all equal 92. So if we start to simplify this, let's have a look. We've got x, x and 2x, which is 4x. And we have the 8 and the 16, which is 24. So 4x plus 24 equals 92. And now we can just solve this just like before. So I can take away 24 from both sides. Take away 4 is 88, take away 20 is 68. So we get 4x equals 68, and then we just need to divide by 4. So dividing that by 4, let's think, gives us 17. So x equals 17. So it does say how old are they all, so we could finish this off and we could just say, well, Chris was x, so Chris is 17. Adam was x plus 8, so Adam would be 17 plus 8, which is 25. And then Brian is twice as old as Adam, so Brian would be 50. Twice as old as 25, double 25. A nice little quick check there, you could just add those all up. 50 plus 25 is 75, plus the 17 is 92. So I'm happy that that works, it meets all those criteria. So the perimeter of the quadrilateral is double the perimeter of the triangle. Work out the perimeters. Now the lengths of each shape are given to us as expressions, so we could get an expression for each of the perimeters to start with. So let's have a look at that quadrilateral. Let's write that down over here. So the quadrilateral, we've got lots of pieces here, so let's count up these x's to start with. We've got 2x, plus this one's 4x, 7x, plus another one is 8x, so we have 8 x's. And the numbers, we've got a -3 and a -1, and then total that is -4. So that's the quadrilateral 8x minus 4, and that's an expression for the perimeter. Then we've got the triangle. Let's have a look what we've got there. We've got 1x, 2x, so 2x, and we've got 3, 4, 5, plus the 4 is 9, so 2x plus 9. Now it says the perimeter of the quadrilateral is double the perimeter of the triangle. So if we double the perimeter of the triangle, then that would be equal to the perimeter of the quadrilateral. Okay, so if we double this one, then those perimeters, those expressions for the perimeters would be equal. And if we double that, we get 4x plus 18. Now because those two perimeters are now equal, we can set them equal to each other using an equation. So we can say this one here, the perimeter of the quadrilateral now, 8x minus 4, is equal to this one here, double the perimeter of the triangle. So that's equal to 4x plus 18. We can now just solve that like an equation, so we can get rid of the smaller x from both sides, so minus the 4x. So over here we have 4x, so we have 4x minus 4 equals 18. We can now add 4 to both sides, so get rid of this plus 4, so plus 4. And we get, let's do this over here, we get 4x equals 22. And then we've got to finish that off to find out the value of 1x, so dividing by 4, x will be 22 over 4, which is okay if we have a calculator, but 4 goes into 22 5 times with a remainder of 2, so it'll be 5 2/4. And 5 2/4 is 5.5. So our final answer there, let's bring that up to here, would be 5.5 or 5.5. And again, it would have probably said in the question it was all in centimetres or it was all in metres, so we just have a look at what units we'd apply there, but 5.5 is our value of x. Now it says to work out the perimeter of the triangles, so we can sub these back in if we want. So 5.5 would be here in place of this one, would give us 8.5, so that would be 8.5. 5.5 on the x plus 2 here would give us 5.5 plus 2, which is 7.5, and then this one over here is 4. So if we add those all up, 8.5 plus 7.5 is 16, plus the 4 gives us a perimeter of 20 for the triangle. We could have done the same with the quadrilateral, but it said the quadrilateral is double the triangle, so this one here must be 40. And again, we could have just subbed that into the quadrilateral there and halved it for the triangle, but we've got our two perimeters. Again, just not forgetting what units it was, not that I've put any units in this one. Okay, so work out the size of angle ABC in this pentagon. So A to B to C is this angle here, and that's got a 2x in there at the moment. Now it's a pentagon, it doesn't say it's a regular pentagon, it's definitely not because all the angles are different. But we need to know what the angles are in a pentagon this time. So a triangle, remember, is 180. A quadrilateral, we add another 180, is 360. And then a five-sided shape, we add another 180, which is 540. So 540 degrees is what these all add up to. Now if we add them all up, again, like we did before, we've got 2x, plus another one is 3x, plus another one is 4x. So we have 4x's, plus all these numbers. So we have 121, 112 and 15. And if we add those all up, 121, 112 and 15, we get 842 or 248. So plus 248 has to equal 540 degrees this time. And there's our equation made because we know all these angles have to add up to 540. So we've got slightly bigger numbers here, but let's take away 248. Take away 248 and it will tell us what those 4x's have to equal. So 540 take away 248 gives us 292. So 4x equals 292. And if we divide that by 4, it will tell us what the value of 1x is, and 1x comes out as 73 degrees. I'm not quite finished the question here because it does say work out the size of angle ABC. Now the size angle ABC here is 2x, so 2 lots of 73, 2 lots of x is 146 degrees. So that one there would be 146. Again, we could work out any of these, we would know that that one now is 73. And x plus 15 down the bottom here would be 73 plus 15, which would be 88. And if you add those all up just to double check, you will get 540 degrees, but our final answer there is 146 degrees. Okay, so a nice quick one here, solving an inequality. Now this symbol shouldn't put you off here. It's an inequality, yes, but we're going to treat it exactly the same as if it was an equal sign. So before we saw a question like this where it was 2x plus 3 equals 20. We're going to do it in exactly the same way, but we're just going to leave that symbol in there. So we're going to take away 3 from both sides, which leaves us with 2x is less than 17, and then dividing by 2. We get x is less than 17 over 2, and we could probably work that out. 17 over 2, half of 17 is 8.5, so x is less than 8.5. Okay, so draw the graph of y equals 2x minus 1 between the values of x equals minus 2 and x equals 3. Now, there's two ways of doing this. Again, we could make a nice little table, and we've got x values and we've got y values. Remembering this equation just means to find the y coordinate, you do 2 times the x coordinate or double the x coordinate and take away 1. Now it says between minus 2 and 3. So if I'm going to do a little table, I'd do minus 2, minus 1, 0, 1, 2 and 3. And all I've got to do is double them and take away 1 as the equation says. So if I start at the end with this positive number, double that is 6, take away 1 is 5, double 2 is 4, take away 1 is 3. Double 1 is 2, take away 1 is 1. Now you might start to see there's a bit of a pattern here. Look, 5, 3, 1, those are all going down in 2s. So I can just follow the pattern here. 1 take away 2 is minus 1, and take away 2 again is minus 3, take away 2 again is minus 5. And we've got our coordinates here. Just looking at this one, that coordinate is minus 2, minus 5 as a coordinate. And all we've got to do is plot these and join them up with a ruler. So that's one way that we can do it. And I'm going to just draw that in to start with. So minus 2, minus 5's here, minus 1, minus 3, 0, minus 1, and the next few go there. And then nice and neatly with a ruler and a pencil, joining that up with a straight line. Absolutely not like I've just done there, which is absolutely terrible, but as best as you can with a straight line and a ruler. Okay, so that's one way that you can do it with a little table. You can actually do a little trick with this one, which is quite nice if you know what these pieces in there mean. So the 2 in front of the x, let's draw this over here, y equals 2x minus 1. The 2 there represents the gradient, and the minus 1 there represents the y-intercept. Okay, where it crosses the y-axis. So let's have a look there. It does cross through minus 1, so we could have put that point on straight away because we know it goes through minus 1, and then we could have had a look at the gradient, and that gradient of 2 just means for every 1 across, let's think from that point, so 1 across, it goes 2 up, and it goes 2 up. So you could do a little staircase here. You could just go again, 1 across, 2 up, 1 across, 2 up, to keep finding those coordinate points, and then tracing it backwards, so 2 down, 1 left, 2 down, 1 left, and you can draw this little staircase in. That's another way of doing it as well. Slightly different one, so draw the graph of y equals x squared plus 2x minus 3 between minus 3 and 2. Now again, I'm going to do a little table for this. So we have x and y, and it's between minus 3 and 2. So minus 3, minus 2, minus 1, 0, 1, 2. Now this is a slightly more complicated one for us to sub in, because to find the y coordinate you have to do x squared, add 2x, take away 3. So I want to write these down nice and carefully. So I'm going to start with 2 again for the positive one. So we have 2 squared plus 2 lots of 2, take away 3. I'm just going to work that out nice and slowly. 2 squared is 4 plus 2 lots of 2, which is 4, take away 3. So 4 plus 4 is 8, take away 3 is 5. So my answer there underneath the 2 is going to be 5. Now I need to follow this process for all of them, but the one thing I do need to be careful of is when we get to these negative numbers. So up here, where I put 2 squared in, just here, we should really make sure we keep that in a bracket, because as we get down to those negatives, it's going to have a big effect on that, and we'll see what happens when we get to them. Now I'm going to do the other ones a little bit quicker. Let's have a look. So 1 squared is 1, add 2 is 3, take away 3 is 0. 0 squared is 0, add 0 is still 0, take away 3 is negative 3. And here's where we need to be careful. So the first one here is negative 1. So I need to put, if I'm going to do this on a calculator, I'll write my working out down. Negative 1 squared, add 2 lots of negative 1, and then take away 3. Now the reason you have to put this in a calculator is because if you put negative 1 squared without the brackets, it will give you the answer negative 1. It will square the 1 and put the negative with it, rather than doing negative 1 times negative 1. Squaring a negative number makes it positive, so negative 1 squared is 1, add 2 times negative 1 is negative 2, and take away 3. So 1 take away 2 is negative 1, take away 3 is negative 4, so we get negative 4 for that one. There we go. Let's have a look at the next one. Negative 2 squared is 4. Add negative 4 is going to be 0. And then take away 3 gives us negative 3 again. And then onto the negative 3. Negative 3 squared is 9. Add 2 lots of that, so negative 6. So 9 take away 6 is 3. And then take away 3 again gives us 0. So you can probably see a little bit of a pattern here. Look, if you look at that negative 4 in the middle, either side of that we've got negative 3, either side of that we have 0, and then we have the additional 5 there. But let's just plot these and see what it looks like. So negative 3 to 0 is there. Negative 2 to negative 3 is there. Negative 1 to negative 4 is here. 0 to negative 3. 1 to 0, and 2 to 5, which is all the way up there. There we go. So this forms a quadratic curve, a parabola, and we just need to draw that with a nice smooth curve as best you can, going through all the points, making a nice smooth curve. And there's our graph drawn. Just as a note, we could also have a cubic graph. So we could have an x cubed up here, and we just treat that in exactly the same way, subbing the numbers in very carefully using brackets. And it tends to be that a cubic graph has this sort of shape, so just be careful. There are some others as well. We could have a reciprocal graph, where we have something like y equals 3 over x, and that has a different look again. It has this sort of curved shape within the positive part of the graph. So there's lots of different graphs that we can have a look at, but just treat it all in the same way and plot the points very carefully, joining them up with nice smooth curves. Okay, so back to a straight line graph. Find the equation of this line and give it in the form y equals mx plus c. So I'm going to use that little trick process that I saw before. We're going to have a look for two coordinates here. I've got one coordinate there and another coordinate here. Now if we go across 1 on the x-axis, being careful of the scale here, because although mine goes up in ones, sometimes you might have 2 squares for every one, so just be careful of that. Now it goes across 1 and then it goes up 2. So it goes across 1 and up 2, so every one across it goes 2 up, so the gradient, the value of m, is 2. All we've got to find is that value of c, which as we've already said is the y-intercept, and it crosses the y-axis down here at -3. So c is going to be -3. So I just need to put those all together. We have y equals 2x take away 3. That's the equation of this line. We can do that nice and quickly like that. It goes through -3 on the y-intercept, and there's a gradient of 2, which I've found between those two whole number coordinates there. Slightly different one here because it's sloping in the other direction, but the same type of question. I'll take the same approach, so I'm going to find the y-intercept to start with this time, so c equals 1, and then we just need to find the gradient. So let's pick two coordinates. We've got one here and one here, and now this time for 1 across it goes 2 down, so 1 across it goes down 2. So my gradient this time is going down, and we'd say it's -2, so the gradient is -2. So y equals mx plus c, we have y equals -2x plus the positive one there for the y-intercept, and there's the equation of that line. And the last question on these, it says here are the equations of 3 straight lines. It says 2 of them are parallel, and explain which 2 are parallel. So in order for a line to be parallel, it's going in exactly the same direction, and therefore it has exactly the same gradient. So in terms of the equation of a line, which we always want in this form, y equals mx plus c, we want to see this number being exactly the same. So these are all written in different formats. None of them are in the form y equals mx plus c. So we need to actually get them into that form y equals mx plus c. So let's have a look at this first one. And that says 2y. So in order to get that to be just y, we're going to have to divide everything by 2. So if we divide everything by 2, we get 1y equals 3x, I'm going to do 6 divided by 2, and then 5 divided by 2 is 2.5, or I could just leave it as a fraction if I want 5 over 2, which you can write as 2.5 if you like. So this line here has a gradient of 3. Let's have a look at the next one. Y plus 3x equals 5. Well, that's not in the y equals mx plus c format either, because this 3x is on the wrong side of the equal sign. So if we take away 3x from both sides, move that over to the other side, we get y equals -3x plus 5, just popping that plus sign in front of that 5 there. Again, we could have written it the other way around, but let's keep them all aligned. So that is a gradient of -3. So those two definitely aren't parallel. Let's just have a look at this last one. So 3x minus y equals 5. Now this isn't very nice because we've got a negative y here on the left hand side. So I might have to do 2 steps here because I'm going to add y to both sides to make sure that that's positive. So at the moment we have 3x equals y plus 5, or 5 plus y. Let's write y plus 5. And then again we need to get rid of this 5 now because we don't want that there, so we need to move this 5 to the other side. So take away 5 and we get 3x plus 5 equals y. Now it's written the other way around there, but we can rewrite that, we can swap the sides over. So y equals 3x plus 5 is our final answer for that one. And again, this one has a gradient of 3. So the top equation and the bottom equation both have a gradient of 3. So explaining which two are parallel, we would say line 1 and 3, as they both have a gradient of 3. And there we go, both have a gradient of 3. And that's that one finished. Now you can expand any two that you want to start with. I'm just going to go for the first two. So if we expand those to start with, let's have a look at what we get. So 2x plus 3 multiplied by x plus 4. Now if we expand that out, just following normal expansion rules, we get 2x squared plus 8x plus 3x plus 12 on that last bit there. Okay, tidying that up first. So tidy this up, simplify it down, we get 2x squared plus 11x plus 12. Now we can multiply it by the final bracket being up there, the 3x minus 1. So stick this in a bracket and multiply it by 3x minus 1. Again, just take your time with this, it does get quite messy when you're doing it. Okay, so just spend the time, make sure that you get each piece perfect. So let's move this out of the way. And let's just be really, really careful when we expand this now. So 2x squared times 3x gives you 6x cubed. And then 2x squared times minus 1 is minus 2x squared. onto the 11x. Let's go for a different colour. So 11x times 3x is 33x, so positive 33x squared again. There we go. And then 11x times negative 1 is a negative 11x. Two more to finish this off. 12 times 3x is 36x. Just about fit this in. And then 12 times minus 1 is minus 12. Right, there we go. We just need to tidy all this up now because we've got a lot of pieces there. We've got the 6x cubed at the start. We've got negative 2x squared add 33x squared. So negative 2 add 33 is 31. So plus 31x squared. Negative 11 add 36 is 25. So 25x squared. Sorry, 25x. And then the minus 12 at the end. And then do just go back, double check, make sure you've added up the pieces correctly. Just to make sure that you don't make any mistakes on that final part there. But that's expanding a triple bracket. Just remember to tidy up your first double bracket and then multiply it very carefully by the next one. Okay, so factorising a quadratic, and here we've got a coefficient bigger than 1 at the start. So we just need to have a think about how you do this. You can have 2, 3, 5, you can have any combination of numbers here. But in order to get a 2 at the start there, we're going to need 2x in one of our brackets, and then x in the other. And then we'll just follow the same process, write down the factors of 12, so 1 and 12, 2 and 6, 3 and 4. And we've just got to think, okay, well, one of these numbers is going to double and we want to make negative 5. Obviously, this one has a negative 12 at the end, so one's going to be positive, one's going to be negative. And when one doubles, we're trying to make that number 5 in the middle. So it's not going to be 1 and 12, because we can't make 5, particularly if we double the 12. We're not going to make 5 if we've got a 24 and 1. And we're not going to make 5 out of 2 and 12, so it's not that one. Let's have a look at the next one. Doubling the 2 would make 4, so 4 and 6. Can't make 5 out of 4 and 6. Doubling the 6 would make 12, and you can't make 5 out of 2 and 12, so that's not going to work either. Let's try the 3 and 4. Double the 3 would be 6. We can't make 5 out of 6 and 4, so it's going to have to be this last one. Doubling the 4, which is going to make 8, so 3 and 8, and that works. You could do positive 3, take away 8, that would give us negative 5. So we want the 4 to double, so we stick that in the opposite bracket to the 2x. We want that one to be negative, so stick a negative with that. And stick your plus 3 in the other one, and there is your factorised double brackets. Just remember as well, it could say actually to solve something like this, and you can solve by factoring. If it did say the word solve, then we'd have two solutions here. For this right bracket, it's nice and easy, you just flip the sign, we'd have x equals 4. And for this left bracket here, nice and easy again, it's still flip the sign, still 3, but because of this 2x here, it'd be minus 3 over 2, or minus 1.5. So if it did say solve, that would be an additional step that you could go about. You could say x is negative 1.5 and x is 4. Okay? Okay, so we've got rearranging or making x a subject here, and we've got two x's in our formula. So, I mean, we can have so many combinations of this question that you can have. The whole idea of this type of question, though, is that you get the x's on the same side of the equal sign, everything else to the other side. Now, obviously, the x's are on the same side of the equal sign at the moment, but we want to get rid of this fraction. So you might not have a square root in a question, but in order to get rid of this square root to start with, we need to square both sides. So if we square both sides, we get y squared equals, and then what's left under the square root, it's not going to change that, we're just going to have x plus 3 over x minus p. Now again, we've still got a fraction involved, so we need to get rid of this denominator. So whatever's on the bottom there, we're just going to times both sides by what's on the bottom. I'm going to stick it in a bracket because it's easier for me to move it. So x minus p, and times the other side by x minus p. Okay, so we've got a bracket on the left, we've got y squared, brackets x minus p, equals x plus 3. Now, as soon as we've got rid of this bracket, we can start to actually move the pieces out of it. So if we expand the bracket, we get y squared x minus y squared p, or py squared, however you want to write it, and that equals x plus 3. Now I can start to move the pieces either side. So let's go for, there's two ways of doing this one. At the moment, I could move the x's to the left or the x's to the right. Now what I'm going to do is I'm going to move the x's to the left, so I can get rid of this negative y squared p, or plus py squared. I'm going to rewrite it differently. So plus py squared to both sides. Let's bring this up here, and we get y squared x, or xy squared. I should have rewritten it there, it doesn't really matter. Add they over, so we get x plus 3 plus this new py squared over here. Now we can minus the x from both sides. We can get all our x's on the left, so minus x. So, and again, I will write this now. I'm going to write xy squared, I just prefer it. Xy squared minus x equals 3 plus py squared. And here's where this process starts to come in now. We can factorise this left-hand side so that we get 1x. So we'll get x brackets y squared minus 1 that equals 3 plus py squared, and then you can divide by this bracket here and slot it underneath the right hand side. So you get x equals 3 plus py squared over y squared minus 1. And there would be our final answer. Obviously there is an unlimited amount of different formulas that you could have to rearrange. So I'm only going to go over the one here because it involved a lot of different steps there, getting rid of a square root by squaring, getting rid of a denominator by timesing it across, putting it in a bracket in this second step. That was over here. And then we had obviously expanding a bracket, getting all the x's on the same side, factorising it to finish. I mean, you've got literally every possible step you could think of in this one. And so it is quite a difficult one there, but there's just an example of some rearranging and what to do when there's two subjects that you're trying to turn into the one. Okay, so working out the nth term for this sequence. So whenever you're working out the nth term of a sequence, this is a quadratic one. It doesn't say it in the question, but it is a quadratic. You hopefully can see that just by looking at it, because here it goes up by 4, and here it goes up by 6, and then here it goes up by 8. Okay, so because of that, we've got a second difference here. So the second difference is 2. Now, whenever you get a second difference, what you need to do is actually divide that second difference by 2. It's just something which happens with the square numbers. If you think about the square numbers, and this is why it's a quadratic sequence, 1, 4, 9, 16, the second difference comes out as 2. Let's have a look. So 3, 5, 7, and the second difference is 2. And that tells you that it's related to the square numbers, but it can be more than just the square, like one lot of the square numbers. So if we divide this by 2, it tells us it's 1n squared, or it's related to the square number sequence, which is this one here, n squared equals 1, 4, 9, 16. So what I always do is write down the square numbers now. Again, I know there are formulas for this, but I just really prefer this method. So 1, 4, 9, 16. But now if you have a look, there is actually a difference between the n squared sequence and the one going up there in the question. To get from 1 to 15, let's just write this down. What's the difference? To get from 1 to 15, that's plus 14. To get from 4 to 19, that's plus 15. And to get from 9 up to 25, that's plus 16. And this just carries on. Look, from 16 to 33 is plus 17. So not very nice. Look, if we had a constant difference, if they are all plus 14, then you'd just put n squared plus 14. But unfortunately they're not, so we can't do that. They're not all just plus 14. So when you get this scenario here, you've got to have a look at this sequence and think, okay, well, I'm going to have to just work out the nth term of that sequence. And the nth term of that sequence is, it goes up in ones. Look, 14, 15, 16, 17, it goes up in ones, so 1n, or n. And then it's obviously not the 1 times table, or if you know the little trick where you go back here, you take away 1, you'd get a 13 at the start. So it'd be plus 13, because it's 13 bigger than the 1 times table. So that sequence there has an nth term of n plus 13. So all you do is you just slot that at the end of n squared, so n squared plus n plus 13, and that would be your nth term of this quadratic sequence here. Okay, n squared plus n plus 13. You can get something slightly different here, like if you had a second difference of, if we just imagine this to the side, if you had a second difference of 4, so if it was 4, your sequence would start with 2n squared. And then you would have to write out double the square numbers. So instead of writing 1, 4, 9, 16, you would write 2, oh, what happened there? You would write 2, 8, 18, 32, and then you would compare the difference back to these numbers. Similarly, if it was 3n squared, if there was a second difference of 6, you would triple all the square numbers and compare it again. Obviously, just remember, if this comes out as a constant difference down here, that's great. You can just put that after the n squared part, or the 2n squared. But if it is a new sequence, you are going to have to forget about the rest of the question for a second and just work out the nth term of that sequence, and then slot that on the end. So our final answer there, n squared plus n plus 13. Okay, so this question says find the coordinates for the turning point of the graph with this equation. So to find the turning point, we have to do something called completing the square. And sometimes it might say write it in the form. It might say x plus a squared plus b. It might say write it in that form. Okay, and that just means completing the square, and it's how we find the turning point. So in order to do this, you have a look at the x coefficient, which is there, and we halve that number, and we stick it in the start of our bracket like this. So we have x plus 8 halved is 4 squared. And the reason you do that is because if we expand this bracket, if we think about it to the side, if we expand that bracket there, x plus 4, x plus 4. There we go. We would get x squared plus 4x, which would give us 8x, but we would get plus 16 at the end. So obviously it's similar to this part just here. We've still got the x squared, we've still got the 8x, but we've got plus 16. And we don't want plus 16, we want plus 3, because all we're doing is we're rewriting it as in a different form, in this completed square form. So in order to make sure 16 becomes 3, we would have to subtract 13 from this double bracket there. 16 take away 13, give us 3. So that is actually written in completed square form there, and that is how you do it. Now you don't have to fully expand the double bracket. You can just think, okay, well 4 times 4 is 16, that's the number I know I'm going to get at the end. So I'm going to have to take away 13. And our coordinates for the turning point are written within this. So the x coordinates in the bracket there, just like when you're solving, you flip the sign. So the x coordinate is negative 4 instead of positive 4. And the y coordinate here is just this number at the end. No flipping of the sign, just writing whatever's there, so minus 13. There you go, so the coordinate of our turning point is negative 4 and negative 13 for the y coordinate. And that's completing the square. Okay, a longer question here, we've got to solve the simultaneous equations. Now when we've got an x squared and a y squared, this actually represents the equation of a circle and the equation of a line. Okay, and that line would be, go sloping this way I believe, let's have a look. Okay, so when you get this sort of scenario here, you get two solutions because there's two crossover points. There is one scenario where you might get one solution, which is where it's a tangent to the circle if it just touches at one point. There could even be no solutions, but it would be unlikely we'd be asked to try and solve something with no solutions. So if we have a look at this, we've just got to basically sub one into the other, and we can sub this x minus y equals 2 into the equation of above. So if we actually do that, first of all we've got to rearrange it. Now there's two ways. I could make y the subject or x the subject. So I'm going to make y the subject, so I'm going to add y to both sides, which actually that would straight away make x the subject, so let's do that. X equals 2 plus y. Okay, you could even write that as y plus 2 if you prefer, and I'm actually going to do that, x equals y plus 2. Now what we can do is we can sub this little expression here, y plus 2, in place of the x in the first equation, this x squared. So if I just do that, so rather than writing x, I'm going to write y plus 2. So y plus 2 squared plus y squared equals 34. Right, so we've now got an equation that has no x's in, and we know that when we've got an equation that only has one unknown in it, we can definitely solve it. So if we actually go about expanding this first bracket here, I'm not going to write it as a double bracket, I'm just going to go for it. So y squared, we'll get plus 2y, so plus 4y, and plus 4 at the end. And then obviously we've got plus y squared equals 34. Now we can tidy that up, look, because we've got these two y squared pieces. So we can add those together just to make it a bit more tidy. So we've got 2y squared plus 4y plus 4 equals 34. And now we can only actually solve one of these, it's a quadratic, so we can only solve that once it equals 0 at the end, so we need to minus 34 from both sides. So if we minus 34, we get 2y squared plus 4y, and 4 minus 34 is minus 30, and that now equals 0. So we can actually go about solving this now. Now, if in this point here, if we've got a calculator, we could potentially use the quadratic formula, we could factorise it from here, but if you notice that all these numbers here all divide by something, we can simplify it down, because we can divide both sides by anything as the right hand side is just 0, it doesn't change it. So if we divide everything by 2, we get y squared plus 2y minus 15 equals 0, and it potentially just makes it a little bit easier to factorise there. Now if we go about actually factorising this, both are going to have a y in. And we're just thinking what numbers there multiply to make 15. So we've got 3 and 5 or 1 and 15. I'm not going to write down the 1 and 15 because I've already spotted it's 3 and 5. And in order to make 2, we need plus 5 minus 3, and that's going to give us positive 2 in the middle. So we've got two solutions going on here. Obviously it's just these numbers in the brackets, but flip the symbols. So we've got y equals negative 5. And we've also got y, I'm just about to write x there, y equals 3. So there's our two y solutions. We now just need to find our x solutions. Now we've got a nice little formula that we made right at the start here. To find x, we've got x equals y plus 2. So when y is 5, x will equal negative 5 add 2, which is negative 3. So x equals negative 3. And then for the next one, we've got y equals 3, so x equals 3 plus 2, so x equals 5. There you go, so you've got your two solutions and they're written in pairs there. We've got our first solution here, x equals -3, y equals -5. And we've got our second solution over here, x equals 5 and y equals 3. Okay, so there would be coordinates there. So it might be, if we think back to this graph, it might be that this coordinate where it crosses over is -3, -5. And this coordinate up here is 3, 5. Okay, so that's what it represents there when we're solving these simultaneous equations. And remember, that could be solved graphically as well. You might be given a diagram, drawing on a straight line and then just, estimating them or finding them exactly where they cross over. Okay, so there's solving simultaneous equations, and again, there's loads of different variants here. You might have two that have y squared in or y in, and you can set them equal to each other, but this is just one of the harder ones here where you've got to sub one into the other. Okay, so we've got some quadratic inequalities. So we're going to solve this. Now obviously these represent a parabola, a curve, a quadratic graph. Again, a quadratic graph here. Normally when we're solving them, we are solving to find these two roots here, or solutions, and you can be asked to represent to find them or to estimate them from a graph. If you've been given a picture, they're referred to as the roots. But when we're solving an inequality, we're looking at something slightly different. Now this first one here, and they're both exactly the same. We're going to have a look at the two different scenarios. This first one says less than 0. So essentially it's saying is what part of this curve is less than 0. Now if you have a look, this part of the curve is what's below ground, what I like to refer to, or less than 0, 0 being the x-axis there. So really all we're going to say is, well, what part of the curve is between these 2 points below 0? So if we actually just factorise this to find out what these two roots are, so putting it into a double bracket, again it might have a coefficient bigger than 0, but I'm just going for a nice easy one here just to show you the process. So the factors are 24, we can have 4 and 6, 2 and 12, 3 and 8, so I'm just going to not write them all down because I've already spotted it's 3 and 8. But that would be plus 3 minus 8, and that would give us minus 5. So our roots here, or our solutions, are x is -3 and x equals 8. So if we were to label those on the graph here, this would be minus 3 on the x-axis and this would be 8. Now the bit that is below the curve is between -3 and 8. So I'd have to write this as one of these types of inequalities. Okay, where we say it's between 2 points. And that would be my answer there. X is between -3 and 8, or the part of the graph that is under 0 or less than 0 is between those two numbers. Now that would change slightly for this one down the bottom, because I've just realised they're pointing the same way. That wasn't meant to be pointing that way. Let's change that. That's meant to say bigger than 0. Okay, so there we go. Sorry about that. Let's change that. X squared minus 5x minus 24 is bigger than 0. So this would be something slightly different now, because the bit that's bigger than 0, and if I just redraw this graph, there we go, 8 here, -3 here. The bit that's actually bigger than 0, we've got one part over here, and we've got a completely separate part over here. So we've got two separate parts of the line, and that means I can only write this as two separate inequalities. Now this part on the left is all this part of the curve is going to numbers less than 3. So my solutions there would be, well, anything that's less than 3. Sorry, -3. So x is less than -3. And that's one of my solutions for that part of the line. But I've also got the other part, and that is going to all the numbers bigger than 8. It's going this way. So my other solution would be x has also got to be bigger than 8. So I've got two ways of two solutions here to write with my inequalities. I've got all the x values less than -3 and all the x values bigger than 8. So that's solving a quadratic inequality. Just got to think about which part of the graph you're actually looking at. Okay, and we've got a question here that's shade the region that satisfies all of these inequalities, and we've got these three inequalities there. Now some of these are quite easy to draw, but when we're drawing these inequalities, if we just imagine us to start with that the inequality is an equal sign, it's just going to help us to actually draw the graph. So all I'm going to do is I'm just going to imagine that this one says y equals 2x plus 1. I'm going to draw that line. X plus y equals 4. I'm going to draw that line, and I'm going to draw the line y equals 1. Now the easiest one for us to draw there is y equals 1. Now looking at my graph here, you can't see the number 1, but it's between 0 and 2. Now on the y-axis, y equals 1 is at this point here, and that line y equals 1 is just a nice straight line going through y equals 1. So that's our first one drawn there. Done. The next one is x plus y equals 4. I'm going upwards now, so x plus y equals 4. Well, if x plus y equals 4, that's quite a nice line to draw, because that means when one coordinate's 0, the other has to be 4. So 0 on the x-axis gives us 4 on the y-axis, and 0 on the y-axis gives us 4 on the x-axis. So you've got a nice diagonal line there to draw between 4 on both the axes, and these x plus y equals a number always just connects up the y-axis and the x-axis to those numbers. So we've just got to do a nice neat diagonal going through with a ruler and a pencil, and I'll continue that all the way. Oh, that's not very good. I'll continue that all the way to the top of the graph there, just a nice diagonal going all the way through. So that's that one done. And the next one there is y equals 2x plus 1. Now you might know little tricks for how to plot these. If not, then I would suggest just drawing yourself a little table and picking some of the values. You probably get away with doing 2 or 3 values. But if we sub in some x values to find our y coordinates here, when x is 0, that would be 2 lots of 0, add 1, y is 1. So if I do this in a different colour, so when x is 0, y is 1, that gives us that coordinate there. Let's pick 2 or 3, let's just go a little bit higher. So when x is 2, 2 times 2 is 4, plus 1 is 5. So when x is 2, y is 5, and that is here. And we could go for some negative numbers as well now, but hopefully you can get a ruler and a pencil and join those up. Now it has a gradient of 2, so I can just look at that coordinate on the y-axis there and go across 1 up 2, which gives us that coordinate there. Cross 1 up 2 gives us the one we've already drawn, and I can follow that pattern backwards as well. But you can draw a full table out for this just to make sure you get it perfect. But there we go, there's my line. I just need to connect those all together nice and carefully with a ruler and a pencil. And there's our 3 lines drawn. Okay, now it says shade the region that satisfies all these inequalities. Now careful, because it's not always that little triangle there that's made in the middle. So I'm going to get rid of these equations now because I don't need them anymore, but I need to have a look at the inequalities. Now all I need to do is pick a coordinate and test it in these inequalities. So if we do pick this one in the triangle here, so this coordinate here, let's do it in a different colour. There's a coordinate inside the little triangle in the middle, which is the coordinate 1, 2. This coordinate here, well, x is 1 and y is 2. And if I sub them into these inequalities, as long as they all work, then that's the region I'm going to shade. So if I sub it into that first one there, x is 1 and y is 2, so y which is 2, is less than 2 lots of 1, which is 2, plus 1, so 2 is less than 3, and that works, that's correct. Moving on to the next one then, that one works, we've got to test all 3 though. X plus y is bigger than 4, so x is 1, so 1 plus y, 1 plus 2 is bigger than 4. No, that doesn't work. So it can't be inside that triangle there. Although what we have figured out is that the first one works. So in terms of that line, y is less than 2x plus 1 is my pinky red coloured line there. So it's got to be on the right hand side of that. So it can't be this region on the left. It can't be this region on the left. And it can't be this region on the left. So it's got to be one of the other 4. But it's not inside that triangle now, so we can put a cross in there as well. We know it's not that one. So we've got 3 left to have a look at. So if we get rid of this, and obviously always leave your working out down, but let's try another coordinate. So let's try one in this region here, as this one's on the top. So that coordinate there is the coordinate 4, 3. Okay, so this one here, 4 and 3. And if we test those out into all our inequalities and see if they actually work. So looking at the first one, we've got y is 3, so 3 is less than 2 lots of x, so 2 lots of 4, 8 plus 1. So 3 is less than 9, and that's correct, that works. Moving on to this x plus y is bigger than 4, so x is 3, so 3 plus 4 is bigger than 4. Well, that's absolutely correct. 7 is definitely bigger than 4, so it works in that one as well. And then on to the last one here, y is bigger than 3. Sorry, y is bigger than 1. The value of y is 3 there on that coordinate, so 3 is bigger than 1. Perfect, they all work. So it's got to be that region there. So we just have to shade this region in. It might say to label it R or something like that, but shade it in and there's your region done. So once you've drawn your lines, just pick a coordinate, test it out into your inequalities, and as long as they all work and they're all correct, then you can shade that region. But do be careful you don't just shade the region of the shape there, like the triangle in the middle, because it's very often not just the shape that's formed. Okay, so we've got solving a quadratic here, and it says give your answer correct to 3 significant figures. Now this gives you a massive hint here, 3 significant figures, that it doesn't factorise. And when a quadratic doesn't factorise, when we've got to solve it, in whatever scenario, we've got to use the quadratic formula. So one that you need to remember, you've got minus b, plus and minus the square root of b squared minus 4ac, all over 2a. And then what I do straight away is I write down the values of a, b and c. So a is 5, the one in front of x squared. So a equals 5. We've got b equals, and you've got to be careful because you've got to get the symbols in, the signs in with it, negative 11. So b is negative 11. And c is, again, that number at the end, negative 13. So first things first, we just need to put them all in the right place. So minus b will be, well, negative b. B is already negative, so that becomes positive. So b is 11. Plus and minus the square root of b squared, and we're squaring a number here, and it's negative, so stick it in a bracket, minus 11 squared. Take away 4 times 5 times negative 13, 4 times a times c. So 4 times 5 times negative 13. There we go, and you can stick that all in a bracket if you want, just depends on what calculator you're using. And that's all over 2a, which is 2 times 5, which is 10. Let's just write 2 times 5. Now if you've got a Casio calculator, which hopefully you do because they are the best ones for these higher GCSEs, then you need to just type that in as you see it. So press your fraction button, 11. Let's do plus. I'm going to do the plus version first. So I'm just going to do it once using the plus sign here, and then I'll do it again in a different colour using the negative. So 11 plus the square root of, in brackets, minus 11 close brackets squared, take away, in brackets, 4 times 5 times negative 13. Go on to the bottom of the fraction, and I'm just going to type in 10. And when I type that in, turn it back into a decimal, it says I get 1 which is 3.05192213. And then I'm just going to go back into my calculator, change the plus sign for the minus sign, and we'll write down what we get there. So back into the calculator. Takes a bit of a while to get all the way back through this, but it's better than typing it all back in again. Delete the plus, put a minus, press equals again, and I get the answer, negative 0.8519221296. There we go, lots of digits there. So obviously there are two solutions, one with the positive there, one with the negative. Then we've just got to round it, so it says 3 significant figures. So in the first one there, 3, 0 and 5 are my first 3 significant figures. So that would be 3.05 for my first solution. And the second one's a little bit iffy here because we've got a 0 at the start, so it's 1, 2, 3 after the 1. So that would be 0.852 because it's a 9 after it. There you go, and there's my 2 solutions written to 3 significant figures. Just be very, very careful when you're doing the quadratic formula that you do make sure of a couple of things. That is, one, when b is negative, make sure it flips this sign for the first one, and the second one is make sure you put these negative numbers in a bracket. Otherwise, it's gonna give you an answer of negative 121 there rather than the positive 121. Although if you are squaring a negative number, you could just put 11 squared and forget about the negative, but a little bit of a trick there. Okay, there we go. On to the next one. Whenever we get an algebraic fraction, though, we just need to factorise everything that we see, no matter what the question, whether you're times and dividing, it's just simplifying. Just factorise everything, and that can be quadratics with coefficients bigger than 1. We can have difference of 2 squares. We can have single brackets, but just look and see what can I do to factorise it. So the top there is no number at the end, so it definitely doesn't go into a double bracket. But the top, the 3x squared and the 9x both divide by 3, and they both have an x in. So we can simplify it. We can factorise it that way. So 3x times x gives us a 3x squared, and 3x times 3 gives us that 9x there. So that's that factorised on the top. Now if we have a look at the bottom, that has a number at the end but no x pieces in the middle, so that's a difference of 2 squares. The factors are 9, it's the 3 and 3, one positive, one negative, that's what cancels it out. So we have x plus 3 and x minus 3. There we go, and when we've got these common brackets on the top and bottom, we can cancel them out. So the x plus 3 and the x plus 3, we can divide the top and bottom by x plus 3. So we end up with a final answer of 3x over x minus 3. And again, you can have lots of different scenarios where you're simplifying an algebraic fraction. Again, there could be different sorts of quadratics or just single bracket factorising that you're doing. But there is the idea of how you simplify these. And no matter what question you see in algebraic fraction, you're normally always looking to factorise. Let's have a look at one more. Okay, so we've got some more algebraic fractions here. Now we're adding these together, so we need a common denominator. So I've got to solve an equation here, but I've got to get these algebraic fractions added together first before I can do that. So if we times both sides, or this left-hand fraction, top and bottom, by x plus 1, and also times the top by x plus 1, that's going to allow me to get a common denominator as long as I times the right by the left denominator as well, which is 3x minus 2, just following normal fraction rules there. So times that by 3x minus 2. Okay, and I've written that next to the top and bottom so I don't forget what I'm timesing by. So on the top there we get 8 lots of x plus 1, and we're going to add to that 6 lots of 3x minus 2. Now because I'm going to get a common denominator here, I'm just going to write that all over my double bracket, which is x plus 1 and 3x minus 2. There we go. Now we can go about expanding all of that and just get it all tidied up. So if I expand the top, we get 8x plus 8, and then we get plus 18x minus 12. And that's going to be all over this double bracket expanded, so x times 3x is 3x squared. I'm going to skip a step here, I'm going to do the minus 2x plus the 3x, minus 2 plus 3 gives me plus x, and then minus 2 at the end. There we go, that all equals 2. Before I set it equal to 2, I'm just going to tidy up what's on the top there. We've got 8x and 18x, which is 26x, and plus 8 minus 12, which is minus 4. And that's all over 3x squared plus x minus 2. So now I've got a single fraction with a common denominator, and that equals 2. Now we can go about actually getting this into a single line equation and removing this denominator. So I'm going to times both sides by this denominator here. I'm going to times that over, and that's going to put it next to this 2. So it's going to be 2 lots of 3x squared plus x minus 2. So if I rewrite this now as a single line, let's bring it up here, we get 26x minus 4 equaling, and let's expand this bracket here, 6x squared plus 2x minus 4. And if we rearrange this, I'm going to make it equal 0 on the left, so I'm going to minus 26x, and I'm going to add 4 to both sides. So I'm going to minus 26x and add 4, and that's going to allow me to get 0 over here. Obviously it's a quadratic and we need it to equal 0. It doesn't matter whether it's on the left and right, but we want to avoid having a negative 6x squared and having an extra step there. So 0 equals 6x squared. Take away the 26x from 2 gives us negative 24x, and then add 4 to that minus 4 gives us 0. So there we go, it doesn't have a number at the end. So we can actually solve this now. So I can solve this, but it doesn't have a number at the end, so it's not going to go into a double bracket, which it might do if it has a number at the end. So we might have two solutions like in that way, but I'm going to see what solutions I get this way. So if we factorise this to start with, I could actually simplify it. I could divide both sides by 6. And if I do that, let's see what we get. Divide both sides by 6, and we get 0 equals x squared minus 4 x. There we go. Now I can factorise it as well. I've just saved myself a bit of time there. So if I factorise it, we get 0 equals x brackets x minus 4. There we go. So now it's factorised. Hopefully remember as well, we've done this on a couple of other questions. This x value here has no number with it, so one of our solutions is x equals 0, and this one here we flip the sign, so x equals positive 4. And there's my two solutions, x is 0 and x is 4. And there we go, that's that solved. Obviously lots of different algebraic fractions that you could have. You could be timesing and dividing them, adding or subtracting them, solving with them. Okay, always just look to follow normal fraction rules, and obviously looking to factorise where possible in these questions. Okay, so looking at some iterations. Now this says using x to the n plus 1 equals 5 over xn squared plus 2, and then it gives us x naught equals negative 2.5, find the values of x1, x2, x3. So all this is a process to finding estimates to a solution of an equation. Now the equation is not given to you in this one, but it does give us this iteration formula. Now this little n plus 1 here just means to find the next estimate. So if you read that in words, it says to find the next estimate, you do 5 divided by, and this little xn here means the current estimate, so the current estimated solution squared, plus 2. And then it says with x naught equals 0, and x naught just means your starting number, and it says start with negative 2.5. This is quite nice and easy actually when you do these. All you've got to do is sub that number into the equation. So don't be put off by the language here. That just means to find the next number. So to find the next number, all we're going to do is in our calculator we're going to do 5 divided by, and this will give us x1, our first solution, that's what x1 is. 5 divided by the current number squared, so negative 2.5 squared. And again, you've got to be super careful here because you've got to put this in a bracket. So the current number squared, so when we're putting a negative number in, we want to put it in a bracket. And then plus 2. So to find the current number, to find the current solution, or the next solution, you do 5 divided by our starting number squared and add 2. So literally just typing that into your calculator. So open up your fraction button, make it look exactly the same as that, 5 on the top, negative 2.5 on the bottom squared, and then come out of your fraction and plus 2, or press equals and then add 2. Now you get a decimal for this, you get either a fraction 14/5 or 2.8. So there is our value of x1. Now obviously now that is our current solution, so 2.8 is our new number. So I'm going to repeat the process here, but instead of putting negative 2.5 in, I'm going to put this 2.8 in. So where I put it in here, that number is now just going to be 2.8. And it's quite a nice little trick you can do on the calculator here. As long as you don't press equals, you can do 5 over, and you can either type this number in, 2.8 squared, or you can just press your answer button. So there's an answer button next to your equal sign, usually just says ANS, and you can just put the answer in there. And it's a lot quicker if we have to do lots of solutions here, but for this one it's quite nice and easy for me to type it in, so I'm just going to write it. There we go. So you go back on your calculator, into your formula, make sure you haven't deleted anything, press your answer button, and it'll put 2.8 in for you. Press equals again, and again this is where the answer button comes in, because the number that we get here is absolutely horrible, and I'm going to have to write it all down. So it gives me the answer 2.637755,102. And that is my value of x2. Now I don't really want to write that in over and over again. You can do as long as you've written it all down, but because I can use this answer button now, I'm just going to not touch my calculator screen at all, and I'm just going to write down what x3 is. So on my calculator screen it currently says 5 over answer squared plus 2. So all I'm going to do is just very carefully, making sure you haven't deleted anything off your calculator, I'm just going to press equals again, and it gives me my next answer. It subs that 2.63 number in for me, and I get the answer 2.718622914, and it doesn't say to round them, so I write down all the numbers on my calculator display, and there they are. There's the values of x1, x2 and x3. Basically just subbing a number in, getting an answer, and then subbing your answer back in. So remember, these are estimates to the solutions of a particular equation. Now the equation wasn't given to us, but these are the estimates to the solution of that equation. Okay, so that's what we use iteration for, and there's your iteration. Okay, so we've got, and I can just see down here, we've got some graph transformations. So it says the coordinates of the minimum point of a curve are 3 and -5. Now there would be an equation for this curve, but it's not written down on this question. Okay, and it says write down the coordinates of the minimum point with these equations. So given that that line, that curve there has an equation, what we're going to do to the function over here. So there's a few rules to remember with this one. If the number in these functions over here is next to the x, or whether it is outside of the x and it's next to the y, let's say, there we go. So if it's next to the x, it does the opposite of what you'd expect it to do. We'll talk about that in a sec. Okay, and if it's next to the y, it does what you expect. We'll talk about what you'd expect in a second. Okay, if it's next to the x, it affects the x coordinate. And if it's next to the y, it affects the y coordinate. Well, let's have a look at this to start with then. So part A there, we've got a +2 next to the x. So it's going to affect the x coordinate, but it's going to do the opposite of what we'd expect. Now we would expect a +2 to add 2 to the x coordinate, but because it's in the bracket there, just like when you can sort of almost link this back to when we're solving and factorising, and when you get a bracket and you flip the symbol, it does the opposite. We can kind of almost link it to that. But what it does is it actually takes 2 away from the x coordinate. So that's going to mean it's going to be not 3, but 1. So 1 minus 5. There you go. Does the opposite of what you'd expect. We take away 2 from the x coordinate. Now on to the next one, and this is where this kind of has a little bit of difference going on. We've got a minus there. Now it's not next to the x coordinate, so we say it's next to the y. So as it's not next to the x coordinate inside the bracket, it affects the y coordinate. But a negative symbol there just flips the sign in front of the number. It doesn't do the opposite, or not do the opposite of what you'd expect with a negative symbol. It literally just changes it from negative to positive, or positive to negative. So it doesn't affect the x coordinate because it's not in the x bracket. So it stays as a 3, but the y coordinate goes to +5. There you go. So it changes it from -5 to +5. Okay, so the negative could be inside the bracket. If it was, it would change the symbol on the x coordinate instead. Look at the next one here. We've got a -3 at the end. No, it's not inside the bracket, so it does what you expect. And we would expect -3 to subtract 3 from the y coordinate. So it doesn't affect the x coordinate, but it does subtract 3 from the y coordinate. So -5 would go down to -8. There we go. Every time I'm just referring back to this coordinate here. And on to the last one. We've got 2x in the bracket, okay, for this one. So it does affect x because it's inside the bracket next to the x, but that means it does the opposite of what you'd expect, and that means 2 times x. So you would expect that to double the x coordinate, but if it does the opposite, it halves the x coordinate. That's the opposite of timesing by 2 is dividing by 2. So instead of it being 3, it would be 1.5, and it doesn't affect the y coordinate, so it would be -5. There you go. So obviously lots of different variations of this. You could be asked to draw the graph as well, but you can always just take this approach, pick a coordinate on the graph and see how it actually changes the coordinate. So it might be that you actually have to move it right, move it left, move it up or down, stretch it, or reflect it with one of these negative parts outside or inside the bracket. Okay, but always just remember these little rules. So if it is in the bracket next to x, it does the opposite of what you'd expect and affects the x coordinate. And if it's outside of the bracket, which I put next to y there, it does exactly what you'd expect, but it affects the y coordinate. Okay, so obviously different variations of these if we change our pluses and minuses. On to some algebraic proof. It says prove that the sum of the squares of 2 consecutive odd numbers is always 2 more than a multiple of 8. Now there's loads of different questions on algebraic proof, and again I'll have a video with lots of these different examples, but here's just quite a good one here. So it says prove that the sum of the squares of 2 consecutive odd numbers. So there's a few numbers that you need to know. So any number we refer to as n. An even number, well, an even number, if you get any number and times it by 2, it becomes even. So an even number in this proof we're going to say is 2n. Now to make a number odd, we can just think, well, okay, well, times it by 2 makes it even, and then add 1 to it. So an odd number is 2n plus 1. Okay, so times any number by 2, you get an even number, add 1 to it, and it becomes odd. So 2n plus 1 is our little expression we're going to use for an odd number, but it says the sum of the squares. So that means add them together and once they've been squared, and it's 2 consecutive odd numbers. Well, I've got one odd number there, 2n plus 1, so my next odd number would be 2n plus 3. Okay, to get to the next odd number we'd add another 2 to it, so it'd be plus 3 instead. So the numbers that I've got 2n plus 1 and I've got 2n plus 3, and it says the sum of the squares, which means we've got to square them. So I'll square them both, and the sum means to add, so we're going to add them both together. And again, lots of different variations we could have here, but we've just got to square these. So if I square this first one, that's a double bracket, remember, so we'd get 4n squared plus we'd get 2n and 2n, so 4n plus 1. And for the one on the right here, we'd get 4n squared again, but it'd be plus 6n plus 6n, so it'd be plus 12n, and then 3 times 3 is 9, so plus 9. Right, let's have a look what happens when we tidy this all up. So adding together the 4n squareds gives us 8n squared, 4n plus 12n is 16n, and then 1 plus 9 is 10. Now what I could do at this point is, if it had said prove that it's always even, or prove that it's a multiple of 2, I could just factorise it by 2, and that would show that any number that I sub in there would be multiplied by 2, but it doesn't say that. It says it's always 2 more than a multiple of 8. So I'm looking to try and factorise this by 8. And if you have a look, well, the first piece divides by 8, doesn't it? I can do that. Let's have a look. Divide that by 8, or factorise it by 8, we get n squared. The next one, we can divide by 8 as well. We get 2n. 16 divided by 8 is 2. But I can't divide this last piece by 8. 8 does fit in once though, doesn't it? But it leaves us a remainder, and my remainder would be 2. So if I think about that over here, if I split this number up, and you can do it like this or think of it as a remainder, but if I was to write plus 8 plus 2 instead of plus 10, the 8 would divide by 8, giving me this plus 1, and then I would still have this plus 2 at the end that I've not factorised. And that there proves that. It proves that it's always 2 more than a multiple of 8. If we subbed any number into this bracket here, so any number, it would be multiplied by 8, and then at the very end we would add 2. So that there proves it. Okay, we would multiply everything by 8, meaning it's a multiple of 8. That means multiplied by 8, and then at the end we would add 2. So that proves that any number we sub in there into this expression is always going to be 2 more than a multiple of 8, because we times by 8 and then add 2 at the end. And that's the end of that one there. Again, lots of examples on this that I've got a good video on. Okay, and the last one here, we've got a circle A has the centre 2, 5, and the point P, 11, 8, lies on the circumference of the circle. Find the equation of the tangent to the circle. Now what we know about tangents is they are perpendicular to the radius, okay? So a tangent is perpendicular to the radius. Let's think about that. Perpendicular to radius. Now it can help with these types of questions to draw a little bit of a diagram, just have a think about what this actually might look like. So if I have a think, a bit of an axis here, it says the centre's at 2, 8. So I'll draw a little sketch, not the best sketch here, but 2, 8. And it says the circle, point P is 11, 8. Let's imagine that's over here somewhere. So we've got a tangent coming off the circle, and that's what it looks like. So there's a few, that's a really bad centre there. Let's change that. It's a little bit better. There we go. So this is a really, really general sketch of what it might look like. Okay, and it says that the point, the centre has a coordinate 2, 5, which is there, and point P is up here 11, 8. Now, there's lots of information we can find on this question here, but let's just have a look and just see what it's actually asking. It says find the equation of the tangent. So in order to get the equation of the tangent, I need to know what the gradient of it is. If we think about the radius here, okay, bearing in mind that they're perpendicular, that's what we've already stated, it forms the right angle. Could we find the gradient of the radius? Now we've got these 2 points, so we've got 2, 5, and that definitely attaches to 11, 8, which is on the circumference. So I can find the gradient of those points. I can do the same as we did in the last question. I can do the change in y over the change in x. And that's change in y goes from 5 to 8, which is 3, and the change in x goes from 2 to 11, which is 9. So my gradient is a third. There we go. So my gradient, or m, is a third. So looking at the tangent, which is perpendicular, I can say that the gradient of that is, well, flip it over, would give us 3, change the sign, -3. So there's the gradient of the tangent. So if we stick that into our line equation, as the tangent is a straight line, we get y equals -3x plus c. And we know that it passes through this point 11, 8. Okay, otherwise it wouldn't be on the circumference of the circle there, which it says it is. That's where the tangent meets it. So what I'm going to do is I'm going to stick 11, 8 into the equation of the line, just like I did on the last question. So we get 8 as y equals -3 multiplied by 11 plus c. And again, exactly the same as the last question, we can solve this now. So 8 equals -33 plus c, times in those out, add the 33 over, 41 equals c. So now I've got the y-intercept of that line as well. Now if we put this all together, we've got our equation. So y equals -3x plus 41. There we go. And there's the equation of the tangent. A few other things that you could be asked about this question though. Let's have a look. There we go. You could be asked to work out maybe the length of the radius. So if we go back to our diagram over here, in order to get the length of the radius, we'd have to use a little bit of Pythagoras. So bringing that down there, you've got a little right angled triangle you can draw in, and it goes from 2 to 11, which was a run of 9 there, and a rise of 3, so you could do 3 squared plus 9 squared, so you could actually get the length of the radius there. What would that be? 3 squared is 9, 9 squared is 81, so square root of that is root 90. So you don't need it for this question, but you could say the radius is root 90. You could also be asked to write down maybe the equation of the circle or something like that, but just something else to be thinking about if you ever want to find the length of the radius. You can find it by using a bit of Pythagoras there. Not that we needed it for this question though. Right, okay, that's the end of algebra. Okay, so share £240 in the ratio 5 to 7. So if we're splitting this in a ratio, let's have a look. We've got in total here 5 plus 7 equals 12 parts. Okay, so if we split this into 12 parts, we could do 240 and divided by 12. And 240 divided by 12 is 20. So in each part there's £20. Now there was 5 parts and 7 parts, so those 5 parts are going to be 5 lots of 20. Which would be £100, and the other part there was 7 parts, and that times 20 would give us £140. So splitting it in the ratio 5 to 7 gives us 100 to 140. And the last little check you can do here is just to add these two together, just to make sure you do get that £240 that you started with. So we're happy with that as a final answer. So Craig and Ian share some money in the ratio 8 to 3. Craig receives £32. How much does Ian receive? Well, C to I, Craig to Ian, was in the ratio 8 to 3. And it said that Craig receives £32. So that is this first number 8 here, that is 32. So what we've got to think about is how do we get from 8 to 32? So 32 divided by 8, which we can do to the side, 32 divided by 8 is 4. So we must have times by 4 to get there. So if we do the same to the other side, times by 4, 3 times 4 is 12. So there we go. How much does Ian receive? Ian receives this 12. So I'll just say £12. Final answer. So Emily and James share some money in the ratio 4:7. James receives £21 more than Emily. How much do they share between them? So Emily to James is in the ratio 4:7. Now it says that James receives £21 more, and if we look at these two numbers here, from 4 to 7 is an extra 3 parts. There you go, it's an extra 3. So that extra £21 is 3 parts. So if 3 parts of this ratio equals £21, then 1 part must be, to divide that by 3, must be £7. And from there we can work out how much they both receive. If it was 4 to 7, let's get rid of this little bit down here. And each part is now worth £7. Well, 4 times 7 gives us £28 for Emily, and 7 times 7 gives us £49 for James. So Emily receives 28 and James receives 49. It says how much do they share between them. So if we can add these together, it gives us the total amount. So 49 plus 28 gives us 7 and 7, so £77. There we go, so they share £77 between them. A to B is in the ratio 3 to 5 and B to C is in the ratio 2 to 1. Work out the ratio A to B to C. So if we write out A to B to C and start to write what we've got so far. Now it says A to B is in the ratio 3 to 5 and then it gives us B to C. So there's an overlap in these, there's a B in both. So I can't put another number just over the top of the 5, so I'm going to start a new level. I'm going to write the other one underneath. So B to C is 2 to 1. Now looking at this, if I can make these middle numbers the same, I can merge these ratios together, I can squish them together essentially. So let's think, 2 and 5 can make 10. So if we times the top one by 2, that would make that 5 a 10, and we'd have to times the bottom one by 5. So if we times the top one by 2, that 3 becomes a 6, and the 5 becomes a 10. Looking at the one below, timesing that by 5, 2 times 5 makes 10, which we've already got in the middle, and 1 times 5 is 5, and there's my ratio A to B to C, 6 to 10 to 5. Just have a look to see if you can simplify in any of these questions, but it doesn't actually ask us to simplify it there. So a mobile phone costs £480 in the UK and the same phone costs $600 in America. The exchange rate is £1 to $1.29. Where offers the cheapest price? So we have two options here. We could put them both into pounds or we could put them both into dollars. I'm going to decide to put them both into pounds. So as we can see, we've already got the cost in the UK is £480, but we're going to have to convert this $600. So looking at our exchange rate, the actual number itself, we get a bigger number in dollars. So we know that our answer here is going to have to get smaller. So we only have one decision to make, and that is either we times or we divide by this 1.29. Okay, so it's times or divide. Okay, but we know logically we're going to get a smaller number in pounds. So let's go for this. When we do convert back, we are going to divide. So it's going to be 600 divided by 1.29. And we'll do that on the calculator. 600 divided by 1.29 gives us, not a very nice number here, £465 and 12p to the nearest penny. Now it doesn't matter about all the decimals after that, because at the end of the day we're looking at which offers the cheapest value, and as you can see there, £465.12 is cheaper than 480. Obviously there is another way of doing this. We could convert them both into dollars. So instead of doing that, what I could do is times this number here by 1.29, and 480 times 1.29, if again we work that out on the calculator, gives us an answer of, in dollars, $619.20. And again, that's more than $600, so again we would state that it's cheaper in America. In a store, you can buy 2 kilograms of washing powder for £3.40 or 5 kilograms of washing powder for £7.20. Which size is best value for money? Now, there's two ways of doing this. I always like to split the page up. So we've got 2 kilograms or we've got the 5 kilograms. Okay, and the 2 kilograms is £3.40 and the 5 kilograms is £7.20. Now we can either build this up to the same amount of kilograms for each, so we could think actually, well, what if we bought 10 kilograms of each? Well, that would be 5 of these would be 10 kilograms, so if we times £3.40 by 5, we get £17. Or we can have 2 of these, and that would be £14.40. And it's quite clear to see there that if we buy 10 kilograms of each, the 5 kilogram one is our cheaper option there. So we just make that statement, the 5 kilograms is cheaper. There is another way of doing this as well. So if we think along the lines of something easy, let's imagine 2 apples cost £1. So 2 apples equals £1. Well, to work out the cost of 1 apple, we would do the amount of apples divided by the cost. Sorry, the cost there divided by 2. So we would do £1 the cost, and we divide it by 2 apples. That will give us 50p per apple. And we can apply this same logic up here. So we can do the cost of each divided by the amount. So for the first one, looking at the 2 kilograms and £3.40, so we can do £3.40 divided by 2, and that gives us £1.70 per kilogram. Okay, per kilogram. We can also have a look at the next one in the same way, so £7.20, and we can do £7.20 divided by 5, and that gives us, let's have a look, £1.44, so £1.44 per kilogram. And again, you can see which one's cheaper there per kilogram. It's the £1.44, again, the 5 kilogram box. So 2 different ways, one non-calculator, one with a calculator, to work out a better value. 3 tins of beans and 4 jars of jam weigh 2,080 grams, and the total weight of 5 tins of beans is 1,800. Work out the weight of 1 tin of beans and 1 jar of jam. Well, straight away we can work out the weight of 1 tin of beans from this, because it says 5 tins of beans is 1,800. So if we do 1,800 and divide it by 5, we get the answer 360. There we go. We might have to do a bit of bus stop for that, but we can do that. 5's into 1,800. 5 into 18 goes 3, remainder 3. 5's into 30 goes 6, and then 0, so 360 grams, and that is for the tin of beans. So tin of beans. There we go. It then says 3 tins of beans and 4 jars of jam weigh 2,080 back in the first line. So if we work out the weight of 3 tins of beans now, well, 3 of those would be 360, 360 and 360. And if we add those all up, we get 9, 10, 1,080. So that's the weight of those tins of beans. So if we subtract that away from this original amount, so 2,080 take away 1,080, that leaves us with 1,000 grams. So those 4 jars of jam, so 4 jars equals 1,000 grams, and we want to know the cost of 1. So we can divide that by 4, and it gives us 1 jar equaling 250 grams. So there we go, 1 jar is 250, and 1 tin of beans was 360. Right, so 180 grams of copper is mixed with 105 grams of zinc to make an alloy. The density of copper is 9 grams per centimetre cubed, and the density of zinc is 7 grams per centimetre cubed. Work out the density of the alloy, which is just a mixture of metals. Now, whenever we've got this sort of mixture going on with mass, density and volume, I like to tidy it up in a 2-way table. First things first, we definitely need to make sure we write down our formula. So density equals mass over volume. Okay, and you can stick that into a formula triangle if you want, which I am going to do. So density, mass, volume. There we go. So drawing ourselves a little 2-way table to tidy this up. Let's have a look. Now for each thing we're going to need a density, we're going to need a mass, and we're going to need a volume. We have the copper, we have the zinc, and we have the alloy. I'm going to split this all up into a table. Right, so let's fill in what we've got. We've got a mass of the copper of 180, we've got a mass of the zinc of 105. It also gives us a density of the copper, which is 9, and a density of the zinc, which is 7. And it wants us to work out the density of the alloy just here. Now we can't add these densities together because the density is going to change as they're mixed together. So if one's 9 and one's 7, the density is going to be somewhere in between that. But what we can work out is the volume of the copper and the volume of the zinc. So looking at your formula, to get volume, we would do mass divided by density. So mass divided by density. So I'm going to do 180 divided by 9 for this one, which gives us a volume of 20. And for the zinc, I'm going to do 105 divided by 7. And 105 divided by 7 is 15. Now masses and volumes can be added together, so we can add these together. We've got 20 and 15, so 35 centimetre cubed is going to be the total volume of this alloy. And we can add masses together, so adding these two together as well. We can do 180 plus 105, which is 285 grams. And then we can finish this question off. It wants the density. Remembering density over here is mass over volume, so 285 divided by the volume, which is 35, and 285 divided by 35 gives us not a very nice number here, but we get 8.142857. It's actually a little recurring number there as well. Now this question would normally ask you to write that to 1 or 2 decimal places, so we would just round it however the question actually asks. But if it doesn't ask us, we write down the full number there, which is 8.14257 with those little recurring dots. So a car has to travel 30 miles along a motorway in 24 minutes. Will the car have to travel faster than 70 miles an hour to get there in 24 minutes? Now I'm going to do this as a non-calculator one, then we'll have a look at one that's maybe a little bit more calculator based. But if it has to travel at 70 miles an hour or more, now 70 miles an hour means that we go 70 miles in 60 minutes. So 70 miles equals 60 minutes. Now what we can do is we can actually start to break this down. So if I have a look, what can I divide both sides by? So if I can divide both sides by 10, that would mean I would go 7 miles in 6 minutes. Okay, dividing that by 10 as well. So you can have a look to see if you can ever break these down this way. So 60 divided by 10 gives us 6 minutes. There we go. Now it says we've got to go 30 miles and we've got to go there in 24 minutes. Now just having a look at this speed here, 7 miles equals 6 minutes. So travelling at this speed, if I wanted to get to 24 minutes, have a look, 24 minutes, we would times that by 4. So if I do the same to the other side and times that by 4, that gives us 28 miles. So travelling at 70 miles an hour, in 24 minutes we would go 28 miles. And the question said a car has to travel 30 miles. So it's not actually going to be able to make that 30 miles in 24 minutes, it's only going to be able to go 28 miles. It would have to go over 70 miles an hour. So I would make obviously that statement no. Okay, it's only going to go 28 miles, or it's not going to be able to do it in that sort of speed. David travels from Birmingham to Glasgow. He drives at an average speed of 70 miles an hour for the first 3 hours, and he then drives an extra or a further 150 miles at an average speed of 30. Work out his average speed from Birmingham to Glasgow, so for the whole journey. I'm going to take a similar approach as I did to the density question here, but I'm going to think about obviously using my formula now. So I want to write down my formula, which is speed equals distance over time. And again, we can put that into a formula triangle if we want. Now I'm going to do that. So speed equals distance over time. So speed, distance, time. I'm going to use a little formula triangle. So let's see if we can tidy up what we've got here in a little two-way table. And again, for each one, we're going to need a speed, we're going to need a distance, and we're going to need a time. Now we've got the first part of the journey, the second part of the journey, and we've got the total journey. So let's split this all up and write in what we've got so far. Okay, so at the moment we have, he drives at an average speed of 70 miles an hour for the first 3 hours. So this first one here is 3 hours and he drives at a speed of 70 miles an hour. The second part, it says he drives 150 miles, which is a distance, and he drives at an average speed of 30 miles an hour, so that's going to go just above there. And we want to work out essentially the average speed for the whole journey, which is this one just here. Now again, we can't join together speeds, it's going to be somewhere there in between the 70 and the 30. So let's have a look at what we can do. So this first distance here, let's see if we can work that out. So looking at our formula triangle, distance is speed times time. So we can do speed times time to work out that distance. So 70 times 3, the speed of 70 times 3, says it will go 210 miles. So again, we can add these together to get a total distance at the end there, because that would be 360 miles in total that he's got to do. So all we've got to do is get this total speed here, this total time, and then we'll be able to work out his speed. So looking at this bottom one here, which is the time for the second one. So to get time, you do distance divided by speed. So distance divided by speed will be 150 divided by the speed of 30, which gives us a time there of 5. So that means in total he's going to be driving for 8 hours. Now we can work out his total speed because we've got his total distance and his total time, and speed is distance over time. So it's 360 divided by the total time of 8 there, and 360 divided by 8 gives us an answer of 45 miles per hour. So I'll just write that down, 45 miles per hour. Again, keeping it all nice and tidy in a table so it all makes sense. We've got some proportion here. 6 taps take 3 hours to fill a tank with water. How long will it take 9 taps to fill the same tank? And then we're going to state any assumptions that we've made. So if 6 taps take 3 hours, it will take 6 times as long as that for 1 tap. So 1 tap would take 3 times 6, which would be 18 hours. It takes 6 times longer. So 1 tap takes 18 hours. So from here, if we know how many taps we've got, we can just divide this 18 hours by however many taps. If we have 2 taps, we can divide it by 2, which would give us 9 hours. We could do 3 taps, divide it by 3 would give us 6 hours. But this particular question here said that there's 9 taps. How long would it take 9 taps? So if we do 18 hours divided by the 9 taps, it gives us a total answer of 2 hours. So these questions are all about working out first, how long would it take 1 tap, or whatever this question's actually about normally. So it says state any assumptions that you've made. Well, I've assumed here that all these taps are running at the same rate. Okay, that's my assumption. All taps run at the same rate. There we go. So obviously in that original statement there, 6 taps take 3 hours, while one of those taps might be running a lot faster than the other, and that would change our answer. So we are assuming that all the taps are running at the same rate. Okay, I'm looking at some ratio and proportion now. So this says James has a bag full of counters. He takes at random a sample of 20 counters, marks them all and puts them back into the bag, and then he takes 30 counters at random, and out of the 35 of them are marked. Estimate how many counters are in the bag. So we're looking at capture, recapture here. Now if we just make a few statements, because we're going to assume that the sample is proportional to the next one that he took as well, or to the rest of the counters in the bag. So initially, he takes a sample of 20 counters out of we don't know. That's what we're trying to work out, so let's call that 20 over x. On the next time, he takes a sample of 30 and 5 of them are marked. So we'll say that that's now 5 out of 30. So out of the 35 were marked, but previously it was 20 that were marked out of something we don't know. But we are going to assume that these are proportional. So in order to work out how many that x value is, we just have to think, okay, well, how do we get from 5 to 20? And we do that if these fractions are equivalent by multiplying by 4. So in order to get that number on the bottom there, we would multiply this by 4, and that would give us 120. So our answer would be 120 counters. Okay, obviously we are making some assumptions here. We are assuming that no additional counters were added to the bag in between the 2 samples, and also none were taken out as well. And obviously there's little silly things like we're assuming that the marks haven't actually come off the counters or anything like that in this time frame. Okay, so that is capture, recapture there. Okay, on to some direct and inverse proportion. So there's 2 formulas that we can use here. It says A is inversely proportional to B. So it's either going to be A equals K lots of B, or A equals KB, or it's going to be A equals K over B. So these are the 2 that you have to remember. Now with inverse proportion, it's this one here, where K is being divided by B. So we're going to use that formula, so just make sure you write them down straight away. And then it gives us some values to put in. So it says 15 for A, so 15 equals K over, and it says B is 4. So we can solve this for K. We can times both sides by 4 to isolate K there, and we get 60 equals K, or K equals 60. And now what we can do is we can put that 60 back into the original formula here, and that will give us our formula. So A equals 60 over B. And that is a formula for A in terms of B, and sometimes you might just be asked just to write a formula for A in terms of B, and there it is. But this question says find the value of A when B equals 12. So all I've got to do is stick B equals 12 into my formula down here. So if we do that, I'm going to do it to the side, we get A equals 60 over 12, and 60 divided by 12 equals 5. So our final answer there is 5. So every time you just think which formula we're going to use, plug your pieces in, find your value of K, and then reuse that in your formula for whatever values you need. Okay, so we've got one of these questions with lots of ratios going on. It says in a bag of shapes are either circles or squares, and then they're white or black, and gives us some ratios about them. And it wants us to work out what fraction of all the shapes are white. Now if I start to break this information down a bit, it says fraction, so I'm going to just start to turn these into fractions. Now it says we've got circles and squares, and that's in the ratio 3 to 5. So in total that's 8, so we've got 3/8 that are circles, and 5/8 that are squares. And then it gives us some information. So it says the ratio of black circles to white circles is 5 to 7. So if we have a look at this, we've got black and white, and that is 5 out of 12, 5 plus 7, and 7 out of 12 for the white ones, okay? Then it goes on to the squares, so we've got 1 to 3, and again that's black to white. 1 to 3, so it's 1/4 and 3/4. Now if I treat this just like a probability tree, because it asks me for the total fraction, so if I think, well, what's the probability of picking a white, a white shape? So if we have a look at the circles, we can go through the 3/8 and down the white shapes there to 7/12. So just like on a probability tree, we would do 3/8 and multiply it by 7/12, and that's going to tell me the fraction of circles that are white. I can do the same with the squares, so 5/8 multiplied by that one there, 3/4. So 5/8 multiplied by 3/4, and that's going to tell me the fraction of squares that are white. Now if we work these out, timesing fractions is nice and easy. So timesing the top, let's just move this to the side a little bit. So timesing the top there, we would get 21 over 96. Timesing these on the right, we would get 15 over 8 times 4, which is 32. And there's our two fractions. Now just like with probability here, we just need to add these two together, which means we need a common denominator. So not very nice, but you might have spotted here that this fraction simplifies. And if we divide the top and bottom by 3, 21 divided by 3 is 7, and 96 divided by 3 is 32. So actually we can now add these two fractions together. We've got 7 over 32 here and 15 over 32 here. And if we just add those together to finish that off, now that there's a common denominator, 7 over 32 add 15 over 32 gives us a final answer of 22 over 32. And again, you could even simplify your answer there if you want. It doesn't say to, but if we halve both of them, because they both divide by 2, we get 11 over 16. So completely up to you there. We've got two different answers, 22 over 32 or 11 over 16 would be a fine answer there. But obviously in that scenario it's quite nice because one simplified to make a common denominator. If not, you just have to apply your normal fraction rules there to get your common denominator. On to some equivalent ratios here. So when ratios are equivalent, if we think about this logical idea here, 1 to 2 is also equivalent to 2 over 4. Now we can apply a little trick here, because if that is true there, we can also make the statement that 1 over 2, the left over the right, is equal to 2 over 4. And we know that that's correct, isn't it? 1/2 is equal to 2/4. And I'm going to apply that same trick to this question here. Even though we're involving some algebra now, we've got 3x plus 5, that's not a 3, we've got 3x plus 5 in the first one. So 3x plus 5 over the second one there, x plus 4, is equal to the first one, 2x plus 4 over x plus 2. And there we go. Now we've actually got an equation that we can solve. So this is more of an algebra question, but it's a trick with the algebra there. With the ratio. So what we can do, and we've got two fractions either side, we can cross multiply. So I'm going to times the x plus 4 up to this side and times the x plus 2 up to the top of this one. So we get a double bracket. We get 3x plus 5 multiplied by that right denominator, x plus 2. And that is equal to 2x plus 4, what's on the top of there, multiplied by that left denominator, which is x plus 4. So all we need to do now is expand both these brackets out. I'm going to do this in quite a quick step. So the first one, we get 3x squared plus 11x plus 10. And on the right one here, we get 2x squared plus 12x plus 16. So we've got quadratics here and we just need to make it equal 0. I'm going to do this in quite a quick step. I'm going to move everything here on the left hand side to the other side. So I'm going to minus 2x squared, minus 12x and minus 16, and that's now going to equal 0. So 3x squared minus 2x squared leaves us with x squared. 11x take away 12x leaves us with 1x, so minus 1x, and 10 take away 16 is minus 6, and that now equals 0, and then we can solve it. So all I did was minus 2x squared minus 12x and minus 16 from both sides, so that equals 0. Now we can solve it. So looking at this now, I just need to factorise it. So the factors of 1 and 6 are either 1 and 6 or 2 and 3, and it's going to be 3 in the middle there, so it'd be x plus 2 and x minus 3, and that would give us minus 1 in the middle, and that's what equals 0. So we've got two solutions here, which is why it says find the possible values of x. We've got this solution here, you got x could equal minus 2, and you got the one to the right of that as well. You got x could equal 3. So there's your two solutions, x equals 2 and x equals 3. Finish that off. Last question here, we've got a speed time graph, very similar to a velocity time graph as well, similar process in what we do. So part A says find an estimate for the distance travelled in the first 10 seconds. We know that our formula, speed is distance over time. So actually working out distance is speed times time, which just means all we have to do is work out the area underneath the graph. So normally it would say to split this into equal widths. Okay, I haven't actually added it to this one, but we're going to split it into 5 equal widths. So along the bottom, along the time, it goes up to 10. So each bar I'm going to draw in, I'm going to split it at 2. So every 2 seconds, I'm going to split the shape up and draw it in. Here we go. And I'm going to connect those up together here to make the shape. So I've got a triangle there, a trapezium, another trapezium, another trapezium, and a final trapezium there. Now this is going to be quite awkward for me to do on here, but I'm going to give it my best shot. So the height of this triangle, I'm going to write them all in because the base of all these shapes is 2. But I just need to work out the area of all these shapes. So the height of the triangle there, as best as I can see, looks like 27. So the height of that is 27. The height of the next trapezium, as best as I can, is 44. You just need to be super accurate with these. The height of the next one is 50. The height of this next one here is what looks like 44 again to me. And this final height at the end here is 20. So what I need to do is work out the area of them all. So I'm going to label these up 1, 2, 3, 4 and 5 and work out the area of all these shapes. So shape number 1's a triangle, so base times height, 2 times 27 and halve it is 27. So just having a look at the units here, it's metres per second, so the shape 1 is representing 27 metres. Shape 2, we've got the area of a trapezium here. Don't forget the area of a trapezium formula, which is add together the parallel sides, or a plus b, divide it by 2 and then times it by the height, which in this case is the distance between them. Now it's really nice when you've got a distance of 2 between them, because actually dividing by 2 and times by 2 cancel each other out. So actually you just have to add up those 2 parallel sides. So for number 2, 27 add 44 is going to give us 71 metres. Again, plug it into this formula if it doesn't have a width of 2. Number 3 is going to give us 94, 44 plus 50, so 94 metres. Number 4, 50 plus, number 4 is the same again, 94 metres again. And then number 5 is 44 plus 20, so 64 metres. So all we need to do is add them all up, which I'm going to do on the calculator. So adding all of those up, we've got 27 plus 71 plus 94 plus 94 plus 64. And that gives us a total distance there of 350 metres. Right, there we go, just adding them all up. Let's put that down the bottom there, 350. Okay, so one more thing that we could have a look at on here, and it's part B. It says work out an estimate for the acceleration at 2 seconds. Now this is a bit awkward to do on the same graph, but what I'm going to do is I'm just going to get rid of some of the drawings here around the 2 second mark. Now in order to get an estimation for the acceleration, we've got to draw a tangent at this point here, and that can be awkward. I've obviously just gone up from 2 there to find out where that is. So you just got to get your ruler really carefully and make sure that it just touches at that point and then skims off. Now it's very hard for me to do on the screen here, but that's it, drawing a tangent there. And then all you need to do is draw a little triangle underneath or above and work out the rise over the run, or the change in y over change in x. Okay, so if I just draw this in, and a little tip if it's a non-calculator is to try and get that change in x to be 1. So I'm just going to have a look to see if I can actually do that. So if I go from here, I go across 1, 2, 3, 4, 5 squares. That's a change in x of 1, and I get that distance there, which for me actually perfectly goes to 10. So it's going to be different on the paper because it's quite hard to do it on here, but that gives me a 1 and a 10. And obviously to work out the gradient, you do the change in y over the change in x, and mine comes out as change in y is 10 and the change in x is 1, and it's sloping upwards, so it is positive. And that gives me a gradient of 10. So in terms of an acceleration here, my acceleration would be 10 meters per second squared. And that's your units for acceleration there. So 10 meters per second squared is my acceleration. Right, and that's the end of ratio and proportion. Okay, so moving on to probability. So we've got here, Emma has a bag of shapes, and in the bag there are 8 red cubes, 7 red spheres, 5 blue cubes and 12 blue spheres. Emma's going to take 2 shapes out of the bag, and she's only allowed 1 sphere, 1 cube, 1 red shape and 1 blue shape. how many different ways can she select them. So we're looking at the product rule for counting here in combinations. So all we have to do is think about here, how many options does she have on the first pick, and we're going to multiply it by the amount of options on the second pick. Problem is we've got this scenario here where she's only allowed one of each shape and one of each colour. So if we think about this at first, if she takes a red cube, then she can't take another red shape, so she can't take any of those red spheres, and she also can't take any of the blue cubes because she's only allowed one red shape and one cube. So if she takes a red cube, the only other option on the next pick is to take a blue sphere. So for that first option there, she has 8 on the first pick out of the red cubes, multiplied by 12 of the blue spheres. So 8 times 12 would give us the amount of combinations there that she can get for the first pick, and that's going to be 96. So she could take that combination there of red cube and a blue sphere. Now alternatively, she could also take, on the first pick, she could take a red sphere, and that would mean on the next pick she can only take a blue cube to enable her to only have one of each shape and one of each colour. So that would give her a total amount of combinations there of 7 on the first pick there if we took a red sphere, multiplied by 5 of the blue cubes, and that would be a total of 35. So she has 2 different ways of picking these shapes. We've got 96 options on the first and 35 on the second. So if we add all these different options together, 96 plus 35 would give us a total amount of combinations here of 131 to meet that criteria of only having one shape and one of the colours for each one there. So one sphere, one cube, one red shape and one blue shape, and that's combinations there. You just got to remember how many choices are there on the first pick, and you multiply it by however many choices there are on the second pick, and then combine any if there are multiple different ways. Okay, so starting this off, we're having a look at working out the length AB. I've got 2 different triangles here, 2 different questions, so let's identify where AB is on the first one. So A to B is this length here. Now when it comes to right-angled triangles, if we've got no angles involved, we can use Pythagoras to work out the missing lengths. So Pythagoras Theorem is A squared plus B squared equals C squared. Now that C represents this longest length here, which we call the hypotenuse, so this is the hypotenuse. I'll label as HYP, so the hypotenuse, and we've got the shorter sides A and B, so 4 and 7. So to work out this length of this hypotenuse, we're going to do 4 squared, add 7 squared, and work that out on the calculator. So 4 squared plus 7 squared is 65. Now that is obviously the length of C squared, so to find out what C is, we just need to square root our answer. So to finish that off, square root of 65, which gives us a decimal for this particular answer, and that gives us a length of 8.06225 and some more decimals. And again, if it asked us to round it to 1 or 2 decimal places, we'd do that in the question. Now moving on to the next one, we've actually got the length of the hypotenuse this time, so we've got 13. And we're trying to find out this length this time, so A to B this time is one of the shorter sides. So rather than add them together like we did down here, we're just going to subtract them. So we're going to do 13 squared, take away this shorter side, which is 12 squared, and again we're going to square root our answer. This is quite a good one because it's actually one that could be done without a calculator. We get 169 for 13 squared, take away 144, and 169 take away 144 is 25. Okay, so as you can see, that's given us a square number. So when we finish this question off, to do the square root of 25, we get the answer 5. This is all in centimetres, so that'd be 5 centimetres. So over here our answer would be 5 centimetres. Okay, so Pythagoras, square the sides, add them together before square rooting for the longest side, and subtract them for one of the shorter sides before square rooting. Okay, so working out the size of angle X, again I've got 2 here, and we're looking at parallel lines. As you can see by these arrows here, these lines are parallel. So there are 3 rules that we're going to really look at when we're looking at parallel lines, as well as all our normal angle rules. We've got alternate angles, corresponding angles, and co-interior angles. So if we look at this one on the left here, 110, there's lots of angles we can find now. So all around this point here, we can find all of these angles. Vertically opposite the 110 is also 110, and then next to the 110 on the straight line there, remembering angles in a straight line add up to 180, these would all be 70. There we go. So it's up to you really how you actually find this final one. I'm going to have a look at finding this Z shape here, which is an alternate angle, and alternate angles are equal. So this 70 here is the same as this 70 here. So x would equal 70 degrees in this one. And we've normally been asked to give our reasons there. So my reason may have been angles on a straight line equal 180, and that's how I got the 70. And then I would have said alternate angles are equal, and that's really important the way you say that. So alternate angles are equal. Okay, there are also other ways that I could have done that. If I flick to another colour, we could have said, okay, well if this is 110, well then this here is also 110 because those angles are corresponding. And again, I'll try and draw this on a different colour, but they make this F shape, okay? So that 110 and that other 110 are corresponding angles. So we could have done it that way and then done angles on a straight line. Let's have a look at this other one. So 105 degrees down in the bottom here. So straight away, just above that, we can find that this angle's 75 because angles on a straight line equal 180. Now, if you have a look, we've got a triangle in this question. Now, there's these two symbols here, which tell us that this is an isosceles triangle, and base angles in an isosceles are equal, and it's underneath these two little, what I call little eyebrows. Okay, so underneath, this will also be 75 because base angles in an isosceles are equal. We can then find this missing angle here because angles in a triangle equal 180. So those two 75s equal 150. And if we take that away from 180, it leaves us with the other angle in that triangle being 30. There we go. And there's all the angles that we found just using basic angle facts. Now to get that angle x, there's a couple of ways we could do it. We could find this angle here and then do angles on a straight line. Or we could again identify that actually we've got one of these alternate angles going up, making this Z shape again. So that's an alternate angle with the 30. So that's 30 degrees as well. So for this one, we'd say x equals 30. And again, we'd probably give this same reason over here that alternate angles are equal. Unless, of course, we took a different approach, which we could have done. Again, lots of different ways that you can tackle these questions, but a few there that you need to make sure that you try and remember. So when we're looking at circles, there's two formulas that we need to know. Circumference equals pi times diameter, and area equals pi r squared. Remember the units for area have squared in, don't they? When we use centimetres, we have centimetre squared. So I always like to remember the little formula for area there is the pi r squared, the one with the squared in. So we're going to work out the area and the circumference of this circle. So to work out the area, we're going to do pi r squared if we start with that. So the area equals pi r squared. And we just need to know what the radius is. So over here, the diameter is 8. So we're going to first halve that for the radius. So I'll just write r equals 4. And we've just got to type that in. So pi times 4 squared. 4 squared is 16, so it'd be pi times 16. And you can just write that as 16 pi. So if it asks you to give your answer in terms of pi, you can just do that. But we want to type that into our calculator if not. So 16 times pi will give us a decimal, which is 50. I'm going to round this, but obviously only round it if it says to in the question. It'd be 50.27 if I round it, centimetres squared, and that'd be an area there to 2 decimal places. Let's have a look at working out the circumference. So circumference up here is pi times diameter. Now we've been given the diameter is 8, so to get the circumference, we just do pi times 8, and we could just say 8 pi. So we could just say 8 pi, which just means pi times 8. But again, if it asks us to work it out, we're going to do pi times 8 on the calculator. So 8 pi, press equals, and we get, and if I round this to 1 decimal place this time, I get 25.1. And circumference is a distance, it's around the outside, so it's just centimetres, 25.1 centimetres. But again, rounding it to how the question asks, and remembering you can write it in terms of pi, like down here 16 pi, and up here 8 pi as well. Right, working out the area of a trapezium, there's a formula for the area of a trapezium. It's a plus b over 2 times by the height. Or it can be written in a slightly different way. You can say half a plus b, again times in by the height. Now a and b are the parallel sides, which in this case is the 5 and the 9. So we add those together to start with. So 5 plus 9, we halve that. So 5 plus 9 is 14, half of it is 7. And then we times that by the height. Now you've just got to be careful here because you are given these two lengths on the side and they're really there just to throw you. They're not the height, they're diagonal lengths. This 4 in the middle is what we want, the perpendicular height from the base, indicated by that red arrow there. So 4 is our height, so we're going to do 7 times 4, which gives us 28, and it is an area. It's in centimetres again, so centimetre squared. So just be careful with the trapezium there that you do identify the perpendicular height from the base. So we've got to work out the surface area of this cuboid. Now there's only 3 surfaces we can see. We've got this one on the front, but there's also one on the back that's exactly the same. back here that we can't see. We've got the one on the top, number 2, which is the same as the one on the bottom, and we've got this one on the side here, which is the same as this one that we can't see on the side. So if we work out the area of these 3 faces, we can just double our answer to get the ones on the back as well. So I'm going to do this in steps. I'm going to do the face number 1, which over here is 8 times 12. So 8 times 12 is 96 centimetres squared. Face number 2, the one on the top, we've got 14 along there, and it's not labelled, but this is 12 as well, the same as the bit below just down there. So that's 14 times 12. So 14 times 12, you've just got to work that out, and that's 168. So that's 168 centimetres squared. And then the last one, face number 3 on the side, it's not labelled, but we can label that the height's 8, and the length going backwards is 14, the same as on the length on the top there. So we've got 8 times 14. So 8 times 14 for our last one. 8 times 14 is 112. So that's 112 centimetres squared. And if we add all of these up, 112 plus 168 plus 96, we get the answer 376 centimetres squared. Now you've just got to be careful at this point, obviously don't forget there are 2 of each face, so we just need to double our answer or times that by 2. So times that by 2 gives us a total surface area here of 752 centimetres squared, and there's our final answer for the surface area. Working out the volume of a cuboid is quite nice and simple. I do like to do it in a particular way though, just so it's the same for all of these shapes where we have a constant cross section. So this cross section, I'm going to have a look at this front face just here. So I'm first going to just work out the area of that, which is 8 times 12. So 8 times 12 gives me 96, and that is the area of the cross section, 96 centimetres squared. And then to get the volume, we just times it by however far back the shape it goes, which is the same as that 14 back there. So times that by 14, 96 times 14 will give us our volume. So 96 times 14 is 1,344, and it's a volume, so we put centimetres cubed, and that's how you work out the volume there. That works for any shape. We've got a constant cross section. If you imagine, sometimes we have these triangular prisms, and sometimes we could even have a trapezium face prism there. Okay, anything with that constant cross section, you always work out the area of this front face to start with, the cross section, and times it by the distance it goes back. So surface area of a cylinder is a little bit more complicated because we've got these 2 circles to work out, and then we've got this shape wrapped around the outside of the cylinder. So the area of the circle we've actually already worked out. Pi times r squared is 16 pi, and that equals the circle. Okay, and not forgetting we've got 2 of those, so let's times that by 2, which gives us 32 pi, which again is a number, but I'm just going to leave it till the end for the area of my 2 circles. Now the next thing that I have is this shape wrapped around the outside, and if we were to unravel that, we'd have a nice big rectangle, and the height of that rectangle there is 15. The length of the rectangle is actually the circumference of the circle. So we just looked at circumference of a circle. The circumference is pi times diameter, so I'll do 8 times pi, or 8 pi, the diameter there being 8, it's given us a radius of 4, so we could put the diameter equals 8, but that's 8 pi for the length. And we work out the area of a rectangle just by doing length times width. So to work out the area of this, we'll do 15 times the 8 pi, and that gives us 120 pi for the area of that rectangular part wrapped around the outside. All we've got to do to finish this off is add these 2 together, so we have 32 pi, add 120 pi, and in total that gives us 152 pi. Again, we could just write this as a decimal, but 152 pi comes out as 477.5 to 1 decimal place centimetres squared for surface area, and there's our final answer. So you just got to remember, you obviously got the circles top and bottom, and then to work out the area of the curved part, you need to think about that circumference there being the length of the rectangle. Okay, so we've got that these 2 shapes are mathematically similar. Work out the length of A and B. Now that there, mathematically similar, means one is an enlargement of the other, which means there's a scale factor between them. So if we can identify a similar side on both of them, which we've got here, 4 and 10, we can find the scale factor. So we always just do the big one divided by the little one. So 10 divided by 4, and 10 divided by 4, 4 fits in twice and a half, 4, 8, and then an extra 2, so it's 2.5. You might just get a whole number there, but there's my scale factor, and I always label that, I just say SF, so the scale factor is 2.5. So to get from a small one, let's have a look at A to start with. we've got to get from 7.5 back down to A. So that's going from the big shape down to the little one. So to get from the big one down to the little one, we divide by the scale factor. So divide by 2.5, and 7.5 divided by 2.5 will be 3 centimetres. And that's actually going to show the same for this other one here, look, because this one's 3 as well. But to get from 3 to B, we actually just times by that scale factor, so times by 2.5. And 3 times 2.5, which we already have there, is 7.5 centimetres. Okay, so you just got to remember divide from the big to the small one, and then multiply by that scale factor to go from the small to the big one. But it's all about identifying that scale factor that we did up here, that 2.5. Here we go, working out some bearings. So write down the bearing of B from A. So if I'm at B and I want to go from A, then I'm standing over here at point A. Now there's 3 rules for bearings. They're always measured in a clockwise direction. There's always 3 digits. I always measure it from north. Okay, so they are my 3 bearing rules. So looking here, if I'm standing facing north, which is shown by the north line, I turn clockwise, I'd have to turn this full 60 degrees. So that thing there, 60 degrees, but it doesn't have 3 digits, so I stick a 0 in front of the 60. So it'd be 060 degrees, or 060 degrees. Now the next part of the question says write down the bearing of from to A from B. So that means now I'm standing at B. So let's just get rid of these little bits. So this time A from B means I'm standing at B. Obviously, following these rules, if I face north, I've got to turn all the way around this way to get back to the direction of going back to A. So let's have a look at how we can do this. Now, what I quite like to do with these sorts of questions is to think about if I can extend the line slightly. So if I extend the line, because these 2 north lines are parallel, we've actually got a corresponding angle there. So this bit here is actually 60 degrees. So we can think about other angle rules while we're doing this. So from that bit just down to my little dotted line I've put in is 60 degrees. Now because this is a straight line, this extra bit here is an extra 180 degrees. So actually what I've got there is 60 to get me down to here, and then an extra 180. And if we add those together, 60 plus 180, we get a total of 240 degrees. So my answer for that would be 240 degrees, which does have 3 digits, so I can just leave it like that. Of course, there is another way that you can look at this as well. We could think about these 2 angles here as being co-interior that add up to 180. These 2 add up to 180. So this one here must have been 120. So actually I could take away 120 from 360, because that full turn there is 360, and we've got this little bit here as being 120. So I could actually do it like that as well. So there's 2 ways that we could approach it. Okay, so translating a shape by a vector. Now that top number in a vector means left and right, and the bottom number means up and down. Okay, thinking about positive numbers moving towards these positive numbers on the axes, and negative numbers moving towards the negative numbers as well. So 4 moves it right towards the negative numbers by 4. So all I ever do is pick a point, you can pick any, and I move it right by 4. So 1, 2, 3, 4, it's going to end up there. The next thing I do is look at the other number, which is minus 2. Now negative 2 moves down towards the negative numbers. So 1, 2 down, and that means that new point is going to end up just there. So all I have to do is draw this triangle in exactly as it is from that top point. So it goes down 3 and across 2, and there we go. We can just draw it in like that. Not forgetting as well, you might actually be asked to describe a translation, in which case you'd say it just like it says above. You'd say translate the shape by a vector, and you'd say what the vector is. Okay, so reflect the shape in the line x equals 1. Now this is your x-axis and this is your y-axis, so x equals 1 is right there. And the only line that you can do from that point, other than going across the x-axis, and it doesn't say the x-axis, is to go up and down. So x equals 1 is this line here. If you think about any coordinates on that line, the x-coordinate's always 1. So that's our reflection line there. Now we're going to reflect it in that line, which is quite nice and easy to do. Pick a point, and we just go 1, 2 to the line, so 1, 2 away, and just follow that process for all the points. So picking this point, that is 4 away, so another 4 away gets me to there, and the same one at the top, that's 4 away, and 4 away gets me to there, and then just joining it all in, obviously using a pencil for this one, and that would be my triangle. I haven't drawn that in particularly neatly, there we go. Okay, not forgetting as well, though, you could have a line, it could say the line, I don't know, y equals 3, which would be across at y equals 3, which would be across here. There's another couple of lines that we could have as well. We could have this one, y equals x. The line y equals x is the diagonal line here where all the x and y coordinates are equal. So we could have that one as well where we have a diagonal. There's one more that we could have as well. Let's pick a different colour for this. We could have y equals negative x, which is very similar to the one above, but it's pointing in the opposite direction. And if I do that in blue as well, that's going down this way. So we could also have to reflect in a diagonal line. But again, you just follow the same process, counting diagonally. Okay, so rotate the shape 90 degrees clockwise about the point -1, 0. So first thing to do is obviously to locate that point, which is -1 across, not up and down, so -1, 0 is just there. The next bit, this is a lot easier if we have some tracing paper. So you stick your tracing paper nice and flat over your shape, trace it in, so trace over your shape, stick your pen on that rotation point and just rotate the tracing paper, not moving it away from the pen. So we would rotate it 90 degrees, so it would be facing this way and just making sure it stays nice and flat. And it would rotate the shape, let's have a look, it would go to here on your tracing paper, and then you would just lift your tracing paper up nice and carefully and draw it in at that spot. And again, the same process if you have to describe one of these, you stick your tracing paper over the top and just move your pen into different points, picking places like here and moving it around until you get the one that matches when you swizzle your paper around 90 degrees. And remembering obviously in your description, you need to put the amount of degrees, the direction that it's gone in, and that rotation point along with the words rotation. Okay, so enlarge the shape by a scale factor of 2 from the point -4, -3. So let's identify that point first, -4, -3, and then we're just going to enlarge it by a scale factor of 2. So what I do is I pick a point on the shape, normally the closest one, let's say this one here, and I just think, all right, how do I get there from the point? So we go 2 across and 1 up. And I'm just going to do exactly the same again. So 2 across and 1 up. And that there is a scale factor of 2. The first movement to the shape is my first scale factor, the second is my second scale factor there. So if I had a scale factor of 3, I'd do the same again. I'd go 2 across 1 up, and that'd be a scale factor of 3. But this one has just said a scale factor of 2, so I'm going to leave it there. Now if I have a look at the shape that's drawn originally, it's 2 along and it's 3 up. And this is going to enlarge it by a scale factor of 2, which doubles those numbers. So it's no longer going to be 3, it's going to be 6, and it's no longer going to be 2, it's going to be 4. So from this point here that we've got to, all I need to do is redraw that shape in, remembering it was the bottom left corner, this one here. So we'll just need to go 4 across, 1, 2, 3, 4, and 6 up, 1, 2, 3, 4, 5, 6. And then join it all up, nice and neat with a pencil and a ruler, and there it is, enlarged by a scale factor of 2. Just remember, if you have to describe one of these, it's a really nice way of doing it as well. You just pick the 2 corners, get your ruler and a pencil, join them up really nice and neat, pick another one, match it with the appropriate one, and then again join that up really nice and neatly, and it will show you down here, look, where that enlargement point came from. And you can find the scale factor by just looking at the sides. So the side length is 6 here, and the side length is 3 there, and 6 divided by 3 gives us a scale factor of 2. So if it was already drawn in, we found our enlargement point, we just say it's an enlargement, a scale factor 2, and from this point down here, just like it did in the question, enlargement, scale factor 2, and from this particular point. Okay, so moving on to some geometry. So we're going to start off with this volume of a frustum. Now you would be given the volume of a cone formula, and that is volume equals 1/3 pi r squared h, where r is the radius and h is the height. So if we have a look at this frustum here, the only thing it doesn't give us is this length across the top. But if we have a look, the height of the little cone on top is 20, and the height of the big cone, if it was still there, is 40. So it's half the size, so the diameter there is 15. Now in order to work out the volume of a frustum, you've got to work out the volume of the big cone if it was there, and we're going to take away the little cone that's been chopped off the top. So I'm going to start off with the big one. So I'm just going to label this the big cone, and I'm just going to plug the numbers into my calculator. So it's 1/3 times by pi times by the radius squared. Now careful, because it's not 30, it's 15, half of that, so 15 squared, times by the height, which is 40. So typing that all into the calculator, and I can leave that in terms of pi, or I can write out the full decimal, and it comes out as 9424.777961 centimetres cubed. Now for the small cone on top, there we go, we can work out the volume of that as well. So it's 1/3 times pi times the radius squared, careful, so it's half of 15, so 7.5 squared, and times that by the height of that cone, which is 20. and that gives us a volume. And again, if we just type that in, let's have a look. So 1/3 multiplied by pi multiplied by 7.5 squared times 20, and that gives us a volume. Again, I could leave it in terms of pi, but 1178.097245, and again that's centimetre cubed. So in order to work out the volume of what's left when the little cone's been cut off the top, we just need to do the big cone, subtract the volume of the little cone there. So I'm just going to subtract this away from that, so subtract. And again, I'm just going to do that on the calculator. So 9424.777961. Take away that answer there, leaves us with a total volume of 8,246 point, and I'm going to round it to 2 decimal places, although you would be asked how to round it in a question, but I'm going to go for 0.68 centimetre cubed. Just be careful what the question asks for. Obviously if it said 1 decimal place, it would be 0.7. It might even just say 4 or 3 significant figures, in which case you just got to make sure you just round it how the question's asked. But there you go, that's using the volume of a cone formula on a frustum there, which is a little bit more interesting than just doing a normal cone. Okay, so we've got some similar shapes. 2 cones are mathematically similar. The height of cone A is 4 and the height of cone B is 10. Now you can always imagine what this is going to look like. You can always draw yourself a picture if you haven't been given one. And we've got a bigger cone. So we've got a height of the smaller one being 4 and a height of the larger one being 10. Now straight away you can work out a scale factor between these two. If they are mathematically similar, it just means one's an enlargement of the other. So I can do the bigger length, 10 divided by 4, and it gives us a scale factor of 2.5. Now when it comes to scale factors, that is our length scale factor, and always label it length scale factor. Now there's 2 more scale factors we could want to look at, and that's the area scale factor or the volume scale factor. And to get from the length scale factor to the area scale factor, you square it. Okay, so we square the scale factor. To get from the length scale factor down to the volume scale factor, you have to cube it. So if we just have a look at this question here, it says the volume of cone A is 40, work out the volume of cone B. So that's cone A is the smaller one in this case, I should probably label that A and B. And it says the volume of this one is 40. So in order to find my volume scale factor, I need to do 2.5 and cube it to get a volume scale factor. So we're going to do that on the calculator. 2.5 cubed gives me 15.625, and that's my scale factor in terms of the volume. So the volume of cone B is going to be 15.625 times bigger. So in order to get that volume there, we're just going to multiply 40 by 15.625. So times that by 40, and we get a volume here of 625 centimetres cubed. There you go. Just remembering as well, if we were going from the bigger down to the smaller, we'd have divided by the scale factor, but as we're going smaller to bigger, we're going to multiply. Let's have a look at a different one. So a similar question, 2 cylinders are mathematically similar. We've got cylinder A and cylinder B. Now it says cylinder A is 160 and cylinder B is 20. So A is my larger one. So if I just draw a little basic diagram of this, we've got A and we've got B. There we go. And this time it says, actually gives me the volumes. So it says the volume of A is 160 and the volume of B is 20. So again, if I find a scale factor here, I can do the bigger one divided by the smaller one. 160 divided by 20 gives me a scale factor of 8. Now, if I'm thinking about this area scale factor, length scale factor and volume scale factor, there we go. This time, I've got the volume scale factor, and that is 8. But I can't get from volume straight to area. Now, if you remember, to get from length to volume, we had to cube it. Okay, so to get back from volume to length, we have to cube root it. So if I do the cube root of 8, that tells me that the length scale factor is 2. Now the question here is saying, it asks me to work out the surface area. So I need the area scale factor. And if you remember just from the last one, to get from length down to area, we square it. So that'll be 2 squared, which would be 4. So my area scale factor is 4. Okay, so whenever you're given an area or a volume, you have to go back to length first to then get back to an area or a volume. So my scale factor is 4 for the area, and it says the surface area of cylinder A is 40, so that's the bigger one. I'll just write area rather than surface area. So to get from the bigger one down to the smaller one, we're going to have to divide by that scale factor, which is 4 for our area, and 40 divided by 4 gives us 10. So we get a surface area of 10 centimetres squared. Right, there we go. There's thinking about some similar shapes. Okay, so we've got a transformation here. It says enlarge shape P with a scale factor of -1/2 with the centre of enlargement 0, 0. So always mark out your centre of enlargement first. And an enlargement with a negative scale factor and a fraction here means that we've just got to do this very, very carefully. Now, the first things first, you need to pick a point on the shape and just figure out how you get from the centre of enlargement to that point there. And if I just count that, that's 1, 2 to the right, and 1, 2, 3 up. Now all I need to do this, and it's going to be quite small in this diagram, is I just count in the opposite direction by whatever the scale factor is. That's what the negative is. So rather than going from 0, 0, rather than going right and up, I'm going to go left and down. But it's a scale factor of 1/2, so I need to also halve those distances, just as if it was -2, I would double those distances. But for -1/2, so I'm going to go left 1 rather than 2. And I'm going to go down, rather than going up 3, I need to go down 1.5 or 1.5. So 1.5 gets me to there. There we go. So that's 1.5. I'm going to do the next one in a different colour, so I'm going to pick this point here. And let's just think how we get to that. Let's get rid of some of these markings here. There we go. So to get to that, we go 1, 2, 3, 4 across, and 1, 2, 3 up. So I'm just going to halve that again. I'm going to go 2 left rather than 4 right. So 1, 2, and then that 1.5 down, which again gets me down to there. There we go. And that is that point. Then again, I just need to repeat the process for the last one. You might be able to start to do these in your head once you've had some practice, but if we do the last point here, being the top one, let's just see how we get there. So it's 1, 2 across, just like it was to that red one, and then we've got to go up 1, 2, 3, 4, 5, 6, 7. So half of that's going to be 3.5. So I'm going to go 1 to the left. Okay, so I need to go down 3.5, 1, 2, 3.5, just there. There you go. Obviously you can do all this in pencil to keep this all nice and tidy, but when you've got a negative scale factor, you're just going to go backwards in the opposite direction by whatever that scale factor is. Obviously join it all up nice and neat, and there we go. And that is that one there. Just always go back and double check. So it was 7 up, so we went 3.5 down. That's absolutely fine. The other one was 3 up, and we went 1.5 down, half of that. And the other one there, perfect. Okay, so you can see with these, it does actually get bigger, and it gets bigger or smaller, and it rotates 180 degrees, and that's what a negative enlargement does to a shape. Okay, so we're going to have a look at another one here. Okay, so it says describe the single transformation that maps shape B onto shape A. This is quite nice. Hopefully you can tell that it's an enlargement, okay, because obviously one's got bigger and smaller, and we're going from B to A. Now what you can do is you can get your ruler, and we're going to have to try and do this quite carefully, but you get your ruler and you join up the similar points. Now the similar points are here and here. Okay, obviously it's been rotated 180 degrees. Now if you get your ruler and join that up, you end up with a little line like that. And then you just do that for all the other points. So I can probably get away with just doing 2, we'll have to wait and see. So if I join up these 2 similar points here, there we go, they join up just like that. And what you'll find is that there's this little crossover point, and that tells you where the centre of enlargement is. So I know that it's an enlargement, we've already got that, so I'm going to have to state it's an enlargement. Okay, so it's an enlargement. I've got to get what the scale factor is. I haven't got that quite yet, but I'll have a look. We know it's negative as it's getting this 180 flip. So we know it's negative. We'll come up with the number in a sec. And I know where the centre of enlargement is. So centre of enlargement. And we just write down what that coordinate is, and it's 2, 2. So centre of enlargement 2, 2. Now to count that scale factor, we're just going to count this side here maybe, and this side here, and just see how much bigger it's got. So that's gone from a length of 1 to a length of 3, so that is a -3 scale factor. So it's an enlargement, scale factor -3, centre of enlargement 2, 2. And you can use that approach for any of these enlargements, whether it's negative or not. Also, you might just want to note here that if it had been from A to B, it would have been the other way around. It would have gone from 3 down to 1, and my scale factor instead, if I was going from A to B, it'd be exactly the same description there, but my scale factor would be -1/3, because it's getting 1/3 of the size going the other way. Okay, so 2 different ones, but the description would be exactly the same there. Okay, so we're on to some congruent triangles. It says prove angle ABD is congruent to CBD. Now if you have a look, ABD is the triangle on the left and CBD is the triangle on the right. Now in order to prove triangles are congruent, we need to look for similar sides and similar angles. Now the first one that pops into my head is the line B to D, this line in the middle. Okay, I'll highlight that. This line B to D in the middle is the same for both triangles. So I could prove a side straight away. So I can say a side, I've got BD is the same in both. So both triangles already share a similar side, or exact same side. BD is the same in both. And remember, we're trying to prove that they're congruent, which means that they're exactly the same. So let's get rid of that. We can have a look at another one now. Can we see any other sides that are the same? Well, we've got these little symbols, and I've already got an arrow pointing to two of them really. We've got these little symbols on all of them, which means that all of those lengths are the same length. So we could state any of these are the same now. We've got AB, this one here, number 1, is the same as BC, number 2. So I can do another side. So I can say that AB equals BC, and actually that's given to us in the question, so I would just have to say given in question. There we go. And actually, using that same logic there, we could actually prove that these two down the bottom, which are labelled 3 and 4, are the same as well, because they're all the same length. So I could prove another side. So I could say that AD equals CD, and again that's given in the question. There we go. So what I have to do is state why that they're congruent there, and I can just say, and I'll just write this down at the bottom, I can say therefore they're congruent, okay, because the SSS rule here, so side, 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 congruent, and we're using the SSS rule. Okay, so there's other things that you can look for as well. You can have a look for angles. Obviously there's a few of these that you can use. This is just an idea of how to approach it and how to lay it out, just labelling what you found. But because these are obviously isosceles triangles, so this one on the left here, we've got two sides at the same length, so we know that the base angles are the same here. Therefore, as they're all the same length, those base angles must also be the same as the base angles on the other triangle. So we could use that as well. And if those angles are the same, then this angle at A has to be the same as the angle at C, so actually we could prove all of them. So there's a lot of different types of questions here, a lot of different proofs, but there's just an idea of one of them and how to lay it all out. Okay, so we're going to have to work out some missing lengths in this triangle. Now it's not a right angled triangle, so to find missing lengths and angles we can use either the sine rule or the cosine rule. And these are rules that you're going to have to remember. But we're going to have a look at one to start with and how we know when to use it. Now the first thing you do is you try and identify in a triangle for first of all what we're looking for, which is AB. So let's label that X. Now what I look for straight away is, do I have pairs of opposites? So I have this pair of opposites here and I've got both of those. And then I've also got X opposite to this angle. So I don't have X, but it's in one of my pairs of opposites. So when we've got this scenario where there's two pairs of opposites, we can use the sine rule. And we only ever need part of the sine rule, so I'm just going to use A over sine A equals B over sine B. Also equals C over sine C, but we only ever need to use two of them here. So let's have a look. We need to label this up. Now I'm going to completely ignore the letters that are on the actual triangle itself. I'm going to label this angle A, which it already is, and this side little a opposite that, and then this angle B, and the one opposite little b. And all I need to do now is stick all the numbers into the formula. So let's have a look. A is 12, so it's 12 over sine the one opposite that, 55, is equal to B, which is our X, over sine B. Obviously you should already know there's two variations of this formula. We could have it flipped over, so we could have sine A over A equals sine B over B, but this is our one for side lengths, and we know that because our unknown piece is on the top, so we're able to isolate this now quite easily. So, sorry, I've written B there, it should be 20. There we go, sorry, there we are, 20. So all we need to do is times both sides now by sine 20. What you could do is work this out on your calculator and times your answer by sine 20, but I'm going to multiply it straight over so I can type it all in one go. So times by sine 20. And if we do that, we get 12 sine 20, it goes onto the top there, over sine 55. There we go. And all we have to do is type that into your calculator, obviously just being careful that you put these angles in brackets. Some calculators are going to need you to do that. So if we type that all into the calculator, again, not forgetting you could just work out 12 over sine 55 first, and then times it by sine 20, but I'm just going to go for it like this. So 12 sine 20 on the top, closing your bracket, over sine 55. And on your calculator, just writing down what you got 5.010353998. Now a question would normally say how to round this, so if we imagine it was 2 decimal places for this one, it would be 5.01, and it's a length, so centimetres. Okay, so just obviously just be careful what the question says. Let's have a look at an idea where we've got to find the angle. Okay, so in this question, let's have a look. Work out the size of angle BAC. So let's identify that. That is here, BAC. Okay, so we're going to use the formula the other way around this time. So sine A over A equals sine B. That does not say sine B. Sine B over B. Okay, so plugging in our numbers, let's just label it up. So let's call this one A, as the A is next to it, that's fine. And again, I'm just going to write over this one, I'm just going to put B and B. Okay, just because of the way I've written my formula. So then sticking in all the numbers, what have we got? Sine A is sine X, so we have sine X over 20 equaling sine 43 over 14. Okay, so exactly the same approach as we did before. We can isolate the sine x by timesing both sides by 20. And again, you could work that right hand side out and times it by 20, but I'm just going to go stick it up the top there. So we end up with sine x equals 20 sine 43 over 14. And if we type that into the calculator now, what do we get? 20 sine 43 over 14. And we get an answer here. Let's write it over here. So we get sine x equals 0.97428 and a few more decimals. And obviously, just like normal trigonometry when you're doing SOHCAHTOA, to get the actual x here, we have to do the inverse of sine. So we're leaving that number on your calculator. You do shift sine, which gets you sine minus 1. Type in that answer or just press your answer button. So shift sine, answer. Press equals, and I get an answer here of 76.9779. And again, a question would ask us to round it here. Just depends. So let's just go to the nearest degree. We go for 77 degrees. Obviously, just making sure what the question says here, but let's just round it to the nearest degree there. So 77. Okay, so that's how you use the sine rule. Right, let's see how this question's different then. So work out the length of AB. So this one over here. Now straight away, looking at this, look, we've got a pair of opposites there, but I don't have any other pairs of opposites. I've not got anything opposite my 15, I've not got anything opposite the 12. So I can't actually use the sine rule here, and that is your clue, that is your hint here, that the sine rule's not going to work, and we're going to have to use the cosine rule. So another rule that you need to know, so the cosine rule is a squared equals b squared plus c squared minus 2bc cos a. Okay, so A being the side we're looking for, so we'll label this little a and this one big A, ignoring the letters on the triangle, and then labelling the other two sides, and they can be B and C, however you like. And from there, all you've got to do is stick these numbers in. It's actually quite simple to use when you know it. So A squared equals B squared, which is 15 squared, plus C squared, which is 12 squared, minus, and I'm going to stick this bit in brackets, 2 times 15 times 12 cos A, which is down here, which is 20. There we go. Right, so sticking that all in the calculator, let's have a look what we get. So 15 squared plus 12 squared minus 2 times 15 times 12 cos 20. Press equals, and I get A squared equals 30.7106 and a few more decimals. Now obviously that is A squared, and we don't want A squared, we want to know what A is, so we just need to square root both sides now. So square root, leaving the answer on your calculator, square root answer, and we get A equals 5.541719. And again, obviously you'd be asked to round this in a particular way in the question. Let's go for 2 decimal places, so A equals 5.54 centimetres. Right, there we go, and there's using a bit of the cosine rule. Okay, so working out the size of angle BAC, which again is this one at the top, and again just having a look, there are definitely no opposites because we've got no other angles, but the angle that we're looking for is going to be our A, and it is opposite 9. There we go, so the others can be B and C again. Now obviously here we're looking for an angle, so it's up to you if you choose to learn the formula. I tend to find that I just learn this formula, A squared equals B squared plus C squared minus 2bc cos A, and then I'm quite happy just rearranging that to get cos A on its own. So in order to do that, I'm going to get this whole minus 2bc cos a. I'm going to add it to the other side. So we get a squared plus 2bc cos a equals b squared plus c squared. Now I can get rid of that a squared, so we can minus a squared from both sides, so minus a squared, and you get 2bc cos a equals b squared plus c squared minus a squared now. And now you can finish off this rearrangement. You can divide by 2bc just to leave you with cos a. So cos a equals b squared plus c squared minus a squared over 2bc. It's up to you. You can choose to just learn that formula if you want, but that's the formula we're going to use to find an angle. So plugging in all these numbers then just into my formula there, we'll get cos a equals b squared plus c squared, so 10 squared plus 5 squared, minus a squared, so minus 9 squared, all over 2 times b times c, so 2 times 10 times 5. Nice and easy typing that into the calculator, so fraction button, 10 squared plus 5 squared, minus 9 squared, all over 2 times 10 times 5. And that equals, let's have a look, so cos a equals 0.44, and then same process again, we need to do the inverse of cos, so cos minus 1 of your answer, and you get, let's have a look, shift cos, answer, and I get 63.896, there we go, degrees. And again we could round that, so we could just say 63 point, and let's just go to one decimal place, 63.9 degrees, again just reading the question. And that's how to use the cosine rule for finding angles. Moving on to the area of a triangle, so your area of a triangle formula, obviously not half base times height because we don't have the height here, so for any triangle the area is half AB sine C. So half AB sine C, another formula there that you need to know. And let's just have a look at how we apply that. So sine C, this time the angle that we're going to use is going to be our C, so we'll call that C. This would then be little c, and the others will be A and B, and they can be A and B in either order. And then it's as simple as just sticking those numbers into a formula. So it's half times 5 times 8 times sine 41. There you go. Type that into the calculator, so half times 5 times 8 times sine 41. And we get the answer 13.12, if I round it to 2 decimal places. It's area, so that's meters squared, just being careful of the units, so 13.12 meters squared. There we go, there's using the area of a triangle formula. Question like this though, you might be given the area of the triangle, so it says the area is 80, so we're working backwards a little bit here. So we're going to use half AB sine C again, so half AB sine C, but this time it gives us the answer, so the answer to that half AB sine C has to equal 80. So let's just plug in all the numbers here, again C being my angle, and then A and B being my other lengths. So if I was to type this into the formula, we'd have a half times 11 times 16 times sine C, and it would equal 80. Now I can't actually work that out, but what I can do is I can work this bit out. So if I do a half times 11 times 16, we get the answer 88. So we have 88 times sine C equals 80. So we can rearrange this. Look, we can get both sides and divide them by 88, and that will just give us sine C on its own. So sine C equals, and 80 divided by 88 is, let's leave it as a fraction, well, actually it is a decimal there, but it comes out as 0.90, and that is actually 90 recurring. There we go, I'm just going to leave it on the calculator screen. And then obviously to finish that off, you do the inverse sine again, just like we have on these other questions. So I'm going to do that over here to the left. So sine minus 1 of this number here, which is actually also a fraction, it's 10 over 11. Sine minus 1 of 10 over 11, or that 0.90 recurring, and we get the answer of 65.38 degrees. There we go, so we can find an angle as well, just working backwards if we're given the answer. And you can apply that logic there to lots of different questions where it gives you the answer and you can use your formula backwards, just dividing everything over to the other side. Okay, so we've got a vectors question. It says B is the midpoint of AC, So that's this point here, is the midpoint. So straight away that tells us, look, because you can see some of the vectors on here, that this must also be A. And again, there are so many different variations of vectors here. This is just one idea of how to approach it, but there's so many different types of questions you can get. We could spend an hour to 2 hours just looking at vectors. M is the midpoint of PB. So we've got a midpoint here, so that's halfway along. And then show that NMC is a straight line. So straight away I'd like to draw NMC in and just think about that. So that it's saying is show that that's a straight line. And we're going to have a look at some of the vectors on this line and see if we can get a common multiple or a common bracket, however you've looked at this before. So all I want to have a look to start with is that line N to C. I've got 3 vectors I can look at. I've got the full line from N to C. We've got from N just to M. So I can go from N to M. Or I could go from M to C. And they're all little parts of this line. Okay, the full line there, let's just highlight this. The full line, the first one that I've written is N to C all the way. The second one I've drawn is N to M, from there to there. And the third one I can have a look at is from M to C, from there to there. Now it's up to you which one you choose. Sometimes some of them are easier than others. But the first one there, so this N to C, is quite simple for us to do. Now to get from N to C, I've got to move backwards up the line this way. And then I can go forwards along to C there. So that first part of the journey, going from, let's get rid of that, going from N up to A, and let's draw this in. So to go from N to A, so I'm just going to write this down, is minus 2b. You have to go backwards through that 2b. So from N to C, first of all, it's minus 2b. Then I can go from A over to C, doing 2a's, and that's positive, so plus 2a. There we go, so I've got minus 2b plus 2a. Now whenever it comes to these vectors here, you always just want to look to factorise them. So I'm going to move this out of the way, and I'm just going to see what does that factorise to. Now I can factorise it by 2, and I would get 2 lots of minus b plus a. And obviously we could write that in a slightly different way. I could swap the letters around if I want. I could write 2 lots of a minus b. Now if I can prove that one of these other vectors here that I'm looking at below has this bracket a minus b, then they must be on the same straight line, because therefore they're going in the same direction. So let's have a look at one of them. So I can either look at N to M or M to C. It doesn't really matter, I'm just going to go with M to C. Either one here are going to be just as difficult for us to do, but that first one there is nice and easy, so always make sure you have a go at finding some of the lines. Now, that M letter here is halfway along PB, so I'm going to have to find the vector for P to B, and that's going to be my absolutely key one here, P to B. Because if I can't find the full length of the line, I'm definitely not going to find halfway along it. So if we look at how do we get from P to B, well that's actually quite simple. You can go from P up to A, and that's minus 3b's, so let's write that down. You've got the minus b to get to N, and then another 2 to get up to A. So minus 3b's. And then to get from A to B, you'd do a plus A moving along that vector there, so plus A. So that is my vector P to B. That's another very good one to always make sure you get that missing line where you've got a halfway point. Now in order to move halfway along that line, I'd have to do half of this vector. So to get from P to M, or from M to B, which is half of that, let's go for M to B, as that's the quickest way for us to move there, M to B. We'd have to do half of this vector. So to times that by a half, I'm just going to write it as a half lots of minus 3b plus a. So half of that. Now if I expand that, I can actually add stuff to this as well, because that only gets us from M to B. If I draw that on, that gets us from here to here, doing half of that line. So expand that out. Minus 3 times a half is minus 3 halves. So minus 3 over 2b. Plus half of A, so half A. And now we can finish that off, because now we're at B, we can do our final little bit of the line, which is to go over here to C, and that's adding an additional A in there. Okay, so that's our last little bit, plus A. And if we add this all together, and let's see what we get. So we have minus 3 over 2b, I'm going to write this over here, that's not changing. So we've got minus 3 over 2b, and then we've got half A, add an A, and that gives us 1.5a, or another 3 over 2a. There we go, 3 over 2a. So let's write that down over here. We have minus 3 over 2b plus 3 over 2a. So that is our vector there to get from M to C. Now all I need to do is just factorise this one. If you have a look, they both divide by 3 over 2. So I can take this 3 over 2 out the bracket, and if we divide them both by 3 over 2, we get minus b plus a. There we go. And I rewrote that a different way as well. I could write that as 3 over 2 brackets a minus b the other way around. And there we go. We've got that matching bracket there in both of them. Okay, so both share that common vector there, that common movement between the points on the diagram, n, m, and c. Again, you could have found n to m as well. We could have done the same thing, and actually, because we found this half, this one just here, we can actually just think if I was moving from n to m, so n to m, we would do plus b and then half of that vector just there. And if we did do that, let's just do it over here to the side. So this is from n to m, not that we didn't need this one, we only ever need 2. So from n to m I could do plus b, or just b, and then add to that this vector down here that we did in the green down there. So add to that minus 3 over 2b plus half a. And if we add that all together there, minus 1.5 plus 1 gives us minus a half, so we'd have minus a half b plus a half a. And again, we could factorise that by a half, so we get a half minus b plus a. And again, we get that minus b plus a there, which we can write in a different way. So we could have done any 3 of them. All 3 of them eventually give us this same bracket here. Okay, so we have the same multiple, it means it's on the same line. And there's a bit of vectors for you. And the last question here is just involving some circle sectors, but also involving a little bit of trigonometry as well. It says that this is an arc of a circle centre 0, and it wants us to work out this shaded region. So if we can work out the full sector, we can take away this unshaded triangle. So to work out the area of a sector, we would have to do pi r squared, so not forgetting your area of a circle formula, pi r squared, and multiply that by whatever fraction of the circle this is. Now it says 35 degrees over there, so it's 35 over 360. So if we plug those numbers in, it will give the area of the sector. So we've got pi times 80 squared, it's in metres, multiplied by 35 over 360. Now if we type that in on the calculator, let's see what we get. Pi times 80 squared times 35 over 360, and we get the answer 1954.7, and let's round it to 2 decimal places, 77. Obviously just be careful what the question says again, and that's metres squared. Then we can work out the area of the triangle, and obviously not forgetting, just because it's not just a triangle on its own, we can still use our half AB sine C. So we can use half AB sine C to get this one. And if we plug the numbers in, 35 there is our C. And because it's a circle sector, A and B here are the same because it's the radius of the circle. So we can do half times 80 times 80 times sine 35. There we go, and if we type all that in, 0.5 times 80 times 80 times sine 35, we get the area of that triangle there, which is 1835.44 metres squared. And then to finish that off, we can do the bigger shape of the sector, subtract the area of the triangle, so 1954.77, take away this 1835.44, and that leaves us with an overall area here. Let's work it out, 1954.77, take away answer, and we get 119.325 metres squared. And there we go, and obviously just rounding that however you'd been asked in the question. So there's quite a large selection of geometry questions there. Okay, so we're going to start by having a look at averages from a table. So this table shows the mark for 30 students in a test, and it wants us to calculate the mean and write down the modal mark. Now to calculate the mean, it's quite nice and simple. If we have a look at this table here, this first row says that there are 2 14s, and if we add together 2 14s we get 28, so we can just times these together to find out what the total is. So that's 28. 10 15s times those together is 150. 2 16s is 32. 3 17s we'll have to work out, I think that's 51. 3 times 17 is 51. And the last one there is 13 times 18, so 13 18s is 234. Now if we add all this up, it'll tell us the total amount of marks that everybody got. So 234 plus 51 plus 32 plus 150 plus 28 gives us a total amount of marks there of 495. So that's their total, and it says that there are 30 students up here. Although if we didn't know that, we could add together this frequency column and we get a total of 30. So to find the mean, we just need to do 495, the total amount of marks, and divide it by 30. And that gives us a final answer there of 16.5. And don't forget, your answer has to fall in between the range here, which is between 14 and 18. So 16.5 is within that, it makes sense, we're happy with that. Now part B says to find the modal mark. Now the modal mark just means the mode mark, okay, the one that's the most common. And if we have a look at our table here, the one that's the most common is this one down at 13, and that represents 18 as the modal mark. So the modal mark would be 18, okay, because 13 people got that, and that's the highest there in that frequency table, so 18. Now this question is very similar. It shows the height of 30 students. This is calculating an estimate for the mean, and then again write down the modal class interval. So the reason it says to find an estimate for the mean is because we can't get an exact mean because we don't actually know, particularly looking at just this first row, what that person's height actually is. It's one person between 130 and 140. There could be anything, 132, 138, anything in between. So what we do is we pick the midpoint. So in between 130 and 140 is 135, and we're just going to use that as an estimate for the height of that person. And we'll do the same for all the others, 145, 155, 165 and 175. And we'll just treat this in exactly the same way as we did before. So one person at 135, 7 people at 140, and we're just going to times across for all of these again. So one lot of 135 is 135, 7 lots of 145 is 1015, again I'm just doing this on the calculator, 8 times 155 is 1240, 10 times 165 we can do 1650, and 4 times 175 gives us 700. And again, from here, it's just the same process. We add those all together. So 700 plus 1,650 plus 1,240 plus 1015 plus 135 gives us a total there of 4,740. And again, it said that there were 30 students there, which we can find from the bottom. So finishing the sum exactly the same as before, 4,740 divided by 30 will give us an estimate here for the mean, because again we have just guessed what their heights are as using those midpoints, which gives us 158. And again, that answer there has to fall in between this range here, which starts at 130 there and ends down here at 180. So it has to fall in between, so 158 centimetres. Now the next bit says write down the modal class interval. Now the word class just means group, so it's the modal group, which group is the most common, and that's here with these 10 people. So all I have to do is, and I've written over the top of it now, but all I have to do is write this group down here. So the modal interval, okay, is that exact thing there, and I just write it down word for word, 160 to, what was in the middle, h in this instance, to 170. And that would be my modal class interval just there. Okay, so reading from a stem and leaf, it says the speed of 27 cars. Work out the median and work out the range. So to work out the median, I want to know which one's in the middle. We can take quite a nice approach for this. We can just cross numbers off either side until we get to that middle number. So if there's 27, I'm going to cross off 10 from each side at least, so I can start to get from the middle. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then going from the back, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now I'm just going to do one from each side until I get one in the middle. So 1 and 1, 2 and 2, 3 and 3, and I'm left with this one here. Don't forget the key though, it says 3-8, or 3 line 8 means 38. So that's next to the 5, so it's 5 and 6, which is 56. So the median there would be 56. Working out the range, we want to look at which one's the smallest and which one's the biggest. Let's have a look. If I get rid of some of my lines here, the smallest number there is 38, the biggest is 70. So to work out the range, which I'll do up here, so the range will just be 70 the biggest, take away 38 the smallest, which is 32 as my range there. Again, there's median and range from a stem and leaf. Okay, so drawing a pie chart. We've got to draw an accurate pie chart for this information. So the good thing about a pie chart is these numbers in the table are always going to fit into 360. This is quite a small one here, because if I add these up, I've only got 10 people in this pie chart. It looks like the type of fruit that they prefer maybe. So we've got 10 people, so all I want to figure out is how many times this fits into 360. So whatever that number adds up to, I can do 360 divided by that number, and it tells me that each person here represents 36 degrees. So all I want to do is times the amount of people by 36 in each scenario, or times them all by 36, and that'll tell us the amount of the degrees I need to draw in my pie chart. So 2 times 36 is 72, 5 times 36 is 180, and 3 times 36 is 108. And again, it's quite a nice check here. If you add those up, they have to add up to 360. And if we add them up, let's have a look. 108 and 72 makes 180, plus the 180 is 360 degrees. So that's a nice little check there. You can tick that off, happy with that as 360. Now moving on to the next part, we actually have to draw the pie chart. So whatever kind of protractor you've got, you need to stick it over the top using this first line here as your starting line and measure out 72. Now if I guess where it's going to be about there. And all we need to do then is draw inside that piece of the pie what that represents. So that represented apple, and it represented 72 degrees. Then drawing in your banana there, which is 180, which is going to be a straight line going the other way. Again, measuring from this line as your new starting point, and that is going to be banana. Ooh. Banana, and that is 180 degrees. And then your final one there, because I've only got 3, the final one's done for me, although stick your protractor on and just make sure that this distance here is in fact the 108 degrees that we want, just to make sure you've done it all correctly. And you'll get an orange in there with 108 degrees. I just remember when it comes to a pie chart, if you ask then to compare this against another group, let's imagine we have another pie chart. I'm going to draw a really rubbishy one over here. We have another pie chart, and let's say that this size is apple now. So we've got apple, banana, and orange, and it says something along the lines of more people like apple in this pie chart. Now without any numbers we can't actually make any statements like that, so if you are given a pie chart to compare, just remember without any numbers you can't actually make a comparison, because there might only be 5 people in this pie chart, for example, in which case it might not necessarily be more people. Okay, so we're going to have a look at some statistics. This is going to be quite a short one. We've only got a few questions to have a look at, and we're going to start with a box plot. So on here we've been given some information about some time in seconds that 15 people wait to be served at a garden centre, and it wants us to draw a box plot for this part A. So we've been given a list of numbers for those minutes, and you've just got to make sure that they're in order, because we need to find a few values. We need to find the lowest value, the highest value, the median, and the 2 quartiles, the lower and upper quartile. So we can quite easily see that they are in order, so we can get the lowest and the highest value from either side, and they're going to form the ends of our box plot. So just very carefully on your scale here, drawing the ends in here, and 44, just make sure the scale goes up in ones. It does. I'm going to do it as best as I can here, and that's our 44 there. Now we need to find the median. So with 15 people, we just want to find where that halfway point is. So all you've got to do is add 1 and halve it. So 15 plus 1 is 16, divide it by 2, and that's going to be our 8th person. So we just need to go along the box plot and find where the 8th person is. So 1, 2, 3, 4, 5, 6, 7, 8. So 25 is going to be our median. That's quite nice. It's halfway between 20 and 30. Draw an end nice and neat there to form our median. Now we just need to find where the quartiles are. So on that lower half, okay, the lower part or the lower quarter here, if I try and highlight that, we've got these numbers here, and there are 7 numbers there if you just count them up. So 1, 2, 3, 4, 5, 6, 7. So again, finding the halfway point, we can do 7 plus 1 and divide it by 2, which gives us 4. So we want to find where the 4th person is for that lower quartile. So 5, 9, 11, 14. There is our lower quarter there. So marking that on the 14th person. 1, 2, 3, 4. And then looking at the higher quarter there. 27, 27, 28, 30. Okay, so once you've marked all of those on there, you've just got to join up your little box. There we go, making it look like the one that you can see below, and then join up these parts here, and there's your box plot drawn. Okay, moving on to the bit below. Now I haven't added the question in here, but quite often it says to compare the box plots. So it says here, the box plot below shows the distribution of times served at a different garden centre. And it would usually say to compare them. Now, there are 2 things that you want to compare when you're comparing a box plot. One of them is the median. So if we have a look, our median here is sitting on 25, and down it's sitting here on 21. Now I don't have to mention any numbers, but I would mention number 1. I would say that rows, I'll just call it rows. Rows has a higher median wait time. Okay, so a higher median wait time. Okay, make sure that you mention some context. Obviously don't just say it has a higher median. What's the story actually about? It's about the wait time at a garden centre, so rows has a higher median wait time. The next thing we have a look at is the distance between the quartiles. And again, I don't have to mention any numbers, but I just have to think this is the distance between the quartiles. It's called the interquartile range, and on the one below here is the distance. Now hopefully you can see there visually that on the Greens Garden Centre there is a higher interquartile range, meaning that the data is more spread out, and you want to mention that word spread out. So number 2, my comparison here, Greens has a higher, I'm going to abbreviate it to IQR, interquartile range, meaning the data is more spread out, or meaning the wait times are more spread out. There you go, more spread out, and mention that word there, spread. There you go, so more spread out, and that is drawing a box plot and also making a comparison between the two. Let's move on to our next one. Okay, so the next question here, we're going to draw a cumulative frequency graph. Okay, so it says cumulative frequency up here, and then it says some information about the speed of 100 lorries, which it starts to tell us over here. Now, sometimes it might give you an extra table down here to draw them in. Just take note of the fact with cumulative frequency, we are doing a cumulative total as we go up these speeds here in our groups. So we start off with 2, which is shown to us in the table just here. And then it says in the next part of the table, right here, it says, look, 0 to 40. Now that is correct, it should say 0 to 40 because that's going right from 0 all the way up to 40, and that means the accumulation or the cumulative total of 2 and 9 there. And if you add up 2 and 9, we have 11. Then there's 23, so from 0 to 60, so add the 23 into that as well. We have 34. Add the 31 into that, we get 65. Add the 27 into that, add 7 is 72, add 20 is 92, and then add the 8 into there gives us our total of 100. Now if it doesn't give you a little table to the side, you just have to do it over to the side of your table here, so 11, 34, 65, 92 and 100, and just drawing it in there instead, but sometimes it might give you the table. From there, it's quite nice and simple. We just have to actually draw it. Now, when we draw a cumulative frequency graph, we plot these numbers, these cumulative frequency numbers, against these values here, the endpoints. Okay, so depending on which table you've got, we're just going to plot it against that. So if I do this nice and as quick as I can anyway, because it's quite small, but 20 to 2 is here. Make sure it's nice and accurate. Mine's not going to be perfect. And then we've got 11, the cumulative frequency going to 40, so 11 is here. Then we have 34, and it just goes along 20 every time, so 34, so around about here. Then 65, there we go. Then we've got 92, just here, and then finishing it up on the 100, there we go. Now when it comes to a cumulative frequency graph, it is a nice smooth curve. Just have a look what your starting number is. Now your starting number, if I highlight it, is over here. It starts on 0, so we're going to start from 0, and we're going to do a nice smooth curve, making sure you go through all the points. And there we go, there's your cumulative frequency graph. Now there's a few things that you can read off a cumulative frequency graph. The actual question that we're going to have a look at down here is find an estimate for the number of lorries with a speed of more than 90. But there's lots of things you can find. We'll start with this one. So a speed of more than 90, if we have a look, well, a speed of 90 is here. So all I have to do is very carefully go up to my graph and show this on your question, and then you go across to the left. Now this is going to vary depending on different people's curves. I'm going to try and read it as best as I can. Mine looks like it's coming out at around 84. So the answer is not 84 because it says an estimate for the number of lorries with a speed of more than 90. Well, there's 100 lorries in total, 84 are up to 90 miles an hour, so it's the additional 16 on top of that, so it's 100 take away the 84 would be 16. But that's not just the only thing that you can find from a cumulative frequency graph, and if I swap to another colour, we could also find the median. So if I have a look, if there's 100 lorries, the median's going to be here, sitting on the 50th, and I could go along and I could find the median speed. Let's have a look. and then drop it down. It looks like that lands on 70 for me. So I could have a median of 70, that's something else I could have a look at. I could also have a look at the quartiles and the interquartile range again. We could find 25, I could go along from there. I could find 75, which is around about here. I could find those two values and then work out the distance between them for the interquartile range as well. So there's a lot of things that you could have a look at. Obviously you just need to make sure you draw it on the graph. And if you do the interquartile range, which is quite a good one, you go across, you find your value down here. Again, mine's not going to be perfect. It looks like about 82 or 84. Just to go for the best as I can on here, 84. If I go along for 25, that comes down, looks like at about 58 for me. So if I wanted to find the interquartile range, I could do that as well. I could do the interquartile range, and that'd be 84, take away 58. There you go, and I'd work that out. What does that come out as? 26. There you go, so my interquartile range would be 26. My median down there was 70, but obviously this question was asking for the estimate there. But lots of things that you can find from a cumulative frequency graph. Next up's a histogram. This is going to be probably the fiddliest one to actually draw on here. So there's a formula that you need for histograms, because obviously on the side of this we have frequency density. So the formula for frequency density is frequency divided by class width. Okay, we'll have a little talk about that. Frequency divided by class width. Now essentially all we're really going to do here is find out what the height of each little rectangle is going to be for our histogram. Now we've already got the widths determined for us, they're in the graph here, so that one there, 60 to 65, has a width of 5. Now that frequency there is going to be the area of each bar. Now if you think about that, if we just think logically about a rectangle, if I've got a rectangle, its area is 15, the width of it is 5, what's the height going to be? The height's going to have to be 3 in order to make sure we get an area of 15 there. So essentially all we're going to do is the same thing. We're just going to do the frequency, which is the area, like in my formula here, 15, and divide it by the width, which is 5. 15 divided by 5 gives us 3. So I'm just going to do a little separate column here for frequency density, and I'm going to work out all the frequency densities. So you might just want to write down these widths over here. So this one's 5, this one's 5, this one's 10, and then this one's 20, so we do have different widths here. So 15 divided by 5 gives us a 3, which we already know the height of that rectangle is going to have to be 3. The next one is 25 divided by 5, which is a height of 5. The next one is 36 divided by the 10, so a height of 3.6. And the other one's 24 divided by 20. 24 divided by 20 is 12 over 10, it's 1.2. Again, if you've got a calculator, that's okay. Don't forget though, some of these harder ones, you could also always write that, couldn't you? You could write 24 over 20, which is 12 over 10. And that's a little bit easier then to turn into 1.2. Okay, so 1.2 for that one. You've then just got to be very, very careful. We've just got to plot this on the left. So we're going to have frequency density. So make sure you label that if it's not given to you. Our highest height there is 5. So I just want to get, as best as I can, a scale that allows me to go up to 5. So I'm just going to have a quick look, because sometimes these are quite hard to see. So if I go up 10 squares for every 1 and just see if that fits. So do this in pencil to start with. Just make sure your scale works. We're going to start with 0. And if I go up 5, 6, 7, 8, 9, 10 here, let's say that's 1. So then up 3, 4, 5, 6, 7, 8, 9, 10, 2, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 3, up again, 10 is 4, and then 5 does perfectly fit there. You could do it smaller, but I'm going to try and give myself as much space as possible, so making sure we've got the labels here. Then we just need to draw these in. They're quite simple to draw once you've got this information. So if we draw this in, look, just making sure you get the widths right. That first speed there is 60 to 65. So my width is going to be 5, so it's only going to be this wide here. Let's have a look. Is that enough? 1, 2, 3, 4. Another square along 5, and that's going to go up to 3. Ooh, not very well drawn there. Obviously using a ruler and a pencil. So there's your first bar. The next one has a height of 5, and again, and he has a width of 5. It goes from 65 to 70. So continuing that line up, we can go up to 5. I'll do this as best as I can. There we go, there's the next one. The next one has a height of 3.6, so being super accurate here, and a width of 10. It goes along to 80. So if I find 3.6 as best as I can, 1, 2, 3, 4, 5, 6. There we go, and then drawing that bar in, and then the final bar there has a width of 20 all the way up to 100 and a height of 1.2. So 1 is there, 0.2 just about as best as I can, and there is your histogram. Okay, so we can also look at some stuff from this as well. So the question here, which I'm going to have a look at, this part B, says work out an estimate for the number of cars with a speed more than 85. Now you can actually do this from the table, or you could do it from your graph. Now 85 is, if we have a look on the graph, 1, 2, 3, 4, 5, it's halfway between 80 and 90 there. Now this bar here, we've already determined is 24 people, or 24 lorries. Now if you think about this, 5 along, actually that could split up into 4 equal chunks that big. Okay, it's a quarter of the way along, and a quarter of 24, and 24 divided by 4 is 6. So in each of these little chunks we could estimate that there's 6 in each. Obviously we don't know because it is group data, but we could estimate that there's 6 in each. So if we work out an estimate for a number of cars with a speed of more than 85, well it'd be these little 3 chunks of 6 here, and 6 plus 6 plus 6 would give us 18. And that'd be a good little estimate for us there. We could also do it from the numbers though up in the table, because if it's a quarter of the way along, we know it's 3/4 of this little group, and we could have just done 3/4 of 24. 3/4 of 24 is 18, divided by 4 is 6, times it by 3 is 18. So you can do little readings from your histogram like that as well. Let's have a look at our next one. Okay, so the last one here, we're going to have a look at a reverse mean question. Now I know it's a reverse mean when it starts to talk about actual means. It says that the mean for certain people is, and then starts to give us some information. So it says there are 20 men, 20 women and 10 children, and they take part in a quiz. And then it gives us the mean score for the men, the mean for the children, and the mean for the whole group. And it wants us to work out the mean score for the women. So that's what we want to work out eventually. So all we got to do is think in reverse for this. So when you're working out the mean, you get the total and you divide by how many people there are. So if we think about the men, you don't have to write it like this, but just so you have an understanding of this, you would get the total, which we don't know, you divide it by the 20 men, and it says it gives us an answer of 6, the mean for the men. So if we reverse this round, times both sides by 20, so times by 20 gives us a score of 120 for the men. So that's the total score for the men. We could then do exactly the same for the children. I don't have to write out this little bit of algebra every time, but if I just think, okay, well the children then, I just know I need to times the amount of children by the mean. The mean is 4 and there are 10 children. So 10 times 4 gives us a total score of 40 for the children. There we go. Now we don't actually know what the mean is for the women, that's what we're trying to work out, but what we are given is this last bit of information here, which says the mean for all of them is 5. Now in total, if we have a look at the question, it says there are 20 men, 20 women and 10 children. So that's 50 people with a mean of 5. So that we could do 50 people times the mean, which is 5, which gives us a total score of 250. So that's our total there. So now we know the total score, we know the score for the men, we know the score for the children, so we can actually work out what score the women got. So if we do this to the side, we know we have to do 250, take away the 120 that the men got, and take away the 40 that the children got. And if we work that out, 250 take away 120 is 130, take away the 40 leaves us with a total score of 90 for the women. So the women scored a total of 90, and it says that there are 20 women. So to work out the mean for them, we've got 90 is their total score divided by 20. And again, depends whether you have a calculator or not here. But even if you don't have a calculator, we can do this one. We can cancel off the 0 top and bottom, and it's 9 over 2, or 9 divided by 2, which is 4.5. There we go. So the women have a mean of 4.5, and that'll be our final answer there to finish that off. There we go, and that's our little bit of statistics done. Okay, the table shows the probability of picking different colours. So we have red, blue, white and black, and it says the probability of white and black is the same, complete the table. So at the moment, we've got these two which add up to 0.7, and probabilities have to add up to 1. Now what we've got left over there is 0.3. I like to think of it as 0.30 because if they're both the same, we're going to have to halve that, and half of 30 is 15, so it's 0.15 for both of those, and now they add up to 1. Now for part B, it says that there are 60 counters in the bag. How many are white? Now if we look at the probability of white, which is over here, 0.15 is 15%. So really all this is asking us to do is to work out 15% of 60. And we can do that nice and easy. 10% is 6. 5% is half of that, which is 3, and add them both together, and that's 9. Now part C here, you won't be given this at the same time as question B because we already know that there are 60 counters in the bag, but it says that there are 12 red counters and how many counters are now in the bag. So if we imagine this is a completely different question now, but it's saying that red counters here, which is 20%, is now 12 counters. So all that's actually saying is 20% equals 12 counters. Now that's okay, we can turn that back into 100% quite nice and easy. I could just times that by 5, but let's imagine it's not a nice percentage. I'd have to try and break it down to something which turns into 100. So we could divide it by 2, which would give us 10%, which is half of 12, which is 6, and then times that by 10 to get us back to 100%. Okay, again, you could actually just times 20% by 5, but I think that's quite nice just to break it down and build it back up. So 60 counters there would be in the bag. Okay, so we've got a lot of information here. 100 students are in a year group, and then we've got some information about whether they wear or do not wear glasses. And it wants us to work out the probability of choosing a boy who wears glasses. And when you've got a lot of information like this, I like to organise it in a two-way table. So I'm going to put this all into a two-way table. Again, you could use a frequency tree, but I'm just going to opt for using a two-way table. So we could have boys and girls on the side. Again, you could have them at the top, but I'm going to put them to the side. And then you've got a total down the bottom. And then we've got whether they wear or do not wear glasses. And again, we've got a total here. So all I'm going to do is put the numbers within the question. We've got 100 students in the year group. 42 of them are boys. 8 out of 100 students wear glasses. So 8 students here wear glasses. And 52 of the girls do not wear glasses. So 52 just here. Now that's everything in the question. We've just got to fill in all the missing numbers now. So if there are 42 boys here, that must mean that there are 58 girls. And out of those, 52 do not wear glasses. So that must mean that 6 of them do. Now again, we've got 8 that do wear glasses, 6 of them are girls, so 2 boys must wear glasses. And again, going along this way, that has to add up to 42, so that must be 40. And then moving downwards or across from another direction, I could add those together to make 92. And a very quick check here, those two add up to 100, so that's right, we're happy with that, we can tick that off. Now it says, work out the probability of choosing a boy who wears glasses, and one of the students is picked at random. Well, 2 of the boys wear glasses, so that would be 2 students out of the 100 students that we've got here. You don't have to simplify that, but just a quick note, it could have said in the wording here, it could have said, rather than saying one of the students, it could have said one of the boys. Now if it had said it, maybe it had picked one of the boys, then that would have been out of 42, so it would have been 2 over 42. But it just depends on what the wording says, so it does say one of the students, it doesn't dictate whether it's boys or girls, so it's out of 100. So when we do a frequency tree, it looks a little bit different, so we're going to split it off in a tree, so we're going to split it like this. And we've got 60 people to start with, and I'm going to put that in straight away. And then we're going to split it off into males and females. Okay, so I'm going to split that, male and female. I'm just going to write at the end of those trees how many of each there are. Okay, and from there, we're going to have a look at the options that they could have picked. So this was about the different countries. So we've got Britain, we've got Italy, and we've got Spain. Okay, and I'm just going to put a little circle coming off all of these. It's not quite as nice and neat and tidy as the table, but I'll try my best. And then off the females as well, we've got the 3 different options. There we are, so Britain, I can't remember what order I said now, Britain, Spain and Italy. So I'm just going to label that up so I don't forget. Britain, Spain, Italy. That is not a B, let's go back and do that. Britain, Spain, Italy. There we go, so we just want to start filling in these numbers just like we did before. Let's have a look. So we've got 38 of the people were male. So straight away we've got 38 that are male that can go in there. It said 11 of the 32 people who said Britain were female. So we don't have a total column this time, but we've got 11 were female. So down the female that said Britain, we've got 11 there. And it's told us it's out of 32, so it's told us that these 2 here have to add up to 32. Okay, I'll just leave that there for the moment, we'll deal with that in a sec. Then it says 8 males said Italy. So in the Italy column, in the males one, we've got 8 there. There we go. And 12 people said Spain. So again, let's have a look. That says these 2 have to add up to 12. Okay, right, that's that dealt with. Right, okay, so it doesn't quite look as nice. I'm trying not to be a favouritist towards the two-way tables, but I do much prefer a two-way table for this particular type of topic. But as I said, we do still need to know how to use these, so we're going to keep going with it and see what we get. So obviously we've got the 2 circles there for Britain. Let's just highlight that, and they've got to add up to 32. Now the one down the bottom there is 11, so the one at the top has to be 21. There we go, and that makes sure that they add up to 32, and we've dealt with that bit of information there. Let's see what else we can figure out then. So we've got 38 males. So let's have a look. They've got to add up to 60, the circle before it. So that is going to make an extra 22 there for the females. Next bit of information, let's have a look at what we can figure out. We can figure out this box here, okay, because they've got to add up to 38, those three boxes. Now at the minute we've got 21 and 8 in the males branch there. That adds up to 29, so we need an extra 9. There we go, that makes sure that that adds up to 38. And obviously we've got this information here that they both have to add up to 12. We've now got the 9, so that has to be 3. And then those three boxes on the female branches have to add up to 22. They add up to 14 at the moment, so that's an extra 8. There we go. So obviously now we've got our frequency tree done. It says one of the females is chosen at random. Okay, so, and again, let's have a look. Let's just highlight this. The female box is out of 22. And it says what is the probability that they choose Spain. There we go. So Spain is the 3 just there. So we just use those two numbers, 3 out of the 22. Okay, so again, very similar to what we did before, but obviously we were using a frequency tree instead this time. Okay, so the next one, we've got a lot of information here. So it says Sophia asked 50 people which drinks they like best from tea, coffee and milk, and all 50 people that she asked liked at least one of the drinks. Then it starts to talk about all these different ideas about what drinks people liked and whether they liked all three, whether they liked tea and coffee. So we're going to go through all of them there, but ultimately it says she selects at random one of the 50 people, work out the probability that this person likes tea. So we need to figure out from all this information how many of the people there like tea, and it doesn't explicitly tell us how many like tea. So when we've got these three options like this, the best way for us to organise this is in a Venn diagram, and specifically a three-way Venn diagram. So we need to draw, I'll do this as best as I can, a Venn diagram that's going to allow us to have three elements in there, and you just need to make sure with a Venn diagram you draw your little box around the outside. There we go. Now I want to keep this all nice and neat and tidy, so I'm going to label them. I'm going to call this one the milk, this one the tea, and this one down here the coffee. I'm just going to go through the list and just start to tick things in when I know that I've got them there. Now the first piece of information it tells us, and if we go through this step by step, it says all 50 people like at least one drink. So that means we know that there's going to be nobody in the outside, so 0 on the outside. Next thing we've got is 19 people like all three drinks, and that's a key piece of information there because we can definitely put that in straight away. The people that like the all three are right smack bang in the middle there, so we've got 19 in the middle. So we've dealt with that one, and you can tick them off as you go or highlight them. So that next one says, it says 16 people, I'm going to swap to a different colour here, it says 16 people like tea and coffee but don't like milk. So the people that like tea and coffee are going to be in the crossover between the T and the C circles, but they do not like milk, so that's fine, we can put them in there, 16 that like tea and coffee but do not like milk. There we go, tea and coffee but don't like milk. It then says 21 people, let's try swap to another colour. 21 people like coffee and milk. Oh, I'm just going to get rid of that because I've got too many things going in there. I've got 21 people like coffee and milk. So 21 people that like coffee and milk. Well, let's have a look. Coffee and milk is this crossover here, but also includes that 19. It doesn't say 21 people like coffee and milk but don't like tea. So if 21 people like coffee and milk, well, we've already got 19 in there that like coffee and milk, so that's going to be an extra 2 that makes that up to 21 there in that little crossover with coffee and milk. 19 of them also like tea, but then 21 in total like coffee and milk. So that's that one dealt with. How many have we done now? We've done all 4 of those. There's lots on here. On to the next one. We've got 24 people like tea and milk. So 24 people like tea and milk. Let's have a look. Well, tea and milk is this one here. But again, it doesn't say that they don't like coffee. So 24 people like tea and milk. 19 are already in there. So that's going to be an additional 5 people there. And that makes up 19 and 5. That's 24 people in total that like tea and milk. On to the next one. We've got 40 people that like coffee. Well, we've already got 3 people in our coffee circle there. We've got the 2, we've got the 19, and we've got the 16. So in total, that adds up to, let's have a look, 2 plus 19 is 21, add the 16 is 37, and it says 40 people like coffee, so that's going to be an extra 3 that make that coffee circle up to 40. Next one, this one's a nice easy one to finish. We've got 1 person likes only milk. So in the milk, we've got 1 person and then we're given no more information. But there is this missing number here in the t. Now just remember, it did say in the question that she has 50 people. So if we add up all the numbers we've got 1 plus 5 plus 2 plus 19 plus 16 plus 3, and all of that adds up to make 46. And in total we have to have 50 people in our Venn diagram. So just in the t one there, that's an additional 4 people to make sure that we have 50. So we just did 50, take away 46, which left us with those remaining 4 people. So we filled in our Venn diagram. Now it says Sophia selects at random one of the 50 people, work out the probability that this person likes t. Well, that doesn't say just likes t, it says the probability that they like t. So we've got a few of the numbers here that we can actually consider. We've got the 4, the 5, the 19 and the 16. So the amount of people that like t, if we add them all together, 5 plus 4 is 9, plus the 19 is 28, plus the 16, what does that give us? 19 plus 16 plus 5 plus 4 gives us a total of 44 people that like t. So there's 44 people that like t out of a total of 50 people, so it's 44 out of 50. 44 of those 50 people like t, and the rest don't like tea. You've got the one person that only likes milk, you've got the 2 people that like milk and coffee, and the 3 people that only like coffee. So 44 over 50, and you don't need to simplify that. And that's our Venn diagram done. Just make sure you go through and tick them all off as you go so you haven't missed any. Let's have a look at another one of these. Okay, so this Venn diagram is a little bit more complicated. It says 82 students were asked what their favourite fruits were. 39 like apples, 50 like bananas, 39 for oranges, 21 like apple and bananas, 18 like bananas and oranges. And we've got some more information there, but the one we're looking for is the amount of people that like all of them, and this doesn't actually tell us the amount of people that like all of them. So we're going to have to take a little bit of a different approach here, but it does say how many of the students like apples and oranges but not bananas, so we're going to look for those people in a sec. Now if I draw a little Venn diagram for this one again, I'm going to need a little bit more space. I might actually make that a little bit bigger. Let's make this one a bit bigger. Okay, so we've got our Venn diagram, again, nice little box on the outside, and let's have a look at what needs to go in here. So 82 students were asked what their favourite fruits were, so we know that 82 people are going to have to go into our Venn diagram. Now it says that we've got lots of different bits of information, haven't we, here? So let's just label it up so we can keep it nice and clear. Apples, bananas, and oranges down here, not to mistake that for 0 people there, that's oranges. Now we don't know how many people are in the middle, so we're going to apply a little bit of algebra here. I'm going to say, okay, well there is an amount of people in the middle, and we'll call that x. Now we can start to have a look at some of the other bits of information. I'm going to disregard the apples, bananas and oranges bit to start with, but what I am going to do is just label that up here just so I remember. So apples is 39, so we know 39 in total in that circle. Bananas is 50, so we know there's a total of 50 going into that circle, and oranges is 39, so we know there's a total of 39 going into the oranges there. Okay, so I'm going to tick those all off. I've drawn them on my Venn diagram, I'll remember that later. Now it says, there we go, 21 liked apples and bananas. So 21 like apples and bananas. So that is going to be 21 in total, including that crossover that's going in these 2 just here where the apples and bananas cross over. So if I knew what the middle number was there, I'd do 21, I'd take away the value of x in the middle, but I don't actually know what x is, so I'm just going to write in here that's 21 minus x for that one. Okay, so that's that one done for the moment in terms of algebra. Then we've got 18 that like bananas and oranges, so bananas and oranges is just here. But again, we don't know what that middle one is there. It doesn't say that they like bananas and oranges, but not apples. So that's going to be 18, take away the middle number, which again is x, 18 minus x. Onto that last one, we've done this one now. So 19 liked apples and oranges, and again, that's this one here, apples and oranges. But again, we don't know the middle number, so we'll call that 19 minus x. There we go. So there's our bits of algebra. Let's tick that off. And then it says 22 like exactly 2 of the fruits. Now the people that liked exactly 2 of the fruits are the first one we did, 21 minus x that like apples and bananas. We've got 18 minus x that like bananas and oranges. And we've got 19 minus x that like apples and oranges. So what we can actually do is we can create a bit of an equation here. Now if we add those all together, that has to equal 22 because it says 22 here liked exactly 2 of the fruits. So if we add them all up, let's have a look, let's just add them all up. We've got 21 minus x, we've got 19 minus x, and we've got 18 minus x, And if we add them all together, let's see what we get. So 18 plus 19 plus 21 gives us a total of 58. So we have 58 minus 3x's, so minus 3x. So actually we can create a bit of an equation here. I'm running out of space a little bit, so I'm going to do it over here. But we have this equation, we've got 58 minus 3x, and it says it has to equal 22 people. So actually we can just go about solving this now. So actually what I can do, and we can rearrange it if we like, but I'm just going to minus 58 from both sides. So 22 minus 58 gives us negative 36. So we have negative 3x equals negative 36. And if we do negative 36 and divide it by negative 3, that gives us a value of x, which is 12. So we know that x, that one in the middle now, has to be 12. So actually what we can do, we can start to get rid of some of these numbers and actually, get rid of some of these x's and replace them with numbers. So if I get rid of the x in the middle, and we'll replace that with the 12, because we now know that 12 is in the middle. We can then do 21 minus x above that, which leaves us with 9. So we can get rid of 21 minus x. Oh dear, got rid of the whole circle there. We can get rid of 21 minus x, and we can just put 21 minus 12, which is 9. So there's 9 going in there. We can get rid of 19 minus x. 19 minus 12 leave us with 7. So we can get rid of that. We just got 7 in there. And then we've got 18 minus x on the right there, and 18 minus 12 leaves us with 6. So we can have 6 in there. There we go, 6. Now we might be able to answer the question from here, but let's go ahead and fill in the rest of the Venn diagram as well. So we know that in A, there's 39 in total, and we've got 9, 12 and 7 that's already in there, and 9 plus 12 plus 7 is 28. So we need an extra 11 in the apples there to make it up to 39. Moving on to the bananas, again we've got 9, 12 and 6, and 9 plus 12 plus 6 is 27. We want to get to 50, so that's an extra 23. And then in the bottom one, we've got 7 plus 12 plus 6, adding up to 25. We need 39 in there down the bottom, so that's going to be an additional 14. Right, there we go. So that's our Venn diagram filled in. Now the question said, not to forget what it was actually asking us here, it said how many of the students like apples and oranges but not bananas? Now the ones that like apples and oranges but not bananas are here. Let's highlight it. These ones here like apples and oranges, but they don't like bananas. So we've got 7 people there. So we've got a total of 7 people out of the 82 people in total, and that would be our final answer. There we go. So you can apply this to a Venn diagram that's not a triple Venn diagram where you've just got a normal two circle Venn diagram as well, but when it doesn't give you that crossover number there, you do have to think about how you can apply algebra to this. So that's quite a complicated one there, but just a little example of how you can approach some of these harder Venn diagram questions. Okay, and on some probability here, it says there are 5 red pens, 3 blue pens and 2 green pens in a box. Leah takes at random a pen from the box and gives the pen to a friend. Leah then takes at random another pen from the box, work out the probability that both pens are the same colour. So we can do this using a probability tree, but there are 3 things. So I'm going to have 3 branches here, and it can get quite messy. So we've got red, we've got blue, and we've got green. Now in total there we've got 5 red pens, 3 blue pens and 2 green pens, and in total that adds up to 10 pens. So this is going to be all out of 10 pens here. So the probability of getting a red is 5 out of 10. The probability of getting a blue is 3 out of 10. And the probability of getting a green is 2 out of 10. Now it's up to you. We can do all 3 branches coming off these if you want for that second pick. It says she doesn't replace it. So off each branch you've got red, blue, green, red, blue, green, and red, blue, green for the bottom. But really, we're only really concerned here about the same colour. So I want to know what's the probability of red on the second pick if we take a red, what's the probability of blue here if we take a blue, and what's the probability of green down here if we take a green. Now if we think about this, there are 5 red pens in the box. So if we were to take another red pen, that would reduce down to 4, so there would only be 4 red pens left, and now there'd only be 9 in the box. So we don't need to fill in every branch on the tree here. We've still got 3 out of 9 for blue, and we'd still have 2 out of 9 there for green, but I only really care about the probability of getting another red at this point. Moving on to the blue branch, so down here, we have 3 blue pens in the box, so if we take one out, we've now only got 2 blue pens, and again, that's going to be out of 9. So that's the probability of getting a blue if we took a blue on the first pick. And then the final scenario down here, if we took a green on the first pick, we'd only have 1 green left, and again, there'd only be 9 in the box, so that'd be 1 out of 9. So there's the probability of getting this second colour when it's the same. So just like normal probability trees, we just need to work out these three probabilities here. So for the first one, we'd do 5 over 10 multiplied by 4 over 9, which is nice and easy for us to do, times the top is 20, times the bottom's 90. Into the middle, we've got 3 over 10 multiplied by 2 over 9, and again that's going to be over 90, but with 3 times 2 on the top, which is 6, and 90 on the bottom again. And then the final one, we've got 2 over 10 multiplied by 1 over 9, and 1 times 2 is 2, and again 90 on the bottom. So there's our three probabilities. We've got the probability of getting red red of 20 over 90, blue blue would be 6 over 90, and green green would be 2 over 90. So when we want to combine all of these together, all we have to do is add them all up. So add all of these together to get our total probability. Let's just put some plus signs here. And 20 on the top, plus 6 is 26, plus 2 is 28. So our final probability there would be 28 out of 90. And again, you don't need to simplify that. So that'd be your final probability. There you go, a little bit of a trick there. When you are constructing these trees, if you only need certain branches, then you can just kind of ignore the others, but just be very careful what the question's asking for, because it could have asked us for different colours there. Just on a side note, if it did ask us for different colours, that would have obviously been the other 6 branches, but you can also save your time just working out the 3 that we don't need, and then we could take that numerator there, 28, away from 90. So the probability of different colours would be 62 over 90. What's left over there, different colours. Okay, that would be only though if it said different colours, and this particular question did say the same colours, so just be careful, but you could save yourself a bit of time. Rather than working out all 6, you could just work out these 3 and take it away from 90 for your numerator. On to the final question here on probability trees. It says there are 4 red counters and X blue counters in a bag. 2 counters are removed from the bag, and the probability that both the counters are taken is blue is 1/3. Work out the value of X. Now, with the tree here isn't so nasty to construct, but we have got some algebra going on in the tree. Now, what it says is there are 4 red and X blue. Now, so for the total amount of counters here, we don't actually know what the total is, but we could write it in terms of algebra. If we knew the amount of blues, we'd just add it to the amount of reds, so we could say it's X plus 4 is our total, and that's going to be our denominator on our tree here. So if we just construct 2 branches for our tree, we've got red and we've got blue, and the probability for red there is going to be 4 out of X plus 4, and the probability for blue is going to be X over X plus 4. Now again, really, the only part of the tree here we're actually considered, we want to consider is the probability for both of them being blue, because it says the probability that both counters are blue is 1/3. So I don't really need to do the whole tree here, I just need to have a look at this probability down here, and that would be if I took a blue on the second pick. But again, I'm actually just going to go and construct all the branches here so that we can just discuss them, but we only actually need the one at the bottom. Now, if we took a red, that would reduce our amount of reds down to 3, because there are 4 reds in there at the moment. So if I imagine that we've taken a red out, we would only have 3, and that would no longer be over X plus 4, because one of them's gone, so it would be over X plus 3, reducing that denominator by 1 again. Onto the blue branch. If we take one of the reds out, obviously none of the blues have actually gone, so we've still got X blues, but that is going to be over X plus 3. Again, all the denominators are the same. Onto the bottom half of the tree, if we took a blue out on this bottom half, the amount of reds would be the same, so we would have 4, still over X plus 3, because we've lost one on the bottom, and the one that we're really concerned about here is this bottom one, which is if we took a blue out. Now, we don't know how many blues there are, so we'd have to just say, okay, well, that'd be X minus 1 counter over X plus 4, and that's how we can construct a probability tree using algebra here. Now what it says is, it says that those probabilities down here, so the probability of getting a blue and then getting another blue is 1/3. So when you times these fractions together, it says they're going to equal 1/3. So if I try and get rid of a lot of this tree here, because we're only really concerned about these bottom ones, let's have a look at what we're left with. So these are our branches. So we can actually do the working out for this. Now what we're saying is X over X plus 4, the first probability, multiplied by X minus 1 over X plus, I just realised I put plus 4 down there, that should be a plus 3. Oh dear, let's change that. X plus 3, there we go, because we took one of the counters out. So X minus 1 over X plus 3, and it says that all of that equals 1/3. Obviously I've got limited space here, so I'm going to get rid of that tree now that we've corrected that denominator, and we've just got to actually work out all of this algebra here, and we've got a bit of an equation. So if we go about working this out now, if we multiply these fractions together, multiplying the numerators, x times x minus 1 gives us x squared minus x. And if we multiply the bottoms there, we have a double bracket to work out. Okay, so you can imagine these are in a double bracket. That first one was like a little single bracket, x times x minus 1. So if we multiply out the double bracket here, we get x squared plus 4x plus 3x, which is plus 7x. And 4 times 3 is 12, so plus 12. And it says that equals 1/3. Okay, so from here, we've got to cross multiply to get rid of these two denominators. So I'm going to times the denominator over here up to the 1, and the 3 up to the other side there. So timesing both sides by 3 and timesing both sides by this quadratic on the bottom, the x squared plus 7x plus 12. So if we do that, I'll write this out as like a step you can see to start with. We'd have 3 lots of x squared minus x equals 1 lot of, so I won't write this in a bracket, but 1 lot of x squared plus 7x plus 12. And now we can actually go about solving this. So obviously we need to expand this bracket out to start with. So by times these both by 3, and we get 3x squared minus 3x equals x squared plus 7x plus 12. Now, just like with all quadratics, we need to make this equal 0. So I'm going to move everything to the left-hand side. So I'm going to subtract all 3 of these pieces. I'm going to subtract x squared, which would leave us with 2x squared when we take x squared from both sides. I'm going to take away 7x from both sides, which would leave us with negative 10x over here. And I'm going to take away 12 from both sides. We haven't got a number on the left, so it's just going to be take away 12 there. And now it equals 0. Now we can actually go about solving this. So we can either factorise or use the quadratic formula. This one I think does actually factorise, but we can simplify it first. We can divide everything by 2. So if we divide everything by 2, we get x squared minus 5x minus 6, which equals 0. And now it's quite nice and easy for us to factorise there. So I'm going to bring this up to the top. I'm going to factorise it out of the way up here. So factors of 6 are 1 and 6, or 2 and 3. So this actually factorises. Let's do it up here. Open up our brackets. And we want minus 5 in the middle, plus and negative 6 at the end. So the only option in there is going to be minus 6 and plus 1. That would allow us to get minus 5. So we'd have x minus 6 and x plus 1. There we go, we've factorised it, so we've got our 2 solutions there. So obviously you flip the sign, so x is 6, and for here x equals negative 1. So what does this mean in terms of the question? Now it said work out the value of x. This is what we've been doing here, working out the value of x, and x there is the amount of blue counters. Now there can't be minus 1 blue counters, can there? But there can be 6 blue counters, so it has to be the positive value there. X would have to equal 6 as our final answer, because we can't have minus 1 blue counters. So just something to be thinking about there. Right, there we go, and that's the end of probability. Okay, well done for making it to the end of the video. That is the end of this paper 2 revision video, and obviously I will be making one of these ready for paper 3. So obviously keep an eye on the channel, that will be available, and I'll also be posting a video the night before the exam, so you can join me and do some revision with me prior to the exam and hopefully pick up some of those extra marks. Otherwise, I do wish you the best of luck with paper 2, but I will see you on the paper 3 video.